we've reached an inflection point. We're at that point in the course where the majority of our app is now running, but we need to supply it with data. So far, we've been working with mock data, and although it has been great, it doesn't really allow us to create the full interactivity that a real app would give us. And so I have supplied data over here for 4 different cities: Antwerp, Chicago, San Francisco, and Toronto. And this data closely mimics what Google would return us if we were to implement the Google Places API. The shape is very close. The data, however, has been massaged in order to resemble what data would look like if it came back from Google, but it isn't the actual data that Google sends us back. Now, this is because we want to eventually implement Google API later in the course, but for now, we need to implement some shape of information that's going to give us the closest representation of what Google would give us so that we can just, at the end, flip the switch. And by flip the switch, I mean create a request and the rest of our code will just work end to end, so we can turn our app into mock mode and a non-mock mode in order to be able to develop without having data available, or if you're off of the grid and you don't have internet and you want to refine some UI. So that is what we're going to be looking at here. And that is very important in terms of the longevity of our app and the ability to kind of build out features and functionality without internet or connectivity, or just putting our app in a mock mode in general. This is a very important step, even if you're in the industry. If you're in the industry, the software industry, you come across these points in building an application where you may not have availability of an API, or you may not have availability of a service. And so you need to kind of work around that. And so mocking the responses is a good way of going about it. And so oftentimes what you'll see is people will hook them up directly into the features. That feels right? Like in the restaurant screen, we just do, the API call directly to Google or whatnot. Well, I like to I call it pushing it to the edge of the application. And so what we're basically going to do here is we're going to make sure that anytime we're trying to get information from somewhere, it's in the same place. So we're going to be isolating how we talk to servers. And the way that we do that is through a pattern called services. So we're going to create a folder called services. And this folder is going to be where all of our logic around talking to external services happen, whether it be Google, whether it be Facebook, whether it be anything else, Firebase or whatnot. Here is where we are going to be talking to servers. So in services, what we want to do is we want to create a new folder. And the services, naming them is also kind of specific to what you're trying to achieve. So one of the services that we have is the restaurant service, right? And its main purpose is to get us restaurants. And so in that restaurant service, that's where we're going to put a new folder, and we're going to call that mock. So this is going to be our mock restaurants. So what we also need in here is 3 things. We need restaurants.service.js, and we need restaurants.context.js. These are the 2 files. So we're going to have our mocks, our context, and our service. And these are going to serve us to get information. So first of all, let's take our mock information and put it in the mock folder. And so by doing that, we now have all of our mock information available to us. This mock information is coming from these files, and the mocks are structured by longitude and latitude. So based on position on the map is how we will retrieve the specific information for these. And we have mock images for the restaurants that we will randomly select. So with this mock information, we're ready to set up 4 different cities for us to request restaurants from. And all we need to do now is build out the service and the context. Now, what do I mean by context? Well, by context, I mean React context. So every service is going to be linked to a React context. And as I said before, context provides a way to pass data through the component tree without having to pass props down manually at every level. So we're going to use context to basically allow us to, first of all, fetch the information that we need to fetch, right? Getting the information we need to get, but then also giving the ability for any level of the application to consume that information. And in this case, the information we're going to retrieve are the restaurants from these specific cities. And then we're going to be able to pass it around through context. So you have to think of it this way, right? If we looked at it from a perspective of like the actual implementation, we would have the cloud over here, right? This is a cloud. Let's say this was Google, right? And our application is all the way over here. Well, now we're saying for our application to talk, we're going to create this services layer, right? Service. This is an S, service. And this is going to basically be what's going back and forth with the cloud, with Google. Now, the service right now is using mocks in order to go back to the application, right? So the application talks to the service talks to Google. In this case, it's actually going to the mocks, and the service returns information to the application to visually represent everything. Okay, now the way that the app gets the information from the service is the app is using React, and React has something called context, right? Context. The service is feeding the information to the context that is actually feeding it to the application. So this isn't a direct relationship. The service gives the information to the context, and the context gives the information to the app for the visualization. And we're using context because the app can reference through React context globally. So let's see how that implementation works end to end. What we just discussed here can become a bit confusing. So I want to boil it down in a diagram that will help simplify what exactly it is we're doing when we're adding data. In a normal circumstance, when we're talking about talking to Google, what our phone is doing in actuality is going to Google and asking it, hey, give me some of your maps information. And by doing that, what Google will send back is the information about the restaurants and the location. Now, in actuality, how we're building this out is as follows. Our phone is having an application that's built in React Native. React Native is built in React. And so when we determine that we're going to work with any type of data, in this specific situation, because it's global data, because the restaurant's data is global data, what we're saying is that in React, we're going to leverage something called React Context. And we're going to build a service layer consisting of these two parts, a service and a context. The context serves to share the data globally within the React Native application, and the service itself stems to determine what methods we want in order to get data from the external service. So the service file operates as a layer in between the context, the React Native application, and the external service provider, in this case, Google. And what we're doing on top of that is we're saying, well, right now we can't really implement the Google API call. There's way more that needs to go into that. So what we're doing is we're faking it. We're not really integrating against Google, but we're having local files that have the information that's structured in the same way that Google would send us back information, but we're storing them locally on the phone. And that way we can build our implementation as if we were talking to Google. And later on, when we actually do talk to Google, it's going to be a question of just switching some things around because the way that our app understands the information is already there. So to boil that down, in reality, if we're talking about a Google integration, our phone talks to Google. But in our implementation, since we're using React Native, we're going to be using the React context. We're going to have a service file that's going to operate as an intermediate between our app and the external service. In this case, we're going to mock the external service. We're not going to make it as if the external service is real. And to do that, we need to build out this service-oriented architecture, this service layer. And for every subsequent feature, we will be using something relatively similar, although we might change it up a bit based on the situation. Now that we understand this, we can get into building out our mock implementation of talking to the Google Service API. Let's start off by building our request. So first off, in our restaurant service, we're going to have const restaurant request. And this is going to be a request to get restaurants, right? So anytime you do this, you need to think, okay, what does my restaurant request need in order to get the information for the restaurants? Well, the first thing we need is the location. And so by getting the location, we'll be able to retrieve whether or not it's Toronto, Chicago, or anything else. Now, if we go look at our mocks, they're based on a longitude, latitude. So this is a position on a map. And so that is going to be the location that we'll be requesting by. So anytime we get a location, and so we'll put our default location to San Francisco. Just for now, we'll say that in the service, the default location is equal to San Francisco. What we can do inside of here is we can say, okay, well, I need to import my mocks, and I need to import those from /mocks/ we can do index, or we can just do this, which will pull the index. So now that we have our mocks, we can console.log mocks. Okay, so how do we run this? Well, first of all, we can't really run it right now because we don't have any availability. We haven't imported this anywhere. So the way that we can quickly and easily test this is we can, for instance, import it at the top level. So we could say like import something like import restaurants request, and then we could say from, this is not the final implementation, but this is just for us to like see what's going on, /source/services/restaurants, and then we'll do restaurant service. And over here, we have to make sure that we export this, right? Because we're importing this specifically. And so now we can go to our terminal and we can see what is going on here. So when we run this, what we can see is all of the mocks that are available, and they're massive, massive, massive objects. So if we were to say that we wanted a specific mock, we could take our location and we could say, let's console log our location. So our location is this, and we know that this massive object takes the location as a key. So if we did mocks location, we should get an object, right? And surely enough, we do. And we know that it's San Francisco because of the places that are coming back from it. So with that, we now have a mock of a location. Okay, so we have a mock of a location. And so with that mock of a location, we now know that we can pull specific mock information from specific spots as long as we have the right key. So our mock information is already set up for us properly over here. So in this case, what we need to do is whenever we do an API call, it's going to be something called a promise. And a promise is something that you have to await. It's something that runs asynchronously. It's something that happens in the future. And so because we want our request to mimic as close to a real API as possible, what we need to do here is, well, the mock's location returns almost immediately because it's local, right? So we have to mimic as if it was a promise. So we'll return new promise, and then we'll do a new promise takes a resolve and a reject function. And what we'll do is we'll go inside the function of this and we'll say get the mock. So const mock is equal to mock's location. And then we'll say if you don't have a mock for this location, reject and say no location, not found, right? Not found. That's the first thing we got to do. And then once we do that, it becomes pretty easy. If we do have a mock, we'll resolve the mock. Okay, so now that we have this, what's going to happen over here is, what is our console log going to give us? Well, this is now going to be a .then, right? So anytime you create a promise, it is now .denable. So it's awaiting something in the future. This is a way of basically saying our restaurant request is not going to return immediately. It's going to return sometime in the future. So we're doing .then, and .then returns us the result as an inner function. So by doing this syntax, we'll be resolving the inner function and we'll have the result. And if we then do .console log result, we'll retrieve the result now. So now we can see that we have our result again. So we're getting the actual return of San Francisco information. Now, if we did .catch, we could see what would happen if we got an error. So if we got an error, console.log error, right? We would see what would go on if we actually got the error. So if we filled in a location here that doesn't exist, like something random, what we're going to see over here at the bottom is an error case happen, right? Error. Now, what is the error? Well, the error is not found because it can't find this location. This does not exist. So with that, we have to know now that we're mimicking a real API in a very, very simple fashion. Okay, so in the next video, we'll look at the shape of the data and what it's returning us. For those of you who are new to promises, I wanted to put together a quick refresher to explain exactly what promises do. You see over here in the function app, the component, we have a const myPromise, and this is equal to a new promise. New promise is a keyword. It's a keyword that is used to define a promise. Now, a promise is kind of like a binding contract. You're promising that you're going to get something back in the future. And so it's a very simple interface. You say new promise. This will return a function internally that has a resolve and a reject function. And then if we hit resolve, we'll return my local promise result. And if we do myPromise.then, in the inner function, in the inside, it defines a function, right? This function in the .then returns us the result that we were promised to get back at a later phase. And so over here we can see local promise, my local promise result. And this is the basic interaction that promises do for us. It's a promise that something will come back in the future. Now, to that extent, we're using local promises to resolve local variables, right? Here, we're not really getting anything from anywhere externally. Now, there are certain functions out there that work with promises. Fetch is one of them. Fetch is a standard that is built into every browser. And what Fetch does is it is an interface around promises that wraps the ability to talk to external APIs. So if we did, for instance, fetch http://jaceholder.typecode.com todos 1, and we did .then, then our response would come back as a JSON object. A JSON object is a simple JavaScript object that returns properties. Now, anytime we're fetching JSON, when it's returned in a JSON format, we'll do the following interaction. We'll do a .then response equals response.json to parse the JSON. And then we'll do another .then where we get our actual response and then console log out the response. So here you can see that I'm getting todos number 1 from jsonplaceholder.com. And in my logs here, you can see that that returns me a user ID, an ID, a title, and a completed. So this is the basic interaction of how promises interact and how we can use them to call external services. And that's our quick refresher on promises. As promised, we're going to be looking at the return data. The return data being the data that is being returned by the API. So if we look over here, right, in the mock folder, and we look just at the data that is being returned, we can see here that everything is underscored. So for instance, we have viewport, location, geometry, northeast, lat lang, that all looks okay. But as we go down, when it's a multiple word thing, like opening hours, it's underscored. Open now is underscored. Place ID is underscored. HTML attributes, photo references, all of this stuff that is multi-word, user rating total, it's all underscored. And so this is not something that we usually want to use in JavaScript because we don't want to do something like well, result dot and then user underscore rating underscore total. We like camel case more. So one thing that we prefer is, for instance, something like this: user rating total. Now, I hear you thinking, Mo, how are we supposed to adapt what comes back from here to match that case for the underscore words? Well, that's a good question. And for that, what we need to do is we need to use a NPM package, and it's called Camelize. And Camelize is a package that recursively transforms keys to be camel case. So Camelize, for instance, if you took this object fee-fi-fo and beep boop and you camelized it, it's going to return you fee-fi-fo and beep boop. So it takes all of the underscored words and all of the dot slash words and all of the words that are broken up by slashes and dots, and it camelizes them for us. So how do we do this? Well, the first thing we need to do is we need to go to our terminal, and we need to do something called, we need to create a new terminal, and we need to say yarn add camelize. And so that's going to allow us to use this package, right? And the way that we use it is we import camelize from camelize, and then we can just wrap our result in it. So if we wrap our result in it, what we're going to see here, if we go to our terminal and we go to node, what we'll see is we'll actually be adapting the information to be camelized. So if we console.log our result here, we seem to be getting an error in the render method of this. But if we quickly open our and reload, what we're going to see here is our returned information, right? This is after we ran camelize. And what we can see is opening hours is now camel cased. Open now is now camel cased. And all of this information is now camel cased. User rating total. If we compare that to what we were seeing in our mock data, right? In, for instance, Antwerp.js, if we look at that and compare it, user rating total is not supposed to be like this. So if we go look, we have price level, plus code, all of that stuff, open now, opening hours. So all of that stuff is being translated, right? User rating total is normally like underscored, and now we see that it is camel cased. So this is an optimization that allows us to create consistency for the information coming in, because you never know how your API is returning you data. On the back end, they may have different principles. They may use underscores. They may use dots. You don't really know how they're going to return you the information, but you want to create consistency for your application. You don't want to be going through your application doing result dot, and then one API is returning you something with underscores, user total rating, and another API is returning you like result dot user total with an uppercase U, and another API is returning you. You want everything to be the same. So that's why we use camelize. And a way that we implement this is we usually have something called a restaurants transform function. And that's going to take the result and it's going to do things to the result. So what it'll do to the result in this case is it'll return camelize of result. And the way that we do that is usually we take this, right? And we do a dot then and we say restaurant transform. And then we can do dot then and we can say transformed response. And we can say console.log of the transformed response. And then we'll have the transformed response properly transformed for us in the terminal. And so that allows us to kind of create this chain of events that is happening. So when we do our restaurant requests, when it comes back, hey, transform it, camelize it. And then once we have that, we have our transformed response, and we can start working with that transformed response in case we wanted to change any properties or do anything special to it. But if we wanted to do anything special to the results, usually what we would do is we would camelize it ahead of time. and then we would kind of transform it that way ahead. So we would do something like, okay, const new result, right, is equal to camelize result, and then we would say return new result, and we would potentially like say, okay, well, new result dot some extra property is equal to new, right? We could add properties, we could remove properties, we could do all types of things here in this transform function to make sure that the response that we're getting back is going to be what we require. So in the next video, we'll look at what additional properties we need. Now that we have our request and our transform function down, one of the things that we really need to look at is more or less the component that we built. So in the component we built, we had these two properties, is closed temporarily and is open now. Now these are properties that if we go look at our actual data, right, our mock data, we don't really have an is closed temporarily, right, or an is underscore closed temporarily. What we have is an opening hours and then an open now property on it that's true or false. And the same is true for closed. We have a business status, which is equal to closed temporarily. So in this case, what we have to do is we have to do a transform. And that transform is part of this. So camelize is the first part of this transform. But in order for us to actually figure out what needs to happen, we need to first and foremost map the result, right? So what is the result? Well, the result that we're trying to get at here is an array. So it's the array of results. Okay, well, good to know. So first of all, what we need to look at here is our result has a result.results.length. And if we open our terminal over here, what we'll see now is that it has a length of 20. So that is the actual restaurant results. Okay, good to know. So we know that result has results on it, and we'll default that to an empty array because that's the one that we want. And then we'll know now that we can call results.length, which is 20. Okay, now camelizing will be the last step. Camelizing will be the step that we do from the output. So first of all, let's return results. But what we want to do is we want to say const mapped results is equal to results.map. And a map is a function that will iterate over every individual restaurant and will return us, if we return, like for instance, 1, and we console.log map results, right? Then we're going to see that so 1 second, there seems to be a small problem here. Oh, I put it at the wrong spot. So right here, that's going to, and then we'll console.log. I have to put this in here. I was outside of the function body. And then what we'll see is that at the bottom here, right? What else do we have? Console.logging. So let's remove this for a second. And what we'll see is that we're printing 1 20 times. Okay, so why are we printing 1 20 times? It's because we're returning 1. So what we want to do here is we want to return the original restaurant, but we also want to adapt some properties. So what we're going to say now is that we're going to have a property is closed temporarily. And this is going to check if the business status is set to temporarily closed. So we're going to say restaurant dot business status is equal to closed temporarily. And then we're going to have an is open now as well, is open now. And that is going to say, well, if the restaurant dot, and then we'll say opening hours and restaurant.opening-hours.open now, then we know if it's open now or not. Okay, so what's going on here now? Well, what we can say is that our mapped results have additional properties. Is open now is false because open now is false, and is closed temporarily is false. So we added these. And now what we need to do is we need to take our mapped results and return those, and we're going to camelize those specifically. So we're going to take the original information, we're not stripping it away, we're adding additional properties, and we're camelizing the rest of the results. And so that in itself allows us to look at the information and be assured that the information that we're looking at here is of the right type. So if we scroll up beyond the errors here and I add back my console log down here, what we're going to see is now we have the business status, which is uppercase. So we're leaving the original information, but we're also adding information. We're adding two properties, is closed temporarily and is open now, which are two Boolean flags that we need for the rest of the information. Awesome. So we have our request and we have our transformer. But now the question becomes, well, Mo, how do I utilize this? And that's a good question. So first and foremost, what we need to do is we need to go inside of here and we need to remove this restaurant request because that's not the place that we want to use it. We don't want to use it over here and we don't want to console.log. Let's take the restaurant request. Where is it? Where did I use it? So, oh yeah, because I imported it, it already worked. Okay. So with that, now that we've removed that here and we don't need this anymore because we're going to use this somewhere else, we now have our request and our transform ready to use, but we have to figure out how to use it. So in the next video, we'll be setting up our context, which is going to be doing the request for us and also exposing the data globally. Now it's time to take our request and actually get the data and be able to share it globally. And for that, we're going to use something called React Context. So first of all, we have to import React and use state, create context, use effect, and use memo. And we're going to get that from React. All right. Now that we've imported what we needed, we also are going to import our restaurant request and restaurant transform, and we're going to do that from /restaurant service. Now we need to make sure that both of these are exported, and as we can see, our transform isn't being exported. Okay, so now that we're back in here, we can now see that we have everything we need to start creating our context. So first of all, we're going to export const the restaurant's context, and that's going to be create context. This is going to create a global context for us with React. And then we're going to export const restaurants context provider. And that's going to be the thing that wraps the app and provides it certain state. Now, what we need to do here is we're going to return a restaurant context dot provider. And that's going to be what's wrapping the app. And so at this point, you may be thinking, okay, what is it wrapping? Well, it's wrapping the children. So it's going to be wrapping whatever the children are. So we're going to grab children off of the props. And what we can see now is that, okay, with this basic concept, if we go to app, what we can do is we can say import restaurant context provider from /source /services /restaurant/ and then we'll take the context. And what we'll do with this is we're going to wrap it before the navigation container, right? So at this level, we're going to put the restaurant context provider and we're going to wrap it around the navigation container so that all of the navigation has access to the restaurants. And what we'll put on this context, first of all, is we're going to give it a value. And we're going to say value is equal to, and then we'll say restaurants. And then we'll say it's an empty array, right? We'll say it's an empty array. And so we'll put 1, 2, 3 in here. And what I want to make clear here is by setting up this context now, because we wrapped the app level consideration with the restaurant context provider, what we can do now is we can go inside our restaurant screen and we can import from React use context. And with use context, what we're going to do here is we're going to say in our restaurant screen, return, we're going to open the function body. And by opening up the function body, what we can do is say const restaurant context is equal to use context. And so what we need to use here is we need to import the restaurant context, right? This one. We need to import this. So we're importing this from, and then we're going to go dot dot slash services slash restaurant slash restaurant context. And by importing this, we can now put it in the use context, right? And by doing that, console.logging restaurant context, we should see our restaurants with the empty array value. So, okay, what we did here is we went into app.js and we wrapped it with the restaurant context provider that we created in restaurant context. So this is the provider of this context. And it returns the restaurant context dot provider, and it gives it an initial value of restaurants 1, 2, 3. So this is basically a component that's going to do the majority of the heavy lifting, and then telling the context what it's going to contain as a value. And that value can be passed around along the tree below app.js. Below app.js, we can then go and say, okay, well, use context, the restaurant context. Anything below app.js now can use context of restaurant context. And if it console.logs.context, what we can see, actually, you know what? Let's go ahead and do this. Let's use it in the data, because right here we have all this mock data. So instead of doing this, let's go ahead and do restaurant context.restaurants. And then we should see the amount of restaurants populate that we have set up. So if we reload this, what we're going to see is we have 3 restaurants here now. So it's using the array of the restaurant context right here, 1, 2, 3, 4, 5, 6, 7, 8. So we'll see 8 restaurants populate. So we know now that 1, 2, 3, 4, 5, 6, 7, 8 restaurants are being populated. So this array is now being used by this screen, right? By this screen as the data attribute. So the data attribute is coming from this. And if we console.log that, console.log restaurant context, and we open our terminal here, what we'll see inside of that restaurant context, if we scroll to the bottom, is that array of 1 to 8. Now, this is obviously not the data that we want to use, but we've just set up a context that will be able to provide any level below app.js with the context and the information. So in that context, that's where we're going to do our service call and store the restaurants that we get back, and then have that passed down. And then eventually we'll be able to load up all of San Francisco's data, and you'll see all of these restaurants change. Now that we have our restaurant context provider set up, and we have our restaurant context, and we've proved that when we give the context provider a value of restaurants with an array of 8 items, that we're able to access it anywhere below app.js's level by using context, by using the use context hook. So by using the use context hook, we're able to pull the value from this object. Okay, so now that we understand that, and we've seen it in action, and we see that it applies itself to the actual output of the screen, because if I put this down to 1 item, well, boom, we have 1 item. When I put it to 2 items, 2 items. When I put it to 3 items, 3 items. So it's in effect, this array is now controlling the output of the screen. Okay, so now that we know that that context is hooked up and the app.js file has now provided the restaurants array to any component below it inside of the tree, now we can go ahead and try to hook up our data, our restaurant request and our restaurant transform, right? So the way that we want to do that is we want to set up some state. So we want basically this context provider, this component, we want it to provide the request. So it's going to do the request, it's going to do the transform, and it's going to provide any state that happens to that request. So the end output of this request should be this array, but it's also going to control the interface with the API. So if, we get an error, it's going to be able to provide an error. It's going to provide the information if it's loading or not. So that whole thing is going to be what we're building right now. So there's 3 states that I talked about: the error, the loading, and the actual output. So we're going to say const restaurants and set restaurants is equal to use state of an empty array, because by default, we don't have any restaurants. Then we're going to say const is loading and set is loading. These are the value, and the setter is equal to use state false. By default, we're not loading. And then we're going to say const error set error is equal to use state of null. So by default, we do not have an error. So we have our 3 pieces of state here, and now we basically have to hook them up to be controlled. So how are they going to be controlled? Well, we're going to have the use effect hook. So when this component mounts, when the restaurant context provider mounts, we're going to do some stuff. And the stuff we're going to do is we're going to basically say, hey, when it mounts, do something. Okay, so when this mounts, we're going to do something. This empty array syntax is saying, run the use effect when the component mounts. So when it mounts, we're going to say retrieve restaurants. That's what we're going to call it. Retrieve restaurants. That's what we're going to run. So we're going to define a function here, and it's going to be const retrieve restaurants, and that's going to do something for us. What is it going to do? Well, first of all, it's going to say, hey, we're loading, so set loading to true. And then what it's going to do is it's going to do a set timeout, because we're going to time out, we're going to act like it's a real API, and we're going to wait for our response to come back, because there is no latency on retrieving our local object. So we're going to wait 2 seconds. What we're going to say is, hey, do the restaurant request. We're not going to give it a location. It's going to fall back to its default location. And then we're going to say .then, run the restaurant transform. Restaurants. So I made a small spelling mistake here that may end up costing me. So run the restaurants transform. And then, let's see here, restaurants request. .then, run the restaurants transform. .then, we're going to say, here are our restaurants. And we're going to say, inside of the function body, set restaurants to restaurants. One more thing we need to do is we need to say catch. And then if we get an error, we're going to say set the error to the error. Now, one more thing we need to take into account here is when we do get the restaurants back, we need to set loading to false. And if we get an error back, we also need to set loading to false. Those are 2 important things. Now, restaurants is already declared in the upper scope, so let's call this results. We don't want to conflict with the upper scope here because we're redeclaring a variable that's already known. So we don't want to do that. Okay, so now that we have what retrieve restaurants is going to do, we can say return restaurants as restaurants. Now we can also shorthand this to just be this, and then it will reference this variable. Doesn't really matter what you choose to do. We're going to return our is loading state. So I'm going to shorthand it to say return restaurants, return the is loading state, and return if we have an error. So those are the 3 pieces of state I want. Okay, now that I have those 3 pieces of state, we can go ahead and we can go look at our application right here. And what we can see, it's loading way more restaurants. So we seem to be getting something back. So if we go inside of here and we say console.log restaurants, we're going to see the different states that restaurant is going through. And if we open up our terminal, we'll see that restaurants is getting our entire restaurant array. Now, if we reload this, you'll see that there's a little bit of lag on it coming in, 2 seconds. right? 2 full seconds. That's what we put down. So we'll optimize that to look nice because we're mimicking as if it was a real API. And what we want to do now is right now we're giving restaurants just the data over here in the screen. So we're saying the data is restaurant.restaurants. And so we can simplify that. We can say restaurants. We'll destructure it off of here. And then we'll say, we'll also get the is loading state. And we'll get the error if there is any. So now that we have our restaurants, what's going on in restaurant list? Well, in render item, we basically get an item. This is what we get. We get an item each time. So if we open this up and then we say return, we can console.log item. And what we'll see is, in the most basic sense, we'll see a singular restaurant coming in. So what we want to do now is we want to go look at what restaurant info card takes in. Restaurant info card takes in a component restaurant. So what we want to do in the screen is we want to say here, restaurant is equal to item. And by doing that, well, now we're getting some weird values. We're getting JSON value, height, etc., etc., etc. Photo cannot be translated. Interesting. So what's going on here is that if we go look at our data, if we go look at photos, photos is giving us an array of objects, right? It's giving us this. Photos, and then it has height, HTML attributions, photo reference, all this stuff. But what we basically want is we just want the URL of the photo, the very first photo. Or we basically want to translate this to properly return us a photo URL. So normally this would return us like a URL in here that would be linked to a photo, etc. And that would be what we want to pull. So we need to edit our transform a bit. So our transform over here in the service takes into account the is closed temporarily. But one thing it isn't doing, it isn't taking into account the translation that we need to do for the pictures. So one thing we should do in here is we should say restaurant.photos is equal to, and then let's just put an array here for now. And if we set restaurant.photos to an empty array, what we'll be able to see here is that we'll be able to render out all of the restaurant information. So now we're getting dynamic information from the restaurant. We're getting the name of the restaurant, the rating of that restaurant. So we're able to basically render out what it's going to be. Now with that, we're getting different icons here. This is a lodge, this is a restaurant, but we're not getting any photos. And so over here in the mock folder, you will have seen that I've put mock images. So there's one thing that I wanted to add here. That is, for us right now, what we want to do is we want to make sure that our photos are randomized. We don't have photos coming back from this API. So let's do restaurant.photos.map, and let's pull in mock images from the mock. And what we'll be able to do here is we'll go and we'll select a random image, math.random, from the mock images. And this will allow us to render out just a specific image. In this case, we'll be selecting a random image from our mock images array here. So there'll be overlapping or similar images based on how the random works. And on every render, the image will be different. But what you can see here is we've just hooked up our data, and now it's randomizing and legitimizing the view. We're seeing all of the restaurants and all of their information happen. And all we did was hook up our context, make sure that our context could get the restaurants from this fetch action over here, from retrieve restaurants. And that allows us to basically be able to get the information that we need, set it, and let's say, for instance, that we retrieved a restaurant that didn't exist, right? So we did give it a location. Now, does it take location as a single property? So yeah, if we did this and we gave it a location that does not exist, it should theoretically give us an error back because the information does not exist. If we went inside of our restaurant screen, what we know now is that we may have an error here. So if we do console.log error, we should be able to see the error coming in. So if we go to our terminal output here and we do this and we scroll to the bottom, we'll see not found because, well, we gave our context a value that does not exist. This is not a valid location. But if we save this, then what we'll see is that our restaurants will come back in and they will load after 2 seconds. So now that we have the end-to-end flow set up to get the information from the JSON files rendering on the screen and dynamically rendering, we can see how powerful the entire setup we went through step by step is, right? Because we set up our restaurant card to take in a certain shape. We set up our context to be able to do the request for us to get the restaurants and then transform that information to match the input that the restaurant card expects. And then in our restaurant screen, all we needed to do was we needed to use the context of the restaurants that already did the API call for us and give the restaurant information to restaurants. And at that point, everything was hooked up because we gave this prop over here. And so now we're getting real restaurant information. Okay, so now that this works, how can we hook up search in order to swap out between the different cities? Well, let's take a look at that. Before we build out search, I wanted to add some polish here because we have our restaurants loading, right? We have it all loading, but the issue is that when we reload, we're not really getting any feedback about if it's loading or not. So one of the things that we can do is we can go look at React Native Paper. And React Native Paper, and if we go look at the docs here, if we look for activity indicator, the activity indicator is this indicator that shows if you are having progress or not. And so an exercise that I want us to go through is I want us to take the usage case of this activity indicator and create an activity indicator that's going to show while the data is loading. So we have our is loading property here. And while this is true, I want us to show an activity indicator in the UI. And so in the next video, we'll look at a solution. Hopefully you built a beautiful activity indicator with an own custom color. I'm going to show you how I solved it. So what I did was I imported the activity indicator and the colors from React Native Paper. And that allowed me to go inside my render function and say, well, I could do two things. I could return early and I could say here, if is loading, and then I could return something else. I opted to render it inside of the safe area view that I already have here. And what I did was I put a conditional in here that said is loading and this would allow me to render something while this was loading. And what I rendered was, there was a couple of options. But what I decided on was, and I'll show you why I did this, is I decided to render a view. And this view that I rendered, let me just get the view from, I'll create a custom view. Well, I'll show you what I basically did. So if it is loading, I would render a view. And that view I would position absolutely. So an absolute positioning means on the screen of the phone, I'm going to position it where I want to position it. So it's absolute depending on this. So the entire screen, I can say, well, render it over here, or render it over here, or render it over here. So knowing that I can just determine where I want to render it, I gave it a position absolute and I said, render it top 50% and render it left 50%. And then I gave it an activity indicator with a size of 50. And that activity indicator, I moved up 25, so half of it. So I deducted half the size of the activity indicator so that it would center itself in the middle of the screen. Because if I didn't do this, it wouldn't. So let me just quickly import view from React Native. Import view from React Native. And then we can go and we can adjust this. So if we import view from React Native, what we'll see here is that if we reload, we're going to see an activity indicator pop up for 2 seconds, right? And it's right in the middle. Let's do that again. It's right in the middle. But if I don't do the margin and deduct half of the size, what we're going to see happen is, it's off center. So a bit of math here to render it in the center. Doesn't really matter where exactly you rendered it as long as you're happy with the position. This is how I would render it in the center. But there are some optimizations we need to make. So we could say const activity indicator. We'll call it loading. We'll say const loading is equal to styled, and we'll give it activity indicator. And then we'll give it a custom style, and we'll say margin left minus 25 pixels. Minus 25 pixels. And that will give us a custom loading indicator. And then we can remove this and we can still give it these properties, right? And then for our view, we'll say const loading. Well, it really depends on what you want to do. So what would we call this? We could call this loading container. That sounds good. Naming things is always hard, honestly. So we'll say loading container, and then we'll give it a position absolute. And we'll say top 50%. And then we'll say left 50%. And by doing that, now we can say loading container here. Loading container. And if we save this, now all of a sudden, we should have a loading container that loads every time we reload. Awesome. We can clean up our styles here. And now we have some interaction while the API call is happening to kind of indicate to the user, hey, I'm trying to retrieve something. Very important user experience. Very important. So now that we have that in here, we've basically tightened up our end-to-end between calling the API and actually retrieving the data. Before we continue down the path of integrating the search functionality, I wanted to give us a quick lay of the land of where we're at right now, because we've made a lot of decisions and we've written a lot of code. But that code creates a specific infrastructure. And so over here we have our phone, right? And we're targeting our phone for Android and iOS. And over here is what we would consider our code base. This is our code that we're writing, and we've structured it in a certain way. So we have our navigation. So our phone comes in, sends a request, and the navigation kicks in. And the navigation has certain features, whether it be restaurants right now or later on search and map. And the features use styled system in order to make up the components and style them for the phone. Now, when we talk about how we're retrieving data, so far we've really supercharged our development, specifically in that area. And that is because the way that the services work is very, very tailored to how the features interact with it. So I wanted to explain the flow here. So when our feature kicks in, right, whether it be restaurants or whatnot, that feature has a context. So we created a restaurants context. And so features, right, the restaurant feature in this case, gets the information from the restaurant context. And that's the array, right, of values that contain the restaurant information. But it also enables the context to do something special, right? The feature is very stupid at this point, right? It doesn't have anything. It doesn't know anything. All it knows is that, hey, I have this restaurant context. So the context is kind of our glue right now between the feature and the outside world. And so we structured this thing called services. And services came with a request and a transform. And the request is the request that we're doing to the outside world to get information, whether it be from Google or elsewhere. It could be any given API. It could be the Weather Channel. It could be anything at all. So our services serve the function of getting that information. Okay, so knowing that, we over here, our React context comes into play. Our feature is dumb. All it knows is at some point I'm going to get restaurants, right? I'm going to get this array of information. And our context is smart. It says, hey, well, I'm the restaurant context. And a context is nothing more than a component, right? We wrap it at a certain layer. It kind of acts like a component, but it's a bit smarter because it can share its state along the application. So the context is smart. And when it mounts, it says, hey, I'm the restaurants context. And I have this use effect. I have this lifecycle hook that's going to tell me, hey, I have a location. And this location is coming in externally, right? The feature is feeding the location into the context, for instance. It doesn't really matter. For this particular use case, we hard-coded the location inside of the context. It doesn't matter where it comes from, but the context itself is smart. It says, hey, I got a location, and so I've just mounted, for instance. I've just mounted myself, or something is updated. And based on that information that's coming into the context, it can make decisions. And so the decision we had it make is we had it call a service, the restaurants service. Now this service is, of course, a mock service. So we're getting back information that's actually already in our code base. But we built our services in a way that they actually act like they're on the internet, right? They have a timeout. They're wrapped in a promise, which is something that has to come back to us. It's not immediately available. So the services act as if they are real API calls. And we structured the service in such a way that later in the course, when we do decide that we want to integrate with an external source, that we can just swap out at the service layer the request, and then the transform and the context should just take over. So all we need to do is formulate a request to an external service, and the rest of our infrastructure will just take over as we set it up and feed the feature with the information it requires. This is kind of the baseline architecture that we have right now. And so now that we know where we are, we can continue down the path of building out the search infrastructure. Before we start building our search feature, I kind of wanted to stop and take a look at, hey, how do search features work? And so if we went ahead and we typed in San Francisco, what would end up happening is this would be translated into a map view that corresponds with this area, right? But what's happening behind the scenes? Well, it's something called geocoding in Google. The geocoding API is an API that allows the process of converting addresses, for instance, a specific address or a city or a town, into geographic coordinates like latitude and longitude, which can be used to place markers on a map or position a map. And so you have something called reverse geocoding, which is taking this and then translating it into an address. But for all intents and purposes, we need geocoding. And why do we need geocoding? Because if we look at the Places API, right? If we get an overview of the Places API, well, when we utilize the Places API, what it is taking as a location, when we look at Places search, it is taking a longitude and a latitude. We can see this when we look at, for instance, how the search would work in an example. So if we look at an example, let's see here. If we took this, right? This is a maps.googleapi.com place nearby search, and then it gives it a location. And the location is taking in the longitude and the latitude, and then potentially a radius, and then you can give it type restaurant and all this other information. So this is kind of what we've been aiming towards, right? If we go look at our code, when we look at our restaurant context, when we look at the way that we structured how this works, if we look at our service, well, our transform aside, when we look at how we structured our mock data inside of index, well, we used longitude and latitude to signify a specific location, whether it be Antwerp, Toronto, Chicago, San Francisco. So we're mimicking the way that the Places API would work for us. You see, in our request, what we're doing is we're saying, give us a location, which is a string of longitude, latitude, that's comma separated. And then we're going to go look for that location. This is no different than actually doing the API call to Google. But the only difference here is because we set it up this way, and because we are setting our service up this way, we are setting ourselves up for success, because when we eventually go to integrate later in the course, in the bonus section where we try to integrate with Google API, what we're going to see here is that it's going to be very easy for us to take this information, like these lines of code, and translate them into an actual API request. Now, you may be wondering, okay, Mo, I get that. Like, our restaurant service works as if it interacted with the Places API. But, right now, our search really isn't doing anything. And that's true. That's because we don't have any geocoding in the app. Like, if we fill in San Francisco into this box, right? If we filled in San Francisco, we have nothing backing us in terms of taking that term, like that search keyword, and then translating it into longitude, latitude. So we need to go and we need to build out a service that does that for us. So that's kind of how geocoding works, right? We're going to take our search term and we're going to translate it to the longitude, latitude that translates to this specific area on the map. Now comes the question, how does this geocoding stuff work? And so to understand that, what we're going to do is we're going to create a new service. We're going to call it location. And inside of location, we're going to create a file, location.mock.js. And that mock file is going to export a certain amount of information from every single city that we want to get information from. So it looks a little something like this. And all this information can be retrieved from the resources folder. You'll be able to pull it from the pull request. Now, if you see here, we're doing export const locations. So these are the locations that we want to have accessible. And again, the information that is in here strongly mimics what Google would return us so that in the end, we can swap out our API call to work with the Google API. But the information in here is not of the same accuracy as what you would get back from Google, of course. So over here, you can see that for Antwerp, it has a results array. And in that results array, there is a geometry object. And in that geometry object, there is a location with a longitude, latitude, and then there is a viewport object. Now, both of these objects are equally important. This will allow us to find the city, right? The city that we're trying to get the restaurants for. And this, at a later stage, will help us configure our map view in order to render out the location correctly on the map view. Now that we know that these are our results, what we can do is, based on this, we can give it each result a key, right? And the key of the object is the key of the city, the search term, so to speak. So we'll have Toronto, Chicago, San Francisco. And as you can see here, I put a space between San and Francisco in order for us to be able to search for it properly. Now, when we hit Google, obviously, it won't really matter because the search term will go to Google, but we're hiding the results inside of the object key. Okay, so now we can go ahead and create our location.service.js. And this location.service.js, what it's going to do is similar to what the restaurant service did, but it's going to work a bit different. So first of all, we're going to get camelize. We're going to say export const location request. And this is going to be a function that does something for us. And then we're going to do export const location transform. And this is going to transform the request for us, right? I need braces here. Curly braces? Curly braces, that's what they're called. Oh, I've been struggling to figure out that word for so long. In any case, the other thing we need is our mock location. So we'll import locations from locations.mock. And this will allow us to get our mock locations. Now, what we need to do is, again, we need to return a promise. So return new promise, and then it gets a resolve and a reject function. And this will allow us to basically mimic as if we were talking to an API. So what we'll do is we'll say location mock is equal to locations. And well, of course, what are we trying to find? We're trying to find a search term. That's what we're looking for, right? Whether it be Antwerp, Brussels, or whatever else, Toronto, Chicago. So we'll do locations search term. And then we'll say if this doesn't have a value, we're going to reject with saying not found. And then if it does have a value, we're going to resolve with that value location mock. Okay, so knowing that, now what we can do is we can utilize this information to figure out, hey, what do we need off of this object? So for instance, if we were looking at San Francisco, well, off of the geometry object, we're going to need location, latitude, and longitude. So how do we go about that? Well, in our location transform, we're going to get the result, and that result is going to be equal to the entirety of this object, the inner object, right? The results. So how do we go about that? First of all, we need to figure out how to get geometry location off of result. So we're going to say const location is equal to result.results, and we're going to say 0 because, again, it's an array, but it only has one value in here, and we're always going to pluck the first value anyways. So we're going to say result.results 0. And then with that, we can console.log location, and that basically would give us the following. If we were to log it out, it would give us this object. So now we know that we need geometry and then location. So we can say, well, if I need geometry off of this, so if we take geometry off of this and then we make sure to default it to an object, what we can do here is we can say get lat and get lang off of geometry.location. So this becomes like a very nested procedure. Now we have to say, okay, const latitude longitude is equal to geometry.location. And then what we need to do is we need to return that lat and lang, and that's going to give us the ability to have the lat lang of what we're trying to get here. Okay, so now that we have both of these, well, there's one more thing we need to do, right? And basically we need to camelize the results. So let's go ahead and wrap result.results inside of camelize, and then we'll pluck 0 off of it. And what that will do is basically, like, for instance, if there was any information in here that was poorly formatted, which it doesn't seem to have, all of the information in here seems to be completely legit and it shouldn't have to do anything, it would fix it up. But just in case maybe the API would add something later on by chance that wasn't camel case, we still want to wrap it with camelize just to make sure that everything comes back. So we could say const formatted response is equal to camelize results. Let's do it like this, and then we can do formatted response and then dot results, and then that way. Okay, so this is looking all right. Now that we have this, now in the next video, we need to look at how we're going to integrate this into the holistic infrastructure, right? We don't have a context for this yet. So let's look at that in the next video. Now that we have our service set up, the next thing we need to do is we need to set up a context for it in order for it to be able to interact with the service. So we need a React layer, basically, that's going to interact with our service. So we make a location.context.js. And in this location.context.js, we import React, and then we are going to import useState from React. We'll also import useEffect and other things later on. But the first thing we're going to do is we're going to import location request and location transform from ./location service.js. And with that, what we're going to do is we're going to do the same thing that we did for the restaurant context. We're going to create two methods. And so I'm going to quickly copy these two lines because it makes it easier. But instead of a restaurants context, we're going to create a location context. And so that location context as well is going to get children. And what it's going to return is it's going to return location context dot provider. And then inside of that provider, we're going to render the children. And then we're going to close this off. And that's going to allow us to interact with the location service. So as well, we need to pass a value to it, right? Just like we did with the restaurant context, we're going to have multiple states. We're going to have is loading. We're going to have error. We're going to have location. We're going to pass a search function, right? A search function that's going to first foremost trigger the search for location, because unlike restaurants where we're going to have a default location and it's going to be able to search every time it gets a new location, in order for us to trigger a search, we're going to do that manually in the search box. Okay. We're also going to expose the current search keyword. And then I guess that's about it. So we need to create state for each and every one of these. So we're going to say const. We can copy a couple of these from over here. Always copy paste what's available. So we're going to say location, and then we're going to say set location. And then we're going to have keyword, and we're going to say set keyword. And we're going to default the keyword to nothing. So by default, there is going to be no keyword. By default, there is going to be no location. By default, there's going to be no error. And by default, we're not going to be loading. Okay, so is this correct? I don't really think so. Our default keyword should be what we're going to be searching for by default, right? Well, no, not really, because we're not really going to be triggering the search from here. That being said, we do want to make sure that anytime we do search, it is defaulted to a current place. So what we basically want to do here is set the default keyword. What we can then do is we can set use effect. Here's the question. Do we only ever manually want to trigger the search function, or do we want to trigger it on load? This is a good question. Well, let's trigger it on load to start with. So on load is a use effect of an empty array. And then what we'll do is we'll have an on search function. And then we'll say const on search equals, and we'll default the on search to set is loading to true. And then we'll trigger a location request for our keyword. And then we'll do a dot then of location transform. And we'll do a dot then of result. And we'll do set location of that result. We'll do a set is loading of false. And what we'll do is we'll do a dot catch where we'll catch an error. And again, we'll do set is loading false. And instead of set error, instead of set location, we'll do set error error. And by doing this, we basically have the error case that we're handling. So now we also need to make sure that when we trigger on search, a keyword is coming in. A search keyword will be coming in. And so we need to make sure that we set the keyword of that search keyword, right? So anytime we trigger the search function right here, it's going to bring us in a keyword. So on use effect, what we're going to do is we're going to trigger on search of our current keyword, which is going to set the keyword to the current keyword on render. Now, one thing to note here is that the ESLint will also warn us when we're missing certain dependencies or when we're using a function that should be changing upon a certain dependency. And so that's extremely important. So one thing to note here is that the location request should happen against the search keyword, not the keyword, because that's referencing the outer scope keyword. And that in itself was causing the error over here, because when this references a piece of state, well, then ESLint is going to warn us to basically wrap our function in a use callback. So one thing to note here is that this should actually be search keyword, and this should, the use effect is missing the dependency keyword, either include it or remove the dependency array. If we remove the dependency array though, what's going to happen is it's going to trigger on every render, and we don't want it to trigger on every single render. That would cause an issue. So in this case, this error is not complete, but in the end, we're not going to be using use effect here. We're just doing it to showcase. Let's go to our app level. What we can do here, we could import location context provider from location context, and we can and location. And so by doing this, we can wrap the tree before restaurant context provider with this and after this. And by doing that, we can now see what is going on in our location context. So let's go over to our terminal, and let's go over to here, and let's just re-trigger opening in iOS because it's currently hanging. Currently my simulator seems to be hanging. So I'm going to do this, and I'm going to close Expo, reopen Expo, and then open MealsToGo. Unknown module 4. Let's reload that. Seems to be having some difficulties loading. What we'll do here is quickly take a look. Sometimes it's good to remove your node modules, reinstall, just make sure that everything's clean, because when things go awry, it's usually due to some state that has broken. So let's just make sure that everything is in a good order, and we'll be back. We're back. We can see that we actually made a small typo here in the locations mock. And so if we reload this, now we should be good to go. And this will allow us to render our application. One thing we also need inside of our context provider is the create context. So we'll do react dot create context. In this case, you can reference all of these variables through React. So now this allows us to kind of look at what exactly is going on inside of our search functionality here. So if we go ahead and we say console log result, we'll see exactly what's in the result. And we can see a longitude latitude object that exactly translates to what we need in order to retrieve the information. And so if we set our search keyword here to Antwerp, that's going to allow us to get a longitude latitude that would be a bit different. If we empty the keyword here, I believe. One thing we would need to do here, just to make sure, console.log, search keyword, and then we'll be able to see. So we're searching for Antwerp, and there's one thing going wrong here, and that is all of our keys are to lowercase. So we need to make sure that anytime we do a location request, we do to lowercase of the search keyword, and that's going to allow us to get the longitude latitude of a different place. So right now, all of our requests are happening, and so like if I typed Antwerp, or if I typed Antwerp, or if I typed Antwerp, we always want it to be all in lowercase, because in our location mock, everything is in lowercase. So we want to be able to match that key. So now that we know the majority of how the context works, how the service works, and how it all interoperates, we can clean up our code here. So let's remove our console logs, because we don't need the logs everywhere. And what we want to do now is we want to remove our use effect here. And I'm going to show you why we don't need this right away. What we need to do right now is we need to build a search component. And that search component is going to live inside of the components folder of the restaurant feature. So we're going to do search.component.js. And so this search component is basically what it's going to do. Blank canvas here. We're going to import React from React. What we need to do right now is we need to go into our restaurant screen. And right over here, we built this search bar and search container. So we're going to copy that out because we're going to build a standalone search functionality that we're going to call search. And it's just going to stand alone, and it's going to talk to the location context on its own. And it's basically going to be encapsulated right here, and it's going to live inside feature restaurant. So we're going to do export const search, and then we're going to declare the function body. And what we're going to do inside of here, we're going to have a search container, which we need to pull out of the restaurant screen. So once we do that, we'll grab it, we'll put it over here. And what we need to do is we need to import styled from styled components /native. And so by doing that, now we have our search container. The one other thing we're missing is our search bar, which we also need to pull out. So we'll take that and we'll put it over here. And so now we basically have our search bar as if it were integrated in a separate feature, correct? Because it's running in its own component folder over here. Okay. So now what we want to do is we want to pull use context. And what we're going to do is we're going to say const search context is equal to use context of, and then we're going to do location context. Now, we're going to call it location context, excuse me. And that's equal to the use context of location context. Naming is important. The variable names are so important. And oftentimes, I'll tell you, so hard. And I'm working on the search feature, and I think I'm using the search context, but actually I'm using the location context that has a search function. It can get confusing, honestly. So what we're going to do now is we're going to import location context, and we're going to import that from ... And then we're going to go into services, we're going to go into location, and we're going to grab location.context. And so by doing that, what we're going to grab is the location context. So if we console.log location context, what we're going to see in here is the ability for us, if we grab this, we close this, and we open our terminal, what we're going to see in here is an error. And that is because obviously we need to import search into our restaurant list. So let's go and do that. So let's do import search, and let's say from ... components /search, and let's save that. And so with that, let's put that, let's group the imports for the imports that are coming from here. I like to group imports together. Just makes it feel a little bit cleaner. So 2 views with the same name. Let's dismiss that. Let's reload here. And what we're going to see is that now that we have this context right in here, if we scroll up beyond our error here, what we're going to see is that we have search, location, keyword is loading, and error. And so because we have all of that information, what we can do now is in our search component, what we're going to do is we're going to start layering it. Like I said, we're going to layer it like a cake. So the placeholder is going to be search for a location. And then what's going to be the icon? Well, let's work on the icon later. Let's say that the value is equal to, we can say we're going to use state here. Use state, and what we're going to say is that we're going to have the const search keyword and then set search keyword, and that's going to be equal to use state. Now we want to move this line down because what we want to do is we want to default the search keyword to a value on location context, and that is going to be, if we go into location context, the keyword. So we're going to grab keyword from here, and we're going to set it as the default, and that is going to be set as the default value inside of the search bar. And by doing that, what we're going to see over here is once we remove our console log, because that's breaking, once we remove that, we can see that San Francisco is being filled in by default. And this is coming from the location context default value that we have over here because we set that to San Francisco. Now let's set it to look proper, right? So we set it by default to San Francisco, and that's filling in here. And so we're tracking local state over here, right? right here, we're tracking local state. Why are we tracking local state? Well, because this component needs to be able to track what the search keyword is that you're filling in, but this one only needs to know once you submit what the keyword is going to be, right? We're going to trigger the search function here at a certain point with a keyword from the search keyword, and that's going to be internally then set from then on to the keyword in the location context provider. So we're having this back and forth between what the component is storing and what the location context will eventually store, but the location context will only store that once we run the search function. Okay, so knowing that, what we need to do now is we need to add some extra properties to this search bar. And the extra properties that we're going to add is we're going to add onSubmit editing. And onSubmit editing is a function that is going to allow us to trigger the search. And so what we're going to do inside of here is this is where we're going to trigger our search, and we're going to trigger it with the search keyword. So when you submit the editing, that's when the search is going to occur. But we still need to set the search keyword to whatever is happening inside of here. So let's say onChangeText, and this is going to be a lifecycle method that is going to trigger every time the text changes. We're going to say every time the text changes, we're going to set the search keyword to text. Now, the one thing we don't want to do is if we don't have text, right? If the text.length doesn't exist, let's just not do anything. We don't really want to do anything in that case. Let's just return, exit early. And so what we can see here, and let's go into our location context provider, and let's just add a quick search keyword trigger here. Let's console.log here. And then if we open up, we close this and we open up our terminal, what we're going to see inside of our terminal is this search keyword updating. So if we scroll all the way to the bottom and then we clear this and we say Antwerp, what we're going to see is Antwerp's coming in. And then if we do Chicago, Chicago will come in to our search context. And then if we do, for instance, Philadelphia, right? Oh, seems to be a small bug here. So we need to be able to figure that out. Philadelphia. What's going to happen is we'll get Philadelphia. Okay, so now we're getting the input from the search box right into our context. But there's still this small little case of a bug here that's basically happening. And this is because, oh, we added this. So this is not something that we want to add. Like the return case here is what's causing this to happen. So Philadelphia is going to happen. One of the things that we need to be aware of here, doing checks, right? It would stand to reason that if text didn't have a length, we wouldn't want to set the search keyword, right? Well, we do still want to set the search keyword over in here. But what we don't want to do is in the location context. In the location context, what we don't want to do is we want to say if search keyword dot length, if that doesn't exist, then we would want to, for instance, say, hey, don't do anything, right? Don't do anything. So here we could do an early return. And what that's going to do is it's going to cause us not to do like an overabundance of API calls, right? So for instance, if we did here Chicago, right? Well, I removed the console log, but that would return Chicago. But now I can easily remove all of the text here, and we're not setting the search keyword. But if I hit enter, I may set the search keyword here. But when it comes into my context provider, well, I'm going to bail out on my search because I don't want to search for an empty location. That doesn't really make sense for me. I'm not there yet. I like, what am I searching for at this point? We don't want to trigger that API call. Now, there's a difference between doing it on the onChangeText versus in the location context. And I wanted to show that because you can inadvertently cause bugs by doing this. Okay, so now we've hooked up our search component as a standalone feature. It's interacting back and forth with the context. It's setting the keyword and then passing it into the search function that eventually will search for the location. And then at the location level, we can console.log our result, right? and then we'll see that we're actually getting back the proper results that we expect. So if we look here at Chicago, we'll see that we're getting something. If we do Toronto, we get longitude, latitude. If we do Philadelphia, what we're going to see is that we're not getting anything. Rather, we may be getting an error. So let's console.log error, and let's see what's going on in there. And so we can see that the back and forth is actually working as intended. So if we do Philadelphia, it's going to say not found. If we do some other place, it's going to say not found. And so that's very important to keep in mind. We have our end-to-end hookup of the flow, and the search component is working. So now what we want to do is we want to hook up what's coming back from this location that we're passing down, and we want to give it to the restaurant context. So let's look at how that would work. Last we left off, we hooked up our search component all the way into the location context. So by triggering a search, we trigger an update in the location context that will go and fetch the location of what we filled in and subsequently track all of the state. And we had console logs to make sure that what we were getting made sense. Now, the next step is our restaurant context is currently hooked up to no location at all. So it's defaulting a location currently in the service, right? Right here, it's being defaulted. So this is not something that we want. But this also means that when we refresh here, there's not going to be any restaurants. We're just not going to have anything. So in order for us to figure out the best way to retrieve restaurants, what we need to do is we need to get location in here. And so one way of doing that is to say const location context is equal to use context. And then we can put location context in here. So we can grab use context from here. And then we can grab location context by doing import location context. And then we'll do from ... location/location context. And we'll grab the use context here. And what we can grab off of it, basically all we need is location. So we'll add location to this part. And what will happen is we'll reload. And what we'll see happen is that the default location should theoretically come in. Now, why isn't that occurring? Well, one thing to note here, and one thing that I noted, is we don't need a use effect in our location context, but we didn't really solve for that just yet. So if we go into our search component, one thing we need to add here is a use effect. And that use effect is basically what's going to trigger search for us. So we're going to add the use effect here, and we're going to say, hey, when the search bar mounts, let's quickly do a search of what we already have. So the search keyword, let's quickly do a search of the search keyword. And so that's going to allow us to render out for the very first location. So if we trigger this, what we should end up seeing is inside of location context. If we open up our terminal, if we console.log the result here, console.log result, what we're going to see is that we're getting a longitude, latitude. Amazing. Why isn't our restaurant context actually working then? Well, it's getting longitude, latitude as an object. It's not getting it as a proper formatted string, right? Remember, we had to do longitude, latitude as a comma separated value where we had longitude, latitude, kind of like that. And so right now we're getting our location, but we kind of need to format it. So we'll say const location string is equal to, and then we can formulate a string by doing a template string, and we can do location dot lat, comma, and then we'll do location dot longitude, and we'll take that location string and we'll pass it into retrieve restaurants. And so that in itself, let's check it out, console.log location string. That in itself should give us what we need. So let's go look. Terminal 37 minus 122. Let's quickly go look at our mocks, and it's 37 minus 122 4115. Okay. So now we're formatting the correct string. And we have the correct location string. So why isn't it retrieving the restaurants for us? That's a good question. That's because we're not taking in the actual location and passing that into our request. So by doing that now, because we had defaulted everything, let's call it lock because I don't want to conflict with an outer scoped variable. What we can see now is that if we reload, the location is going to be set. Now, 1 second here, dismiss. If we reload, what we're going to see is that location.long isn't a value. So what we have to do is we have to say if location. We always have to check if we have a location and if it's a proper value. That's going to play a big role in us being able to search here. One thing we need to do is we need to add location here so that every time location changes, it actually renders. So now that this is happening, well, we can see that we're getting Zuni Cafe, Brendan's French School, but we can look now and we can fill in Antwerp and let's see what happens. We get a longitude, latitude, and oh, we got different restaurants. Interesting. We just retrieved different restaurants. And if we fill in Chicago and we do that, we can see our little render cycle going in the background. So one thing that we need to add into this procedure, and one thing that we're not seeing happen, is if we go into location context, every time we trigger a search, rather in our restaurants, what should be happening is that when we do retrieve restaurants, we should set restaurants back to an empty value because we're trying to search for new restaurants. So we'll set it to empty, and then when we look for Antwerp, that's going to trigger. We're going to be looking for Antwerp. Then we look for Chicago. That's going to trigger a render cycle and a loading cycle. And then when we look for instance, Toronto, that's going to trigger another render cycle. Now there's something going on here. The street address, for some reason, is still being set to the mock address. Why is that? Well, let's look into that in the next video. I want to challenge you all to find what's causing this bug. This bug on this address field has 2 points of entry. One is our card component, because our card component is expecting some type of data to come in that isn't available. And the second part of this is our restaurant service. Our restaurant service isn't returning what's expected. Otherwise, we would see something here that is expected. Now, would it be something to do with the transform? Potentially. Could it be that we don't have a property? Potentially. Try it out. Try to figure out what's going on here. And in the next video, we'll look at the solution. One thing we are seeing happening in the app is everything is rendering properly. But the address doesn't look right. And so here's where I would challenge you. If we go look at the mock data and we go look at where the address is actually being defined, right? If we look at kind of the place ID, the scope, the reference, and then we look here, address isn't called address. It's called vicinity. Oh, that was a miss on our part, wasn't it? Or rather, sometimes in an application, what you want is you want to translate what the API is giving you. Just like we created these extra properties, is open now, is closed temporarily. Sometimes you want to translate a property to a different name. And so what's important to know here is that it's not that vicinity is wrong. It's rather that we want to name it address. So we could do something like address is restaurant.vicinity, and that would give us the address as a variable. Now, vicinity is still on the object, obviously, because we're spreading restaurant. And we could do something like removing the key, right? We could delete the key. We could go through that transformation step, and we can look at that later once we add utility functions to clean up some of the things that we're doing in here. For now, we're just going to leave it as is. And so if we go inside and we save this and we go back inside our app, what we can see, okay, now the addresses are rendering properly. So we had a bug, but it was an intentional bug because we had changed the shape of what we expected to come back, but we hadn't checked our mock data properly enough to realize that address was actually named vicinity in the data. And so this is part of the trickery of when working with APIs. The API may give you something. You may expect it to be named something else. You may set up a component in a specific shape, but that shape doesn't match the reality of the data. And so this is why I'm doing this specifically to show you the power of separating out. First of all, we separated out our request, and then separating out the transformation and pushing it to the edge of the system, because we have full control here over what's coming in and what it's supposed to look like. And we have changed it with one line of code, and suddenly the UI has all of the benefit of it because it's rendering out properly now, right? And so that's extremely important to note here. There's this thing that keeps bothering me, and it's that we keep seeing this error, this warning popping up. Each child should have a unique key prop. Check the render method of restaurant info card. And so what I want to do now is I want to go and solve that, because it's starting to bother me. Isn't it bothering you? And so if we go to restaurant info card component, what we're going to see here is if we go to the render method, we'll see, well, what exactly is it complaining about? Oh, over here, we put together a rating array, but we didn't give a key to each individual star. That can be a problem. So what we want to do here is we want to take the index of the array, which is not a great way to give a key, right? Anytime you give an index as a key, it's not guaranteed to update correctly. But what we're going to do here is we're going to use the index as part of the key. So we're going to say key is equal to, and we're going to construct a key. We're going to say star dash, and then we're going to pick a property off of here, right? So we have a name, a rating, place ID. So let's go look at the data. Well, if we go look at our services and we go look at our mock data, we can see here in the mock data that we have a place ID. So that's equal to some place ID. Usually this is kind of like a random string. Right now I put it as kind of this. Now we'll take that place ID, and remember we camel cased it, so it's going to look like this. And we're going to say star place ID dash I, just to make sure that it is completely unique. And so by doing this, now what we'll see happen inside of our terminal when we run our code is, if we scroll all the way to the bottom and we refresh here, what we're going to see is that we will no longer have this key issue popping up anymore. Okay, that's great. So by doing this, what we've basically achieved is the removal of a warning. These can pop up anywhere, anytime you do any type of map, anytime you do any type of iteration where you're trying to render the same element multiple times, you have to make sure that you're generating unique IDs. Now, in this case, place ID is guaranteed to be something unique because it's coming from an API at some point, and it should usually be one concurrent string. That's going to work well. And then the I is going to allow us to iterate and say, well, that's the star 1, the star 2, the star 3, and the star 4. It's a combination of things that make it unique. All right, it's reflection time. And you know what happens during reflection time? We look at our code and we evaluate if we've done anything wrong at all. And so what I want to point out here is, it's not necessarily that our code doesn't work, right? Our code works, but it's not as efficient as it could be, and it's not following all the proper React patterns potentially. And so for that, when we set up our services, we set them up in a way so that they would work, right? We set it up in a way that we did our back and forth and we made it work. But we may have inadvertently introduced some anti-patterns, some patterns in React that, although function, could cause bugs to happen very, very quickly. And you remember when we set up our location context? Well, when we set up our location context, remember when I told you that there was a difference between using effect here versus using effect in the search component and having the search component determine when it's going to do its initial search? Well, I put that there because I wanted to show you something very useful that ESLint is doing for us. And although it may sound stupid at the time, why wouldn't I just write the code as if it was perfect from the get? Well, we're never going to get into a situation in a live production, live product environment where all the code is written perfectly. And some code bases may come without ESLint, may come without the tooling that we're setting up here. And so I want to show you how you can leverage these tools to create the proper patterns. And so in order to create the proper patterns, we need to reflect. We always need to reflect. We need to look at our code and we need to say, hey, what's going on here? And sometimes the hints that the code give us are very important. So we're done with a feature, and as we do every time we're done with a feature, we're going to go look at the errors. And so, the majority of them are very small. We need to add a new line here. We have a variable over here that is unassigned. And we have this use effect is defined but never used in location context. And so we're going to leave that there for now. And we have this use memo that is not used as well. So, okay. Why am I leaving the use effect in the location context? Mo, you told us we don't need it there. We're going to do it in our search component. Well, our search component is doing just fine, right? It's searching once when it mounts, and it's applying the search keyword, and everything works, right? It works. It just works. But it's not the most optimal way. You see, locally, we're storing our search keyword. And we can see over here that and our search keyword's initial value is always going to be the keyword that we get from the location context. But there's a small problem here, because right here, the React hook use effect is missing the dependency search and search keyword. Either include them both or remove the dependency. So if we add search and search keyword, what's going to happen is we're going to cause an infinite loop. We're going to cause our app not to render anymore. And this is because now the use effect is going to change every time the keyword changes. Now, Mo, how could the keyword be changing every time? Well, every time we trigger search, our location context is going and running on search, which is setting the keyword. And every time we set the keyword, subsequently we search, our location changes, the object in this use effect is changing, which is re-rendering the search tree. We very easily cause an infinite loop here. And well, it's saying either add them both or remove it. And if we remove it, the use effect will now run on every render cycle. And every render cycle is basically every time anything changes. Again, infinite loop. So right here, this is very problematic, right? We can very easily cause an infinite loop in our code just by doing this very simple effect. We don't want that to happen. Why this is happening is because we're searching with the search keyword. The search keyword is changing the keyword. The keyword is coming back and changing the state here, and so forth and so forth and so forth, and basically causing an infinite loop. Now, an easy way to fix this is say, hey, Mo, just remove this here, right? And if we remove that, it should work, right? Like if we add search keyword and search here, that should do it, right? Well, not necessarily, because if we now go ahead and we reload, of course, our app is going to be in a state where it's constantly re-rendering still, because the values are changing of search. So this isn't ideal either, right? This isn't ideal. How do we go about fixing this? Well, it's very nuanced. What we want to do is, first of all, we want to remove our use effect here, because this isn't going to work out for us. This is causing us a whole lot of pain. What we need to do is we need to have our context be a bit smarter about how it's going to use search. So if we go into our location context, what we're going to do here, we're going to dissect our onSearch function. We're going to look at what exactly is going on in here. So anytime we run search, we're going to run the location context request at the same time. But that isn't necessarily what we want to happen. You see, anytime we run both of these methods, we're running this changes the location changes, search changes, etc., etc., etc. Okay, so we need to be a bit smarter about how this happens. So let's first of all go and remove this. So anytime we search, we're going to set is loading to true, and we're going to set the keyword to the search keyword. And then we're going to say that we're going to take a use effect here. So we're going to have the context determine when it's going to fire the request. And it's going to be smart about it. So first of all, let's put our request in here, right? Let's put our request in here and let's say if keyboard.length, right? Because it's setting the keyword. And then we're going to do keyword here. We're going to use keyword again. And what we're going to say here is if the keyword changes, what we're going to do is we're going to fire a new request. And only then will we fire a new request. Will this solve our problem? Well, let's go have a look here. So over here, inside of the search keyword, we're setting the initial state to the keyword. And over here in our app, what we can see is, let's go ahead and reload. We're going to see that the app doesn't end up in a state where it's infinitely reloading. This is because the use effect inside of the location context is only triggering our request to get the location when the search keyword changes. So it's important to note how this lifecycle works, and it can be quite tricky. We can inadvertently cause bugs. So these warnings that ESLint show us, all these warnings, they have a meaning and a purpose, and they show us the proper patterns to follow. And this is the proper pattern to follow when using context triggering services. It's time to get into our next major feature. As you can see in our current app, we have full search functionality. We can figure out where, what, how. We can search a location. We can get the restaurants in that location. We have nice random images and information rendering for every location. We can even show if they're closed temporarily or not. We have set up all of this amazing infrastructure. But the one thing we don't have that the real app currently does have, well, there's a couple of features that we still need to work through. But one of the big features is we need a detail screen. We need to be able to show a detail screen with a nice, smooth, scrollable action, right? That screen is going to showcase the card information that we currently have. But what it's also going to showcase is kind of a static menu. And that static menu is there as a purpose to kind of categorize what kind of details we could show at a restaurant. Now, Google doesn't send us back the menu information, unfortunately. So this entire feature is going to be static for the menu. And there is no real API out there that can go and figure out the menu per restaurant without doing some type of scraping action or kind of like some more advanced types of things that extend way beyond the capabilities of what Google supplies us or otherwise. So with that, this feature inside of here for the menu is a static feature, but the restaurant information is dynamic and all of the information around the restaurant is dynamic. And the modal feature is here to showcase from a UI perspective, kind of that usability aspect, kind of that finish that you would expect from a mobile application that you can showcase in a workplace and that production level apps also require. Production level apps require this smooth transition, this buttery smooth kind of feel, as well as this nice UI separation with the drop shadow from the menu. And that in itself, that holistic feature is what we'll be focusing on now. Hey, Mo here. Before we get to building this feature around the menu and the menu list and the items that will go into there, before we get to any of that, we currently have one small issue. Our navigation, the way that we've set it up, the way that we navigate between screens, isn't set up for scale. It just isn't right now. So before we get to building this out, I'm going to quickly pause this feature, and in the following videos, what you're going to see is us optimizing the code for the navigation in order for us to build out this feature more properly. So in the following videos, don't be scared that you see us pivot away from this feature, because what we need to do is optimize what we've built already so that we can build this in the best way possible. Before we hit the ground running with this feature, we need to talk about our navigation setup, because currently our navigation setup lives solely inside of the app.js. And currently we're only able to create tab navigation. And as you could see by the feature, it wasn't really a tab navigation type of feature. Rather, it was more or less a stack view. So right now, every tab is a singular component, a singular screen. But now we're getting into a more complex scenario where this component should actually be a different navigation stack. So every tab is going to be able to navigate on its own. And the purpose of this is so that in every single tab, we have our own kind of universe. Every tab should have its own universe. And sure, tabs can link through to other tabs. That is completely fair. But tab interactions should, in reality, be isolated to that tab. So everything that has to do with restaurant information and restaurant detail should live inside the restaurant tab. Everything that has to do with map should live in map. And everything that has to do with settings should live inside of settings. And so every route, right? We have to think of this in terms of routes. Every route should live inside of its tab. The tab is kind of a container that's going to contain more navigation options for us, right? This is kind of the shell in which we're rendering a specific route. And so one of the routes that we want to render is restaurant detail. Now, in order to do that, what we're going to need to do is we're going to need to introduce, instead of a restaurant screen, a stack navigator of sorts. Okay, so a stack navigator is a different type of navigation than a tab navigation. But before we get into that, we need to do some cleanup, because can you imagine defining a stack navigator inside of app.js for every single tab? We need a better system to organize our navigation. And so luckily, we had already set up a good approach to this. We had our infrastructure folder in which we had our theme. And so our infrastructure folder is a good place for us to create a navigation folder. And that navigation folder is going to contain all of the infrastructure for navigation, right? All of our different types of navigators, so to speak. And why is it infrastructure, you ask? Well, it's infrastructure because navigation is a core functionality of the application. It's a core feature, but it also requires setup. And so it's pulling things together. It's pulling screens together, right? It in itself is a feature, but it's a feature of infrastructure, not a feature. When we talk about features over here, what we're talking about is user-facing features, the features that the user consumes. When we talk about infrastructure, however, we're talking about app infrastructure. And although navigation in itself is a feature that is user-facing, oftentimes it is more considered infrastructure of the application because it's pulling together all of these different user-facing features for the end user to consume. Now, with that said, what we want to do in navigation is we want to create an app.navigator.js. And so in that app.navigator.js, what we basically want to do is we want to move over the whole navigation container of the tab view in there. And so try this out. Try to get the app navigator running on its own. And then in the next video, I'll show you how we split it out. So moving around infrastructure is kind of tedious, I will admit, but cleaning up your code is part of the process of getting a better and better code base and end product in the end. And structuring your app for scale is where you have to make decisions like this, because refactoring is inherently a part of removing technical debt, and it's a skill that you need to get good at. Leaving everything in place just makes things more difficult in the long run for extensibility, maintenance, and all those things. So I have a philosophy that's Marie Kondo your code base. Make sure that you always put things in the proper place. And that also means that we need to restructure things at times. Now, the way that I went about restructuring my code is I created an index.js in the navigation infrastructure folder, and I created a wrapper called navigation. I did this because I feel like navigation is this holistic concept that may have different decisions that need to be made. Right now we have a tab navigator that is our core app navigator, but at some point we may want to, based on certain decisions, show a different navigation model when the app boots up, and then show the tab navigation once you go through that, for instance, for authentication purposes or other purposes. So it's important to leave yourself open with the ability to extend. So the app navigator is the main navigator that we work with. And here, what I did is I basically just moved over all of our imports, renamed some of the imports, and left everything intact as is. And in the app.js, you'll see that now it's just rendering navigation. So the main purpose of me restructuring the code in this way is that when we look at this tree, what we want to achieve is a quick overview. When you go to the index file of your app, when you go to the index file of any app, you want to have a quick overview of, hey, what's going on and where can I look deeper? And so here we're achieving that. We know that, hey, we have a theme provider, so we're providing a theme to the entire app. We have a location context provider, so somewhere in the app, location is an important concept. And then we're wrapping the entirety of the app with the restaurant context, because at the end of the day, it is a restaurant app. And so we're trying to allow every aspect of the application to have access to those restaurants. Right now, the only aspects of the app are the tab navigation, which needs access to the entire restaurant context provider. Now, if we extend the app with multiple functionalities, we may take this restaurant context provider and put it deeper nested inside of navigation in order to achieve, a better access point for restaurant context. And this is because, well, maybe at a certain point, the whole app doesn't need access to the restaurant context. And maybe at a certain point, it doesn't need access to the location. It's one of those things where you have to play around with it. But right now, our app is in a state where the whole app requires both of these contexts. So it makes sense. Make the right decisions for the right point at the right scale. Okay, so with that being said, we have our navigation here. And what we need to do now is we need to create a specific navigator for our restaurant screen. So let's go look at how we'll do that. Now that we have our app navigator in the right state, now comes the question, well, what do we do with the restaurant screen and how exactly is this going to work? Well, the one thing that we need to do is we're going to start creating navigators for each one of these tabs. So we'll have a restaurants.navigator.js, and this navigator is solely going to be responsible for all of the navigation that can occur within the restaurants tab. And so that restaurants navigator is going to import React from React, as always. Very important step unless you're just building styled components. And then we'll import the create stack navigator from React navigation /stack. And so this is pulling in the create stack navigation from the stack package. And this allows us basically to create a navigation that is, instead of going to be tab based, going to be stack based. So pushing stacks on stacks on stacks, where the ability is basically screens to flow in a natural state, whether it be left to right, right to left, modals. So think of it as screens layered on top of each other. And so the first thing we need to do is we need to say const restaurant stack is equal to create stack navigator. And then we'll say const restaurants navigator is equal to a component that is going to return the restaurant stack dot navigator. And now the reason that we don't need a navigation container, just like we did around the app navigator, is because this restaurant stack is going to live within the tab navigator. So it's not a separate holistic navigator, it's a sub navigator within this navigation paradigm. So that can become a bit confusing. Think of it this way. This is our main navigation. This is our main navigation container. And within the tab navigation, we're creating a stack navigation that's going to sub-stack inside of the restaurants tab. Okay. So knowing that, what we need to do now is we need to close off the navigator. You always want to close that off. And then what we can do is we can take this and instead of a .navigator, we'll have a .screen. And that .screen is going to be what's going to consume the restaurant screen. So let's go and pull in restaurant screen inside of here. And with restaurant screen, what we can do now is in the stack screen, we can say the name is equal to restaurants. And then we'll say the component is equal to the restaurant screen. And by doing this now, we can take the restaurant navigator, we can go back inside app navigator, we'll remove this, and then we'll say import restaurants navigator from /restaurant navigator. And instead of having the restaurant screen in here, we will have the restaurant navigator. Okay, so now we've kind of gone end to end, and you may be thinking, okay, Mo, well, what's going to happen now? Well, if we go back to over here and we quickly reload our app, what we're going to see is unable to resolve module React navigation stack from source infrastructure. So let's go to our package JSON and just quickly make sure /stack. And it seems that we still need to install the stack navigation. Oh, we forgot. So if we go back over here and we go to React navigation and we look for the stack, right? We look at, for instance, the getting started right over here. Now, if we look at the hello world, we can see here that we still need to install React navigation stack. So it's a separate package. Remember when we installed the tab navigation? Well, when we installed the tab navigation, we installed all of the base packages for React navigation. We installed the React navigation native, which is the tool set, the utility bar, and we installed the bottom tabs package. But now, because we want stack navigation, well, remember when we said that React navigation was fully customizable, right? It's an extensible platform, completely customizable. That's because they split out everything into separate packages. So what we need to do is we need to go inside our terminal, and we'll open a new terminal and we'll say yarn add React Native Navigation stack. And this will install the package that will allow the stack navigation module to actually create the stack that we require. Okay, so this part is kind of elusive because when we talk about stack navigation, right? Stack navigation is one of those concepts where we're trying to create multiple stacked screens inside of a navigator, kind of like this, right? Where we have a home stack and we can then configure subsequent screens, but we're doing it inside of a tab navigator. So now that this is installed, we can reload. And once we reload, what we'll see happen here when we go into our node is it's rebundling. And once it's finished bundling, we'll see right here that we still have one error, couldn't find component, get component children from the screen restaurants. Now, let's look at this. Restaurants navigator is coming from restaurants navigator in the /restaurant navigator. And so we need to export that, which we forgot. And by doing this, now we can see that our app will work as if it already did work. Okay, so the app is working as intended. Now, what happens when I give this a different name? Let's say I called it Hello World, right? The name. Well, if I give it the name Hello World, it's still the first stack that's going to render. So it's the very first screen that is rendering inside my stack navigator, and that is why it's getting precedence. So if I for instance said restaurant stack navigator, and I said restaurants 1, and I said here, render out null, well, that's obviously not going to render out anything. And so now, well, I kind of broke my app because it's showing restaurants 1 as the first item on the stack. Now, one more thing to note here is we're seeing this header bar over here. So what we want to do is we want to say header mode is equal to none because we don't want to see any headers in here. And by doing that, the header disappears and it looks nice. Okay. So knowing this now and knowing how this will work, let's start building out or looking at how our detail screen will actually work, because we now have our stack navigation, and what we can basically do is we can create multiple stacked screens here and we can transition between them based on a click action. So let's take a look at that. Now that we've set up our stack navigator to allow the restaurants tab to contain multiple screens, what we're going to do now is we're going to say the restaurant stack.restaurant detail, is going to be equal to a null, right? Let's not do null. Let's import text from React Native, right? And let's put a text field in there that says restaurant detail. Okay, so now that we have this, what we can do is we can go ahead and we can try to navigate to there from the restaurant screen. Now, one of the things that you get when you link a component to a restaurant stack.screen, what this is going to guarantee you is that this component is going to pass a prop into restaurant screen at the top level. So whatever component is in this component field automatically gets a prop. Now, what is that prop? Well, that prop is the prop navigate. So anytime a component is given to this, what we're going to see here is that you're going to have a prop navigate at this level. Anywhere deeper inside, like restaurant list isn't going to have navigate, search isn't going to have navigate, but the restaurant screen is going to have navigate because it's injected right here. So any of the components that are in this field are guaranteed to get the prop navigate. Okay. And of course, it's called navigation, not navigate. So if we give it navigation, what we're going to see is that navigation should have the properties, add listener, can go back, dangerously get parent, all these different things, jump to, push to. And so what we can do with it now is we can make it push to a different screen or navigate to a different screen. So the way that we're going to do this is we're going to go ahead and do a on click, right? Now, how are we going to do this on click? Well, right around here, around this restaurant info card, we want to add an onPress handler. So we're going to import something special. So what we'll do is we'll import pressable from here, and then we'll wrap our component over here with a pressable, and then /pressable. And what we'll do is our onPress function will be navigation.navigate, and we'll go to restaurant detail. And so over here, it's expecting a curly brace, I believe. That should do it. And so now, anytime we press on one of these, we're going to restaurant detail. We're going to restaurant detail. And so now these have a pressable action. Now we could have also used touchable opacity. We could have used a bunch of different things. But this pressable API allows us now to hit our card and transfer to the restaurant detail screen. But there's something that's not quite satisfying here. You see, we're kind of stack navigating in a direction that's left to right, but I want the detail to pop up from the bottom. So how would we achieve that? Well, let's look at that. So now we have a couple of things we can improve on. We know that when we click, it's going to transition, and it's transitioning from left to right. So first of all, we want everything in the restaurant stack navigator to come up like a modal, except the initial screen. The initial entry point, this is the initial entry point of the stack, so it's always what we'll render first. Anything subsequent, we want to render as a modal. And so in order to do that, what we want to do is we want to import something called, not from here, from the create stack navigator, we have something in here called transition presets. And so what this allows us to do is set the transition for the screen. And so in the stack navigator, what we can do is we can pass something called screen options, and we give it an object. And so that in that object, what we want to give it is ... transition. So we're spreading transition presets. We're spreading everything on transition presets. .modal presentation iOS. And that will set a modal presentation that happens like iOS would. And so now when we hit our target, it's coming in from the bottom, right? It's coming in from the bottom, and it's working as intended. It's swiping up, which is super useful for us. Okay, but there's one more thing. We're not really getting any visual feedback on our press. Remember when we were looking at the pressable API? Well, when we were looking at the pressable API, we saw that it has the ability to track the presses and track how long something is pressing, but it really doesn't give us any visual feedback. It kind of just works the way that you can allow press and you can build custom pressability. So let's go back to touchable without feedback. Well, touchable without feedback was going to allow us to touch without feedback. So if we take that, right, what we were going to see was, if we go to our restaurant screen, if we look at pressable and we quickly replace that with touchable without feedback, right? So now what we're going to see is that we're going to have the same effect, but we're not really seeing any feedback. So what we actually really want is something called touchable opacity. Now, touchable opacity is going to point us in a wrapper for making it respond to touches properly. So if we press it, it's showing us an opacity happening, an opacity transition. So although pressable is the extensive future-proof way to handle touch-based inputs, you still have to do a lot of heavy lifting in order to get the actual output that you want. For simplicity's sake, we're going to use something called touchable opacity. And now what happens is when we click, we're going to see feedback. We're going to see the card fade out. And that's going to allow us that visual feedback that we were looking for in order for the user to properly be able to handle. And so the reason we went back and forth on this is because with the pressable API, we have an extensible, more rigorous way of handling presses. We can handle on press in, on press out. We can figure out when the press was activated, when it's deactivated. We can handle long presses, short presses, but we don't need all of that configurability. What we want is a wrapper for making views responsible to touches, and by default, the touchable opacity will control the opacity by wrapping the children in an animated view and adding that. Now, this can affect the layout, of course, but for us, it really isn't affecting the layout. It's just adding a nice opacity transition to the touch. So it's important to know that although we could use the pressable API in order to have an extensible experience and be able to control the press action and different versions of press actions, for instance, if we wanted to long press on this and then show a menu or things like that, we would use the pressable API and we would do some fine tuning. But for all intents and purposes, all we're looking for is some feedback and the ability to touch. So with that, touchable opacity works a bit better. Now that we've reached a clickable state and we're able to render the restaurant details specifically for each and every restaurant that we click, what I want us to do is I want us to render out the card, the information card that we have here on this screen when we click it. Now, in order to achieve that, what we need to do is we need to go to React Navigation. And if we go to React Navigation, what we can see here is that when we go towards passing parameters to routes, what we'll know is said, remember when I said there's more? Well, parameters is a part of navigation where when we do navigation.navigate to a specific route name, we can pass parameters to go along with that route. And we're able to read those parameters when we go into that specific subscreen by reading the property or the prop route.params. So we can do something along the lines of when we do our touchable opacity on press, we can pass parameters in here. So I want you to try to pass the parameters. And then what I want is for us to build out a restaurant detail screen in the restaurant screens folder. So a restaurant detail screen, pass that in here, and then read out the property route.params and try to render out the card. In the next video, we'll look at the solution. Hopefully that went all right. Now let's look at how I solved it. So first of all, in the restaurant navigator, what we needed to accomplish was we needed to remove our text input here from the restaurant screen. Rendering an inline function causes React Navigation not to work properly, so we need to import a named component. And we created the named component restaurant detail screen. Here we can remove this import, and we import restaurant detail screen from our features folder where we created a screen called restaurantdetail.screen. Restaurantdetail.screen is a screen that contains three things. First of all, we need to import React. Then we need to import the restaurant info card. Then we import the safe area view from the utility safe area component because we want to make sure we render in the safe area, even if it's a modal. Inside of that safe area, what we're going to do is render the restaurant info card. The restaurant info card is going to be part of the holistic approach that we're taking to rendering out the details. We want to show the exact same detail card without the same exact interactions just yet. And so what we need to take in as props is the route. Now the route is coming in because it's part of Restaurant Navigator. Because it's defined as a component on the stack screen, Restaurant Detail screen now gets information from its route in order to be able to pull information. Some of the information we need to pull is off of route.params. As you saw in the documentation, route.params allows us to pass information around. And so the param we're pulling off is restaurant. And as we pass that into the restaurant info card, we pass restaurant is equal to restaurant. We also needed to adjust the restaurant screen in order to pass that parameter. And the parameter that we passed is on navigation.navigate. We put in the path we're going to navigate to, which is restaurant detail. Then we did comma, we opened up an object, and we said restaurant was equal to item, because as you remember, item is our restaurant. So we're passing restaurant on route params to restaurant detail as we go over there. And if we look at that from a solution perspective, if we go over to our phone, what we can see here is now if we click on our restaurant, we'll pop up the detail screen and it will show the information that is required inside of the safe area view with the restaurant detail card. So the restaurant detail card is the first part of the detail screen that we've now built out, and we've been able to successfully pass the restaurant information each time that it's clicked into the restaurant detail screen. So we're in a good state here to start building out our menu. Hey, it's me again. Now that we've restructured our navigation in a way that is optimized for scale and optimized for usability across all of these features, what we can do now is unhit the pause button on this feature and look at how we can build out this static menu of items and lunch menu, dinner, drinks, all of that good stuff. Let's take a look at how we can build that out now. Now that we have our restaurant card, detail card rendering out, the next portion of the feature is to put in place a menu accordion group. So what we're going to be trying to do is achieving the following. We're going to be putting menu groups for breakfast, lunch, dinner, and drinks. And for that, we're going to be using React Native Paper's list accordion. And that list accordion is going to work as follows. When we look at the usage, what's basically going on here is we're going to have a use state for every accordion group. And that's going to basically have a title and a icon that is going to be rendered, as well as the items internally inside of the list. Now, every icon is going to be specific to React Native Paper. So when we go look at React Native Paper, it has icons and it can use many components of the React Native vector icon group. That means you can pass the name of a material community icon as well as a React Native vector icon library. They have a list of supported icons so that you can find icons and you can search for icons inside of here that you want to put. Now, what we'll do is we'll reconvene after this video and I'll show you how I put together my list accordion groups in order to render out breakfast, lunch, and dinner inside of the restaurant detail screen. There are a bunch of ways to reach your desired effect when it comes to rendering out the menu inside of the safe area of the restaurant detail screen. Now here I'm going to show you how I achieved it. First of all, I had a couple of use states that I was going to require in order to open and close the accordion groups. So I had state for the breakfast, the lunch, the dinner, and the drinks. And this is keeping track of each individual accordion's state. On top of that, I had to import list from React Native Paper in order to utilize what the list has to offer us. And next to that, I eventually needed a scroll view. But first, let's go through putting together the accordion. So what we need to do here is we need to define the accordions one by one. And that means having the accordions predefined before putting the list items inside. Here we have an accordion for breakfast, which I gave the title breakfast. On the left side, I put a list.icon of the icon bread slice, which was available. And then I linked the expanded, so the tracking of whether it's expanded or not, to the use state of breakfast expanded. So anytime we trigger the list accordion, this will be set to true or false, depending on its open or closed state. By triggering the on press, which returns an inner function of set breakfast expanded of the inverse of breakfast expanded. So if the current value is false, it'll be set to true. If the current value is true, it'll be set to false. Okay, so now what we need to do is we need to create the same accordion groups for lunch and dinner and drinks. That means creating a accordion for lunch, for dinner, and then for drinks. So here we have dinner, and then we have drinks as well, which is going to be linked to the state of set drinks expanded. And so with that, we have all of our accordions ready to go to be filled in with information, but they currently do not have any information inside of them. And so if we look at what that renders out, we need a closing JSX tag for each and every one of these. Now, when we look at list accordion, is each one of our accordions closed? And here we can see the following. Error expected, closing tag for list.accordion, and it seems that I wrote according. Small little mistake here. And then what we can do here is we can just I made the same mistake everywhere. According. Fun little mistake. Now, if we open these up, what we're going to see is that we have breakfast, dinner, and drinks, and they're triggering their state to open and close the accordion, which is great. So that means that we're tracking the state correctly and our accordions can open and close at will. Now what we can go and do is we can go put list items inside of here, and those will expand and contract with the accordion group. So you can put however many items you want in every accordion group. It doesn't really matter. I chose a couple of list items for breakfast, lunch, and dinner, and that allows us to set up our breakfast, lunch, dinner, and drinks accordingly. Now, if I contract lunch and then we see dinner, we can see that within dinner, I put breakfast. Oh, actually, I accidentally skipped one. So what we need to do here is this is the lunch clause. And this is the breakfast clause, the accordion rather, that has these items. And so by saving, we restructure. And then I have a couple of drinks here that I wanted to put in as list items in the drinks accordion. And that allows us to set up correctly dinner and drinks. But we have one issue here. You see, when we set this up and we unfold every single one of these, we can't really see the entire list item. And and in the drinks area, we can see clearly here, after Coke, we have Fanta, but it's going off the screen. So what can we do here? Well, one option would be to use flat list. But then again, we don't really need flat list here because it would separate out too much of the data. The data would have to be each individual item in a category, and then structuring that would be very hard. So what we need to use here basically is a scroll view. We just want to make the area scrollable for us. that means that we're going to import scroll view from React Native. And this will just make the area around the accordions scrollable and thus able for us to scale our accordions accordingly. And now we can see that if breakfast, dinner, and drinks is all expanded at the same time, we can still scroll down and see everything that is available to us very easily. You see, flat list is for when we have data coming in of a certain structure and we want to render out one certain item. Here we have accordion groupings and items inside those accordion groupings. It's not to say we couldn't use flat list, but all we needed to do here was make the area scrollable in order for our menu to become scrollable. And we're never going to hit a case where our menu has 100,000 items. So we're not at risk here of running into performance issues because menus tend to be limited. You may have 50, 60, 70, 80, 90, maybe 90 items at max. And at that point, you have a gigantic restaurant, and I don't know how that kitchen is doing it. So a scroll view is just performant enough here for us to be able to gather all of our information and set up and have that scrollable interface while still keeping the top level information, the important information of the card right here for us. Okay, now that we have our detail screen fully built, what we're able to do from here, right, is we have our detail screen. We know that for every single restaurant, and these work with a swipe down action, by the way, you can also click the tab icon in order to close these. Now that we have this set up for each individual restaurant and we have the detail screen set up for each one of these, what we can go ahead and do is we can go ahead and set up our map view now because we have all of our information ready to go for us. So why don't we go take the restaurants and now render them on a map? Before we start getting into building the actual maps feature, we want to get a sense of what our feature overview is going to be. So anytime we search for any given place, what we want to do is we want the map to swap out and then show us the markers at that specific place. And with that, we'll be able to create an experience for the user that's seamless between the restaurants, which also take into account that the location has changed, and the map. And when we click on a specific restaurant on the map view, we'll go back to the restaurants view and showcase the restaurant detail information. That way we have the ability to create the seamless experience in the app of flowing from the map screen back into the restaurant detail information. And so knowing that that's how our feature is going to work, the first thing we need to figure out is how are we going to render a map? And so let's get into that. Now that we have to render a map view, we have to do our research. What exactly do we use? And luckily, because we are in an Expo controlled environment, the Expo docs can point us in different directions when it comes to utilizing specific functionality. And when we look it up, what we can see is that they have a map view implementation, specifically with React Native Maps, which provides a map component that uses Apple Maps or Google Maps, depending on the platform you are on, and on Android. And Expo uses React Native Maps from the community, no setup required, for use within the Expo client. Now, what do we need to do in order to get this up and running? Well, all we need to do is run Expo install React Native Maps. So let's go ahead and do that. So if we go over here to our app and we open up our terminal, what we're going to be able to do is run that command in a new terminal, Expo install React Native Maps. And while that's happening, let's go back to the documentation. As we can see here, in order to utilize React Native Maps, and you can see the full documentation at React Native Community, React Native Maps, we can import a map view from React Native Maps. Oof, say that 50 more times, React Native Maps. In any case, we're able to import a map view. And with that map view, we're able to give it a specific style, and it will just render out a map. Now with that map, we can then give it directionality in terms of which location to render out, what specific zoom level to be at, and where to put pin markers. Now you can try this out on an example snack, and that will bring you to an example snack that will run React Native Maps. And if we tap to play here, we can obviously run the map inside of an Expo project and test it out before we get into the nitty-gritty of specifically what we're trying to accomplish ourselves. Now, we have React Native Maps installed, and the next thing we need to do is we need to make sure that our navigation is set up correctly. So if we go into our infrastructure and we go into navigation, what we can see here is at the app navigator level, we still have the setup that was previously done for the map, which is an inline function right here. Well, not an inline function. It is a component function outside of the body, but it's inline in this file. And so what we want to do here now is, first of all, we want to go into our restaurants and we want to build for the restaurants a new feature. What we're going to call it, well, we could either build it inside of restaurants, but we're going to create a new feature and we are going to call it map. And that feature map is going to have a screens folder, new folder, screens. And inside of that screens folder, we're going to create a new file and we're going to call it the map screen, map.screen.js. And so inside of that map screen, what we need to do is we need to first of all import React and the map view from React Native Maps. Then what we need to do is we need to ensure that we're able to utilize all of the functionality that we require. So what we're going to do is we're going to export const map screen, and that's going to render out the map view initially. That's what we'll do. And then we'll take map screen, we'll go back to our app navigator, we'll remove this initial map implementation, and we will import the map screen from //features map/screens/map screen. Okay, now that we have our map screen, we have to ensure that it is properly being used here. And once we do that, what we can see here in our app is that when we reload, if we go to the map now, once everything is loaded, if we go to the map, oh, nothing's being loaded just yet. Why is that? Well, let's give it a style, and let's say that the style is height 100%, width, and then let's leave the width off for now. And now we can see that we're rendering an entire map view inside of here. And if we go over to Android and we run the same exact thing, what we'll be able to see over here is that once it loads, the map screen should also render out the map, but this time with Google Maps. So we have our map implementation working here now. And from here, we can start layering on the functionality in terms of rendering out the right zone, putting on the map markers, and all of that good stuff, as well as triggering a redirect to the restaurant detail when we click on a marker. Good stuff. A couple of easy installs, and we're good to go. I hear you asking the question, Mo, why did we set up a map screen and then import that map screen directly into React Native Navigation? Why didn't we create a navigator called Map Navigator like we did for Restaurants Navigator? Well, that's because right now we're just building out the map screen. We don't know all of the other functionality that it may need, if it needs to be able to go to different screens, if it has different screens inside of the map view, or if it's solely just the map view that's linking out into Restaurant Navigator. We haven't built out all of the functionality yet. So for now, map screen will suffice for us to enable us to be able to load what we need from maps. Now that we have our map up and running, the next thing we need to do is we need to make sure that it gets the information it requires in order to render out what it needs to render out. So for us to do that, we're going to need to build out a bit more than what is already here. So right here, we see that we have a map screen. And if we open this up, what we're going to be able to do is build out what our map screen is supposed to look like. Right now, the entire map view is rendering inside of the entire shell of the app. And we don't really mind if it's taking up the entire view rather than, for instance, rendering it in a safe area. We don't mind the full screen solution here because it looks nice. It looks nice when the map extends out into this area. So we're going to leave it as is, but what we're going to do is we're going to import styled from styled components /native. And what we're going to do is we're going to say const map equals styled, and we'll give it the map view. And then we'll say height 100%, width 100%, just for good measure. And then once we have that, we can utilize that as our map rather than have the inline styles going on. And as we can see here, it is still loading correctly. When we go into our map, that looks amazing. Now that we have our map set up with a styled component, what's the next thing we need to do? Well, I would argue that the next thing we need to do is figure out how we're going to render out the search bar at the top. So right now our search is inside of this feature component, restaurants. So what we can do here is we can reutilize the search that is currently inside of here, or we can build a standalone search for the map screen. I lean towards building a standalone search for the map screen because at a certain point, these search bars may diverge in terms of functionality and view, and we want to build the right component for the right use case. So what we can do is we can copy everything in this file because it's going to look close to what is currently here. We'll create a components folder, and then we'll create a search.component.js, and we'll paste what is in here. And this will allow us to have a very similar component to what is already inside of restaurants. But the reason that we're copy pasting is it's not bad to copy paste components when they differ in visualization or they may differ in some view in functionality, because we don't want complex if else logic inside of the component determining, hey, you need to render this icon or you need to render this icon in this specific use case. And as the search bar extends across multiple features, it becomes like this very, very bulky thing. So for that case, we build the search bar specifically for the map view. Now we can go ahead and we can say import search from ... components / search component. And now we'll have a search bar for our search screen. So we'll do search here. And as we do that, now we'll be able to see that we have a search, but it's not really positioning itself correctly. And so that's where the search function already diverges from the search function we saw for restaurants. Instead of it having padding, it's also supposed to be positioned in an absolute fashion. And next to that, we're going to give it a Z index of 999 so that it renders at the top. It already has a padding, and we're going to say from the top, always be 20 pixels far down. And so with that, oh, now it's rendering over here. Well, let's also give it a width of 100% so that it scales to the UI. And maybe let's render it a bit lower. That looks good. That feels good. And maybe we could go a bit lower. We could go a bit lower. And if we look on Android here, what we're going to see is something very, very similar. We're going to see it render inside of the view at a good position. And so with that, we now have our search bar that is rendering already the same value as in the restaurants view because it's already hooked up to the context, right? We already hooked up the search to the context, so it's using the same keyword that is currently set. And this is pretty cool because let's say we searched for Antwerp inside of here, Antwerp. Now we're going to render the restaurants for Antwerp, and if we go to our map view, oh, well, this isn't updating. Why isn't this updating? Well, we're only setting the search keyword for the initial render. So we need to make sure that anytime the keyword updates, we update the search keyword inside of here. So what we can do is we can set a use effect inside of our search component locally, and we can say anytime the keyword changes, let's set the search keyword, let's set the local search keyword to the keyword, and let's import use effect from over here. Now we can have a sync that happens between these two screens. So if I reload here and I search for Antwerp, we're going to see that it is going to adjust itself inside of this screen. But if I search for San Francisco here, what we're going to see is that in here, it's not going to update. So we need this logic in both places. But the reasoning behind us duplicating this logic is because we don't want two search components. We don't want one search component for both use cases because they're going to diverge heavily in visualization and positioning. So the styling, the search container is going to differ, as well as some of the functionality in here. Now we could say that we may take out this search bar and give it some conditional logic. I honestly prefer this method because this will scale with the feature. If the map screen feature needed more intense search functionality, type ahead functionality from Google Type Ahead to test or A/B testing the map screen search versus the restaurant search. So I like to bucket these features. I like to bucket these features to be separate. And one of the things that we're immediately going to do is we're going to show a custom icon inside of this search component for the search map screen. And so the way that we're going to do that is we're going to say icon is equal to map. And by doing this now, we can see that when we're on the restaurant screen, it's going to show us a search indicator, but when we're on the map screen, it's going to show us a map indicator. And that map indicator is going to allow us to know, hey, visually, we're on the map screen. So another divergence point. Okay, so now we know that if we type in Antwerp here and we were to hit search, what we would see in the restaurant screen is also a loading of the Antwerp restaurants. Amazing. We're starting to link functionality together. We're starting to get the map screen in a good shape. Now, we've set up search for the map screen. We've set up the map screen inside of the navigation, and we've kind of coupled the searches together so that when one search happens in the map screen, the other search also updates. That back and forth is very important. In the next video, we're going to look at how we can extend the map view to render out the information for the restaurants. Now that we have our map view rendering and our search hooked up, the next point that we need to get to is the ability to render out the map markers that are required for this map. So let's open up the map and then let's see how we're going to go about this. So first and foremost, we're going to need our restaurants. How do we get our restaurants? Well, what we're going to need to do is we're going to need to pull in both the location context and the restaurant context. And for us to do that, we're going to need to import both location context and the restaurant context from their service folders. That means a short little import statement here to make sure that we pull in the context. And then once we have them, what we need to do here is inside of the map view, we're going to have to do a type of restaurants.map where we're mapping over the restaurants, getting the individual restaurant, and then taking that information and rendering something out. So for now, let's return null because we're not going to be rendering anything out. And let's see if our app still renders. So if we go over to the map view, we're still good. Now, how do we render out a map marker? Well, that's a good question. The React Native Maps has something called mapview.marker. So we imported mapview, but we also imported mapview, wrapped mapview with the styled component. But for this, we're going to reference mapview dot, and we're going to do dot marker. This is going to give us a marker that we're going to be able to use in order to determine a specific position. Now, where are we going to place this marker? Well, that's a good question. We don't even know where we are on the map yet. But if we put markers for each restaurant, we need to give it coordinates. So it's going to take some type of coordinate that's going to have a longitude, latitude, and a latitude. Now, before we get into that, how about we make our map, first of all, render out the correct space? Because right now, our map markers are not going to be able to render out in the correct spot. We need to figure out how we're going to get our map in the correct spot. So let's put null back here, and let's think about this. So when we put together a location in our infrastructure folder, in our services folder rather, when we put together a location, the location mock gave us back geometry. And so far we've used longitude and latitude from the location object to determine how to search for restaurants. But now we need to use both this location and the viewport. The viewport is referring to where on the map it's supposed to focus, to determine how we're going to let our map render out the correct spot. In order to do this, we're going to need to do some math. So what we're going to do is we're going to write a use effect. And this use effect is going to be what is going to calculate exactly where we're supposed to render. And it's going to change based on the location changing. Now, what it's going to do for us is it's going to do some of the heavy lifting. We're going to need to track something called latitude delta. Latitude delta is what determines how close the zoom level is going to be on the map. And right now, we don't have any information about that just yet. But how we calculate this is we do our viewport. So we're going to pull in our viewport from location. That means we're going to do const viewport is equal to location. And we're going to pull in our viewport in order to be able to calculate all of this. Now, are we exposing our viewport currently on the location object? Well, let's go look at location context. And currently location is pulling in the following. If we go into our service, currently our location is pulling in lat and lang from geometry.location, but we do not have a viewport. So let's expose viewport by doing geometry dot, and let's go double check. If we do geometry, oh, it's geometry.viewport. Okay, so geometry.viewport. By exposing this now, we'll have access to the viewport. And if we console.log the viewport, we'll be able to know what exactly is going on. Now, it's missing a dependency. It also needs to take into account if the viewport changes. And by doing this, now we're able to calculate. So let's close this up. Let's open up our terminal and let's go to where our code is running. And now we can see that when we console.log out the viewport, we are getting an entire object right here. So if we do this, are we actually getting the correct output? Let's go back to location mock. Well, when we do the viewport, we should be getting northeast and southwest. So let's go ahead and say dot northeast, and let's see what that renders out. When we re-trigger the render inside of here, well, now we're getting lat and lang. Amazing. Okay, so now we have our viewport ready to rock and roll. So we know that we have the information that we need. And to calculate the delta, what we're going to do is we're going to take the northeast latitude and the southwest latitude, and the delta is going to be the difference between the two of these. And so we can shorten this by just writing this inside the set latitude delta function. Now that we know the latitude delta, we need to use this information in some way. So what does the map take? Well, the map is going to take coordinates as well. And when we say coordinates, we say region is equal to, and then we can say latitude is equal to lat, longitude is equal to lng, and then the latitude delta is going to be lat delta, And then we're going to set the longitude delta to 0.02, which is a default zoom level that we have determined that we want. And now when we render out our map, well, first of all, we need to get lat and lang out here because we need them for the map. And then once we do that, if we go to our map view, we are now zooming in on San Francisco. And if we search for Antwerp, we're going to zoom into Antwerp. And if we search for Toronto, we're going to be zooming into Toronto. We search for Chicago, and now we can zoom into Chicago. So we've quickly built the ability for our map to take the information from the response, calculate what zoom level it needs to be at with the longitude and the latitude delta, take the latitude and the longitude of the position, and then put that as the map's region so that we can specifically see where we are on the map. And the same is true for Android. San Francisco is rendering here, and if we search for Antwerp, we'll be going to Antwerp and rendering out the city center of Antwerp. So that's amazing. Just a couple of lines of code with all of the information that we already had available from our location context and our restaurants, and we're able to put the map in the right position. And now that we're able to put the map in the right position, what we can do is we can start rendering out the markers for the restaurants, but we need to dissect the restaurant information to determine where we're going to put the markers. So let's go ahead and do that. We have our map view rendering out the correct region. Next up on the chopping block is, how are we going to get the restaurant markers in the right spot? Well, we already have the information. Right here in our mocks, if we go look at Antwerp, at the specific restaurants, every restaurant has the same geometry object with a location and a viewport. And so with that information, we can calculate where the markers are supposed to be. So knowing that, it's fairly simple for us to build out the map screen functionality for the mapView.marker. So what we're going to do is we're going to do mapView.marker, and we're going to say close the marker, mapView.marker. And what we're going to render inside of here later on is the view, the detail view. But for now, we need to say the key of this map view is going to be restaurant.name, and the title is going to be restaurant.name. And then next to that, what we're going to do is we're going to say the coordinate of this map view marker is going to be equal to the following. Longitude and latitude is going to be equal to restaurant.geometry.location.lat and lang. And by doing this, what we can do is, let's self-close this for a second so we get rid of the error. By doing this, what we're able to do is we're able to determine where the latitude and longitude of this pin is going to be on the map by taking the geometry location object for a specific restaurant. Okay, so with that, we should have our markers, right? Well, let's go look. Over on the map, wow, we have all of our markers, and they are automatically rendering out a nice marker for us to know, hey, this is the restaurant. And if the markers are close together, we just zoom in, and then we know which one is which. And we can kind of pan out, and we can go City Beer, Tommy's Joint. It's that easy. We just put markers on the screen, and it looks so professional. So professional. If we go over here to Antwerp, now we're going to see that when we change views, boom, the markers are going to come in, and we're going to know exactly where the restaurants are that we just searched for in this vicinity. That's absolutely amazing. Okay, so now what we need to do is we need to update this callout. This callout for the map view is a bit, well, simple. And so we want it to look nice. We want it to look something like what our cards look like. We want to see the image and the name, and we want to have a nice font. So let's go ahead and look at how we're going to do that. We're getting in the territory of rendering a custom callout. And so the way that this works is anything inside of the map view marker is what's going to be rendered as part of the actual tooltip. So if we went up here and we said const some text is equal to style.text. And then we just use that as the internal, right? Some text. And then we put inside of some text, hi there. Well, now what we're going to see is when we click a marker, nothing is happening. And so why is nothing happening? Well, first of all, we need to wrap this in a view. And so by wrapping it in a view, we'll be ensured that it will be part of the actual render cycle. So let's import view from React Native. And now we'll go to our map screen. And what we can see is that, it's not rendering it as the tooltip, it's rendering it as the marker itself. Oh, okay, so that's what map view marker does. So now, well, what we actually need is map view dot callout, and that is specifically what is going to render out the tooltip for each and every item. Now, that being said, once we refresh, what we can see here is that every single map view callout is going to render hi there some text. And so we now know that the same is true on Android. When we refresh here, what we're going to see is that the map view is going to render out our markers, and that the callout is now going to change in terms of saying hi there. If we put a specific hi there in here. So if we put hi there, we could see hi there, hi there, hi there. So what we need to do now is we actually need to build out the component that is going to visualize the map view marker detail. And for that component, what we're going to set out here is inside of components, we're going to say map callout dot component dot JS. And this map callout component is what we're actually going to put inside of the callout here. So let's go ahead and let's remove our unused code here. And then we'll remove this some text and we'll put map callout component, and it'll take restaurant as the current restaurant for the information. And then we'll import this from components, from /components / map callout. And by having this, what we can do now is we can go into map callout. We can say export const map callout is equal to, and then we'll render out some information in here. So let's import React from React. And the first thing we're going to do here is we're going to import styled from styled components / native. And we'll say const my text is equal to styled.text. And we'll take that into account. We'll grab the restaurant from here. And we'll say my text is equal to restaurant.name / my text. And this should render out the restaurant name in the my text component. So here we can start building out the visualization that we want for our map callout. And so let me show you the visualization quickly. If we go home and I open up the 0 to mastery version of this app and we go to our map view, we can see here that what we want to render is the image with the name inside of the callout. So as an exercise, I want you to try out building out this component. Don't worry about the favorites icon. We will get there. But for now, just render out the image with the specific name of the restaurant in this font. So for our map callout component, in order for it to render out this version of what we want, in the map callout component, we could create an entire custom view. Now I'm going to create a shared view called compact restaurant info, because at the end of the day, what we want to achieve here is reusability. And this is a component that we will end up reusing in the favorites feature that we're going to build later on. So just think of it as if I was building all of the information in here. And so compact restaurant info takes in restaurant as a parameter. And with that, we can now import the compact restaurant info from, and we're going to do it from components/restaurant. So in the core components, we're going to create a folder called restaurant. And then inside of that folder, we're going to create a file called compact restaurant info.component.js. And so this is going to be the component that is actually going to contain the information that we want. So we're going to import React from React, and then we're going to do a bunch of different imports. But first of all, let's export our compact image. And what we're going to do inside of here is we're going to return a touchable opacity. So we're going to make this a touchable component. Well, actually, right now we don't need the touchable opacity. So let's just focus on the raw compact views that we need. So let's import styled from styled components native. And let's create 3 components. So I want a compact image. I want a compact image and a compact item. So these 2 elements are what's going to provide me with the compact view. Now, in our render function, what we want to do is we want to render out item, and we want to render out the compact image. So we'll take compact image, and then what else we'll need is we'll need to import text. So let's import text from /typography/text. And so with text, what we're going to render out is the restaurant name. So let's do that. And for compact image, we're going to say that the source is equal to the URI of restaurant.photos0. And so this will allow us to basically render out the entire compact item inside of the compact item view area. Now, inside of our map callout components, we have an error here, I believe. No, this is not an error. Let's just, the error cannot be dismissed. So let's quickly restart Expo. Sometimes that can happen. And let's load the local MealsToGo. And so unable to resolve /components/restaurant. And then we need to add /compact restaurant info component. And then we'll reload. And so what we'll see on our restaurant screen here, or our map view screen rather, is when we click this, we'll be able to see our compact info. And if you're seeing an overlap when clicking one of the markers, it is because you are not zoomed in close enough to tap the ones that are close to each other. So here we're seeing that we're able to click and see the information with the callout for the specific restaurant. What is it looking like on Android though? So let's go look at Android. If we go over to our map view and we press on our compact image, well, it's not showing anything. And this has to do with another difference between Android and iOS. Specifically with the map view callout, there is currently an issue where the initial render of the image component inside of the map will not resolve the image correctly. And so a way around this is to use the React Native Web View. And so the React Native Web View, if we go to Expo and we search for Web View, is a component that we can install by doing expo install React Native Web View. It basically renders a page, so to speak. Like if you were to go to a browser, it's rendering a web page. So we're going to render a web page instead of an image component because that tends to work better on Android, and we're going to do it specifically for Android. So let's go into our component code here. And if we go into the terminal and we go to this one, we can do expo install React Native Web View. And as we do that, what we'll do is we'll start building out the code that is required for this. So we'll import web view from React Native Web View. That's the first thing we'll do. And then we're going to create a compact web view as well as a compact image that's going to look exactly the same, but it's going to wrap the web view. And so inside of our component, we're going to do a quick check on platform. So let's import platform from React Native. And so what we can say over here outside of the render function is const is Android. And we'll do platform.os is equal to Android. And by doing this, what we'll be able to do inside of here is determine what const image will be. Const image is Android, question mark. So if we are Android, we'll take the compact web view. Otherwise, we'll take the compact image. And with that, we'll be able to render out the correct image. So we'll use image over here. And so now we're swapping between the web view and the image for Android and iOS. So let's quickly go over here and check what's rendering inside of the map view of iOS. So if we go to iOS, it's still rendering out the image and it's using the image itself. And on Android, what it should be doing is it should be rendering out the actual web view. So let's go over here and let's just quickly restart the app because Expo was crashing, too many refreshes. So if we start up Expo and then we go into the app once it's ready to load, what we're going to see over here is that in our terminal, we shouldn't have any issues for the web view. If we scroll all the way down to the bottom, and now it's loading up San Francisco's restaurants. And once those come in, and so now that we're on the map view and it's rendered out all of the markers, if we open out the callouts, what you can see is that it's now properly rendering out the images for the different restaurants. And this is because it's rendering inside of the compact web view. So it's important to note that certain packages and certain libraries may run into issues when trying to render out the image, and this may have been very well an issue you ran into as you were doing the implementation. It's important to note that these types of issues are not uncommon and can occur where something works in iOS but doesn't quite work in Android. The same was true for the spacer component, and now the same is true for the image component inside of the callout of the map view marker. So very strange issue, yet very important that we understand the differences and the limitations of certain libraries between the two platforms. And so now we have a very similar user experience between both the actual Android map and the iOS map. In the next video, we'll look at how to put an on-click handler to make the restaurants go to their subsequent detail screen. The last thing we need to do is make the callouts clickable, because right now, when we click them, nothing really happens. In order to do that, the map view callout has a onPress function, and this onPress function has the ability to do a function call. Now, as you remember, any screen that is given to a navigator, if we are looking at our navigators inside of infrastructure, any view that's given to a component here has the navigation prop. So because we know that we have the navigation prop, let's quickly go and get it, navigation. And what we can do here is we can say, well, onPress, do navigation.navigate. And where do we want to navigate to? Well, we want to navigate to restaurant detail. And we want to make sure that we give it the restaurant as a value. So restaurant, and we'll give it the value of, well, we have restaurant here, so we can give it value restaurant of restaurant. Or you can shorthand this and just say restaurant, pass the restaurant along. Okay, so now that we've done this, if we press, we're going back to the restaurant screen and we're showing Tommy's Joints info. That's amazing. It was that simple. And if we go here and we press Pancho de Villa, well, instantly we're going to the restaurant detail screen. Absolutely amazing. It was that simple. Because we set up our navigation and our infrastructure in such a simple and rigorous way, we now have an easy way to link everything together. A couple of lines of code, exactly three, and we have a fully fledged integration between the map screen and the restaurant detail screen. It was that easy. Absolutely amazing. Next up on the chopping block, the favorites feature. So as you can see here in the app, we have the ability to favorite certain restaurants so that we can keep track of the ones that we would like to visit or have visited or in general just like. Now this feature is amazing for different reasons. First of all, we can save across multiple cities the restaurant information. And on top of that, we're going to persist it beyond the app closing and opening. And in order for us to get there, obviously there's going to be some type of mechanism that we have to put in place. But as an initial entry, what we want to be able to do is store favorites and be able to view them in the restaurant tab. Now let's show you how to do this. Now that we're getting started on our favorites feature, one of the important concepts that we need to come back to is the concept of services. So far, we've used services to mock API calls to external services like Google. But services extend way beyond the fold of just that. In essence, with our service folder, it has everything to do with our interaction of data, right? Data is what flows into the application and flows back out of the application, and services are that layer that communicate with the data. We don't want data all across our application being muddied in terms of where we call and request data and retrieve data. No, we want a nice shell around how we work with data. And so services are that shell. Now, when we get into the concept of services, obviously we have our service, our mock, and our context. And the context is there to provide the glue between what is React and what is the actual data transmission, right? The API call and the transform we do against the data is one layer of requesting data. But the other layer is how do we get that into the React ecosystem? And so we decided that context was going to be that way. Now, when we talk about our favorites are basically also a service. Now, whether we decide to store them locally or store them externally on a server, on a database, or whatever, at the end of the day, it's data that we're interacting with that may eventually become an external concern. So when we talk about it as a service, we have our favorites service. But our favorite service is a bit different than the other services that we've created so far, in the sense that we're used to having a mock, a service, and a context. In this case, we're going to be storing our favorites locally. So in that case, what we're going to start by doing is we're going to start by building the context. So we're going to have a favorites.context.js. And this is going to kind of be where we focus all of our efforts. So as with all of our services so far in all of our contexts, we're going to import React from React. And what we're going to do here is we're going to also import the all-important create context. Now, what we need to define here is export const favorites context, and that's going to be equal to create context, which is going to be the context that is going to hold the favorites. Now, as with everything, we're going to export a const favorites context provider, which is going to be the one that wraps the tree or the app.js in order for us to be able to supply the favorites to the tree of React. And inside of there, we're going to say favorite context.provider, and then we're going to close that off, .provider. And inside of here, we're obviously going to render our children, which are going to come from the props of the component. Now that we have this, what we can do is we have our baseline. And so when we talk about favorites, well, our favorite context needs to keep track of our favorites. And our favorites are basically the restaurants. So the restaurant data is what it's going to store. So we're going to import useState. And useState is going to have const favorites and a setFavorites function. This is going to be equal to useState of an empty array because we do not have favorites when we boot the app. And each time a user decides that they want to interact and add a favorite, we need to set up something to add and remove favorites. So let's say const add is equal to adding a restaurant. So we're adding a restaurant to our favorites. And this is going to equal the process of doing setFavorites of the current favorites plus the new restaurant. That is going to be the process that is followed by the add function. Now, if we go look at our remove function, the const remove function is going to look a little something like this. It's going to take in the restaurant that we want to remove, and what it's going to do is a bit more involved. It's going to do const new favorites is favorites.filter, and it's going to check the restaurant by place ID against the other restaurants in the favorites. So the current favorites have all of the restaurants, and we're filtering saying, hey, if the place ID matches, do not add. We could do something similar to this where we said, if it is equal, don't add. Now that logic is going to be left for the outside. Now we need to provide our provider with the value that it's going to provide externally. And that value is very important for us because it is the shape that is going to go to the outside of the component. So first of all, we're going to provide favorites. And then we're going to say add to favorites is going to be equal to our add function. Remove from favorites is going to be our remove function. And that's basically it. These are the three methods that are going to be part of our favorites context. It's very simple, very straightforward. And so now let's go look at how we hook it up. Now that we have our context set up, we want to put it in the right place, which means we have to go over to app.js and we have to import it from the favorites context provider. So first of all, let me take this over here, duplicate the line and put favorites. And then I'm going to import it from favorites/favorites.context. And then what I'll do is I will wrap the top of the tree from the context provider perspective, and I'll wrap all of the context providers with the favorites context provider. And this will allow me to pass the methods down all the way through the tree. Okay, so now that the favorites context is set up over here, well, we can go over to our features. We can go to restaurants and we can go to the restaurant screen. And what we could do over here is we already have use context set up. So what we're going to pull in is the favorites context. And we're going to pull in that from favorites/favorites.context. What we'll set up here is a favorites. And we're going to pull that from favorites context. And if we console.log this, favorites, what we're going to see in our log is an empty array. And as we can see here, we're seeing the empty array show up after a re-render. And just to double check to make sure that this is the correct output, we can go and we can see empty array. An empty array is being pulled in 3 times because there's 3 different re-renders. Because the data comes in and the loading and all that good stuff. So we know that our favorites is set up here. But now what we need to do is we need to figure out, okay, how are we actually going to hook this up? So let's remove this real quick and let's start thinking about it. We don't want to prematurely go ahead and build a feature without thinking it through. When we looked at our screen, what we saw was that there was a little heart icon in the top right-hand corner of every single one of these cards. So does that mean that we should go ahead and go into the restaurant info card component and build a favorites icon right inside of here? Well, we can do that. We can definitely do that. We could go ahead and put it right beside the restaurant card cover. But the issue with that is going to be that there's also logic coupled to this favorites button. So first off, let's go ahead and declare our favorites button. We're going to call it favorite. This is going to be the feature that we're going to hook up here. So we're going to say, hey, we're going to have a favorite, and let's call it, well, it's not really a button. It's more like an icon. So we're going to call it favorite in this specific case. So the favorite is going to position itself right along here, right next to the restaurant card cover. And where are we going to declare it? Well, that's a good question, because the favorite icon needs to work in a lot of different places. So we could potentially declare it as a component. And what we could do is we could say, here's a new folder called favorites, and we'll put our favorite.component.js in there. And that's going to be the component that holistically wraps the ability for us to favorite something. So how would that work? What we're going to do in here is, first of all, we're going to get rid of the error. So we're going to import React from React. And then we're going to export const favorite. And we're going to say that that is a component that returns null for now. And then we're going to go into our restaurant screen, and we're going to say import favorite from /components/favorites, favorite.component. And now we've gotten rid of the error, and we can start building out the favorite component. So what is this component going to look like? Because right now, nothing is visual. So let's close off our Finder here, and let's go look at how we would build out this favorite feature. And so if we look at it from a 10,000-foot view, what we're basically trying to get here is the ability to favorite a specific item. So what we're going to need here is use context, because we're going to need the methods from the context, and we're going to import favorites context. We're going to import that from /services/favorites/favorites.context. And we're going to say const, we're going to pull in favorites, we're going to pull in add to favorites, and we're going to pull in remove from favorites, our three methods. And we're going to do use context, favorites context. So now we've pulled in everything we need to kind of get it going here. There's something else we need here. First of all, we need our styled components from styled components native, because we're going to add some styling here. We're going to add some nice styling. We're going to add something called ant design from vector icons, because we want to put in a nice heart icon there. And then we're going to import touchable opacity. And let's do that from React Native. And what we're going to do here is we're going to say that the const favorite button is equal to a styled of touchable opacity. And we're going to give it very particular styles. We're going to position it in a very particular way. So here are the styles that I've kind of come up with. We're going to give it background color transparent. We don't need a border radius. We're going to give it a background color. We're going to position it absolutely, and we're going to play around with the top and right position. But for now, I've kind of given them free reign. We don't need to define a width right now, but what we need to define is a z-index to make sure that it pops up to the top. And we're going to put in the favorite button right in here. And what we're going to do with this is inside of it, we're going to put an ant design. And that ant design is going to be a component that is going to take in an icon of the heart shape. So what we're going to do is we're going to say name is equal to heart for now. And we're going to say that the size is 24 for right now. And with that, we're going to also define the color as red, just so that we can make sure that visually we're seeing what we need to see. And so right now we can see that it is rendering in the top right corner. So in the next video, let's look at improving the placement and actually hooking up the functionality. So now that we're here, we can actually look at improving the placement. And it's as simple as playing around with the top and the right position, because this will position it evenly both on iOS and Android in terms of positioning on the card. That's a good thing. We know that it's going to be positioned on the right spot on both cards. So 25-25 looks pretty good to me. That's a good position in terms of being able to add and remove the favorite from the favorite button. But there's one tiny little thing here that we need to improve. And that is, well, right now, we don't know anything that comes into this component. What this favorite component should take it every time is the current restaurant. So we should pass the restaurant to the favorite, and then it can determine whether or not it has been favorited. Once we get in the restaurant, what we can say here is that we can determine const is favorite is equal to the favorites dot find of the restaurant in the list dot place ID being equal to restaurant dot place ID. And this will tell us whether or not it exists in the array of favorites. And so what we'll know then is that, well, we can do more complex interactions. For instance, if it is the favorite, what we can say here is do a heart, otherwise do a heart outline, heart outline. That is one of the basic functionalities. And then for color, what we want to do is if it's favorited, do red, otherwise do white. And so right now we can see that nothing at all is favorited. So now we need to add an onPress handler in order to make sure that we can actually add things. So this is going to expose a function where if it is not a favorite, we're going to add to favorites the current restaurant. Otherwise, we're going to remove from favorites the restaurant that was passed in. And so with this, we have the full-fledged functionality of the favorite button. And we can see that because when we click here, now it's added to the favorites. It's being added to the favorites in every given circumstance. That's amazing. So right here we can see, all right, this is looking good. This is looking good. And we have all of our favorites selected now. And we can deselect favorites. And if we console.log our favorites array, what we'll see here, console.log favorites, we'll do .length so that we can see the length of the array. What we can see here is if we scroll to the bottom, it's going to be 0. So it's 5. And if we scroll to the top, 4, 3, 2. And so what you can see here is that it's rendering the amount of times that the list is rendering. So the favorite button, of course, has to render for every single restaurant. And so it needs to determine for each individual restaurant if it's in the list or not. And so if this were a list of 100,000 restaurants at any given point, this would be a performance bottleneck. We wouldn't want to run the isFavorite function in this way with a .find. That being said, we're only finding against a small subset, right? If we had a favorites array that was 100,000 items large, we're having a bigger problem. But for now, this logic works just fine in terms of being able to verify the current instance against the favorites array, because our favorites array is going to remain small. Now, as we gain a larger and larger list, there may be optimizations that we can make to this isFavorite logic, but that would be a premature optimization. Okay, so with that in mind, right now we have a fully fledged feature. We're able to add to the favorites array. So next up, what I would like to do is I would like to be able to view all my favorites in a list right above the list view when I click the icon over here. So let's go and take a look at how that would look. This is amazing. We now can see all of our favorites and we can heart them and we can unheart them in any given screen for the restaurant detail. And that is absolutely amazing. Now, one thing we also need to keep in mind here is that if we want to build a favorites bar, what we're going to need to do is we're going to need to track some state here because we're going to toggle and untoggle it at given points. First things first. Over here in our restaurants, we have a search component. And in the search component, we have the ability to give it an icon. And that icon value, we're going to currently set it to heart. And what we're going to say here is that it's going to be a clickable element. So we're going to do an on icon press, and that's going to be equal currently to a null method. And so as you can see, it is now a clickable element. Okay. So now we need to set up our state to be able to track. And the restaurant, or rather the favorites bar, is going to be a feature that is going to live right underneath search. So this component is going to need to track some state. We'll use state. And what we'll say here at line 31 is const is toggled, set is toggled, is equal to use state false. And this will be the method that we will pass into our search container, and we'll call it on toggle. We'll say set is toggled equal to the opposite of the current is toggled. So we'll invert the is toggled each time it is clicked. And this will allow us to toggle it on and off. Now that we've given it a method, what we can go do is we can go back into our search component and we can say here, well, first of all, we also need to pass the is toggled state. We'll say is favorites toggled. And then we'll also do on favorites toggle. We'll give it a bit more of a semantic reasoning here. And on the inside, it's okay if we name it is toggled, but for search, we need to give it more of a name. And so in search, we're going to take in the prop is favorites toggled and on favorites toggle. And we're going to run these. So on press is going to run on favorites toggle. And in the icon, we're going to say is favorites toggled, do a full heart. Otherwise, do a heart outline. And here we have to say full on heart outline. And that's going to allow us to toggle off and on the heart. So here we can see we're toggling it on and off given the state. So we're able to toggle the favorites bar on and off. Now we don't have a favorites bar yet. So what we need to set here is toggled and we'll set up a favorites bar. And this favorites bar is going to come from the same place that favorites comes from. So we're going to say favorites bar comes from components favorites / favorites bar dot component. And over here in favorites, we're going to set up a favorites bar dot component dot JS that's going to import React from React and export const favorites bar, which is equal to, we'll quickly put something in here. We'll import text from React Native quickly. What we'll do with this text is we'll say text favorites bar. And so if we visualize this out in our component, what we're going to see here is favorites bar, no favorites bar, favorites bar, no favorites bar. Okay, so now that we have the framework set up around the favorites bar and being able to toggle and untoggle the favorites bar, and we set up that infrastructure for the favorites bar, we can start building out the visualization. So let's get into that. Now that we have everything in order for the favorites bar and all of the different parts set up that we need, what we can start doing is building out what the favorites bar is intended to look like. So first of all, what it needs to take in is the current favorites. That is what it will be consuming. And then once it has the current favorites, what it's going to return is a styled view. So import styled from styled components / native. And we're going to create a component that's called favorites wrapper. And that's going to be a component that is styled.view. And we're just going to give it a basic padding. We're going to give it a padding of 10 pixels all around. That's all that it needs. And so we'll take that favorites wrapper and we'll render it out. And inside of that favorites wrapper, what we're going to need to do is we're going to need to put in a scroll view from React Native. Scroll view. And that scroll view is going to work basically as our horizontal navigator. So we'll put in a scroll view and we're going to put in the following properties on it. Horizontal and show horizontal scroll indicator false, both of which are necessary to make sure that our scroll view goes in this direction, right? This direction, not this direction. So from left to right, not up to down. Once we have our scroll view set up, what we can do is we can say favorites map. I'm going to copy a code snippet here. What we can say is favorites.map, and then each individual restaurant is going to have its name, and we're going to split and join it. That's a potential that you could do on the key. We don't really need this, but it's an option. And we can say that we're going to have a const. You know what we'll do? We'll have a spacer here that is going to be of type left. So position left, and size is going to be equal to large. Or you know what? Let's do medium. So we're going to have a spacer here because we had a view that basically had an inline style, but we don't want to do that. So we're going to import spacer from ../spacer/spacer.component, and that's going to allow us to space the compact restaurant info, which we also need to import from ../restaurant/compact restaurant info. So it's going to be a very basic setup here. And then what we're going to say is that the key is equal to key right here. Once we do that, if we go over here to our overview and we open it up, undefined is not an object. Favorites bar isn't receiving favorites, of course. So we have to go over to the restaurant screen and we have to make sure that we, in the restaurant screen, import the restaurant context and the favorites context specifically. So favorites context from favorites/favorites.context. So once we have our favorites context, what we can go do over here is we can use the context favorite context. We can pull in the favorites, the current favorites, and we can pass them to the favorites bar like so. Now, I hear you asking, Mo, why do it this way as opposed to having the favorites bar just use the context directly? Well, the reason for that is the favorites bar should be able to receive its favorites at any given point from anywhere just as a prop. It should be something that flows in. And so the question then becomes, well, why didn't we do that to the favorites component? Why does that one take in a restaurant but kind of hook itself on to the context? And that is because we consider this favorite to be more of a module. It's kind of a self-contained feature of sorts. It interacts without any outside help, and it's just there to position itself. If we were to take in all of these different methods from the outside, it would defeat the purpose. We could even go so far as to put this inside of a module favorites folder, but I decided to leave it as a favorite.component. We could even potentially rename it to favorite.module, but all of those are semantics. It's just the reasoning behind why we're doing this. If we look now at our favorites bar and we open it up, oh no, element type is invalid. Expected a built-in function. So there's something going wrong here. So if we look at favorites bar, it's importing from, accidentally undid it. So this should be from favorites, and then it should be favorites bar dot component. And this should allow us to render out nothing. Well, that's new. And that's because we don't have any favorites. So once we start clicking favorites, oh, there we go. There are our favorites. This is looking good. So we can import all of these. And as we import all of them, you can see them pop up here. And once they pop up, they basically become usable right out of the get-go. And so removing them will remove them from the list in the position that they were in. And so we can quickly see here that we will push them to the back of the stack. If we add them back, we can hide and show our favorites bar. But there's one crucial thing missing. In the favorites bar, we're unable to click on the compact restaurant info. And so one thing we would want to do here is add a touchable opacity. And once we add the touchable opacity, we would add it around the compact restaurant info. And on press, we would say navigate. So on press, we could say go to detail. And go to detail would come in as a prop. Or we could say on detail. Let's call it on detail. And when we say on detail, what we're going to do here in our restaurants screen is we're going to pass it a function to go to onto detail. And that's going to be the same function that we basically use over here, but we're going to pass it in here. And we're going to say on detail equals, and we're going to pass it not the full navigation, but we'll pass it navigation.navigate. And that will allow us to go inside of favorites bar. Let's call it on navigate. That feels better. On navigate. And then in the restaurant screen, we'll call it on navigate. And then we'll be able to copy the same body that we put inside of here. And when we go inside of our favorites bar, then once we have the touchable opacity, what we can do is we can say on navigate as a function return. And there we go. That'll work a bit better. Now we don't have any favorites. So once we add them, we can quickly see here that we can know if they are favorited or not. And once we click them, we know where they are. We can go see the detail of them. That is absolutely amazing. And so now we know all of our favorites. A little thing we could add here to the top is potentially some text. So let's import text from /typography/text. And we'll add some text with a spacer around it right up here. And we'll call it favorites. And so now we know that we're looking at our favorites, the things that we favorited so far. And that allows us to better understand, hey, what is going on up here and what are we looking at? Amazing. So we just built out our entire favorites bar, but there's a small issue. When we reload, we lose all of our favorites. And so nothing is rendering out. And so we shouldn't be rendering out if we don't have any favorites. So one thing we should add into here is a return up here. And then down here, let's close it off. And what we'll do is we'll say up here, if favorites.length does not exist, right, is 0, then we'll return null. We won't return anything. So just to make sure that we don't render anything out in case, that way we kind of know, hey, we don't have any favorites. And then once we select one, okay, it's pretty obvious that it will show up in the list. Great. But we also need to figure out how we're going to store favorites, how we're going to store favorites between sessions even. So let's take a look at that. We've hit this proverbial wall because now we're able to add favorites. And when we add favorites, they're immediately visible when we go to our favorite screen. And that's absolutely amazing, right? When we trigger our favorites bar, we can see all of our favorites and we can remove the favorites and see it happen. But we have a problem. When we reload, all of them disappear. So they're not being persisted. And that is a consequence of, first of all, our favorites being in local state, and second of all, us not storing it anywhere. Now there's two options. We can store it on a server or we can store it on the phone. And I'm always a fan of these types of information. It's good to store them on the phone because it's local information. And eventually, if we do get to a level at which we have infrastructure backing the app, we can move it out, but it's good as a caching mechanism, as a secondary caching mechanism as well. Store the first 20 favorites so that the user doesn't have to wait on an API call or whatnot. There's different reasons to store locally. For now, we're going to store locally because we do not have a server environment, and we do not need one because a user has a limited cap on how many favorites they're ever going to store. You're never going to have a user with 100,000 favorite restaurants. I don't think a person can like more than 4,000 or 5,000 restaurants. And even then, how long would it take them to get there? By then, we would already have our infrastructure. So it's a premature optimization. So then we have to ask ourselves the question, well, how are we going to store locally? In React Native, we have the concept of async storage. But oh no, well, what is this about? Deprecated? It's been deprecated? React Native deprecated async storage? Oh, and this is why the docs are oh so important. React Native has a lot of moving parts. Things move all the time. And so it's important to keep on top because as React Native grows as an ecosystem, so does its support. They're moving things out of React Native and into external packages because they should not belong to core. And so it's saying use React Native async storage instead. And so when we look at React Native async storage, it can store string data, it can store object data, but you need to serialize it first. So it's saying you can use JSON stringify and JSON parse when loading. Well, that's pretty good. And so with that, well, what does Expo say? So let's do Expo async storage. And when we go look at the docs of Expo, which is also always useful when we're looking at high-level features, it says use React Native async storage, and it has an Expo install command even. This is amazing. This means we have first-class support for the package that React Native is telling us to use. And so with that, let's go ahead and run this command. And if we open up our terminal over here and we open up the terminal 2 and we run the Expo install command, while that's installing, let's go look at the usage. If we look at the usage in here, it says import async storage from React Native async storage /async storage. Now, that's a whole mouthful. Try saying that 3 times fast. And if we go into our code, where we want to import this is inside of our favorites context. So at the top, we're going to import async storage. And we're going to go look quickly at how this works. So it's saying store data is an async function. This is a sugar for a promise. This is kind of the same as doing a .denable something that we saw earlier in our promises. An async await is a different way of writing it. And so we can say store data is an async function that is awaiting async storage.setItem. And then when we store an object value, it's JSON.stringified. So if we have a complex object, which is what we're going to store, we're going to JSON stringify it. And then if we want to read the data, we can do an async function again, where we're going to await async storage.getItem, and then check if the item has a value, otherwise catch the error. This is pretty good, isn't it? And what we can do here is we can go ahead with this and we can try to directly implement these methods. So let's go inside of here, and we've now installed React Native async storage. And so let's quickly implement our functions. So it said that we needed a const store data. So let's call that, first of all, let's call that save favorites. That sounds better. We'll call that save favorites, and it's an async function. And what it's going to do is it's going to do a JSON value of a value. And in case of an error, let's console.log the error, just in case. Now, we're also going to need a load, so reading the data. And so let's go ahead and do const get data, like they did over here. Let's call that load favorites. And so with these two functions, we're basically set up to put together our favorites. But we need to give it a proper storage key. So let's say @favorites. That's going to be our storage key. Okay, so now that we've set this up, what we need to do now is if the value is not equal to null when we load it, well, then we need to set it to favorites, right? But we need to JSON parse it. Set favorites, JSON.parse, and we need to do value. value is basically the equivalent of getting our favorites. And if we have an error, let's console.log the error just in case. And let's say error loading as a prefix and error storing as a prefix, just so that we know which error is which. And so now that we have this basically set up, what we need to do is we need to grab our use effect. And once we have our use effect, we can start implementing how this is going to work. So right here below the remove method, let's put a use effect. And let's say that the use effect is going to listen to any change in favorites. And anytime favorites changes, we're going to store the favorites. So we're going to do a save favorites of favorites. And that's going to be what we want to store. Okay, so now we have that use effect where we're going to save. But now we also need to make sure that we load the favorites, which means we're going to load favorites every time on the very first mount of our context. We're going to make sure that we load the initial favorites. Awesome. So with all of this code, are we set up for success? Well, let's go take a look, because that wasn't a lot, and we basically know now what exactly is going on. So let's just restart Expo inside of here, and let's make sure that everything works as intended. So if we load MealsToGo here, what we can see is that once it loads up, in the very first instance, we're not going to have any favorites. But once we start saving favorites, so we'll save the first two, and then we'll showcase the first two. If we now reload our app, we should still have them saved as favorites. So let's take a look. Ah, amazing. They're still saved as favorites, and I can still see them here. And if I go to Antwerp, and I search for Antwerp, and this starts loading, and I save a favorite from Antwerp as well, and I reload, what I'm going to see here is that load favorites on the very initial load of my context is going to load up my favorites from the async storage, so from the storage on the phone, and we have all of our favorites loading up in between sessions. So even if we close and reopen our app and we kill the app, we're going to save what we've stored so far. That's absolutely amazing. That's a big, big, big advance. But there's one more thing we need to do here, and that's select some favorites, because we need to pick our favorite restaurants, don't we? Awesome. This is a great feature. I love it already. Don't you? And so now we have 3 fully built features. We have our restaurant screen. We have our favorites implementation. We have our favorites saving and loading. We have our map view in which we can go and we can go to specific restaurant details. What's left? Well, there's quite a few things left. So let's look at that in the next video. Uh-oh, we have a bug. If we look at our restaurant favorites bar here, the images are loading on iOS, but not on Android. Now, why would that be? Well, remember when we originally set up the restaurant compact info to work in a certain way? Well, if we go look at compact restaurant info, if it was Android, it was going to load the web view. But we wanted that specifically only for the map view. So what we should add here is a specific trigger that we're going to check. And we're going to call it, well, we know that naming is hard. So we'll call it isMap. And we'll check if it is Android and it is map. Then we'll render the compact web view. And so on the map, we're going to go inside of the screen and we're going to say that the map callout, which is this component, over here, we're going to say isMap. And so this will allow us to render out the correct view for the favorites locally, right? In the favorites bar, we still want to use an image component even if we're on Android, because we specifically only had the bug with the image view inside of the map view. So we didn't want to trigger that logic when we weren't on the map view. And so that's important to note here. And so what you can see here is, of course, the images don't correspond because we're randomly selecting images. Of course, if I deselect and reselect, you'll see the image pop up. This is because we're randomly selecting images for each restaurant. And so this can happen. The images may not match up, but that's completely fine. As we can see, the feature is working as intended. And on the map view, we are still rendering out the images in the web view correctly as intended. So the bug fix for the map view is still there, but we aren't breaking the favorites bar in Android anymore. We've come so far from the blue and green screen we first started at. And our next focus point is going to be authentication and authorization. So the ability to log in and the ability to register an account so that you can log in. And logging in is the simple process of being able to fill in an email address and fill in a password. And if you fill in the wrong password, seeing errors, filling in the right password will then give you access to the app. And this entire back and forth is here because we want to have different users be able to use our app. Of course, we'll have the ability to log out as well as some personalized info from the account showing up to know who you are. Now, the question remains, well, how do we go about this, Mo? What are we going to use? Well, how are we going to build authentication? I've never done this before. Well, authentication is a kind of a procedure that now more and more is being offloaded onto these external services. And over here, you see something called Firebase. Firebase helps you build and run successful apps. So Firebase is one of those platforms where it's backed by Google and loved by app development teams because you can use it and have so many services out of the box for free. It can grow with your product and grow with your solution as your app journey begins. Now, if you look at all of the build products, you can see that they have so many different things going on for them. They have a build section, they have a release and monitor section, and they have an engage section. So you can literally go through the process of building your app with core infrastructure to release and monitoring your app in production, and also tracking specific analytics. They have such a wide plethora of products that they offer that it's almost ridiculous not to go with Firebase these days when you're starting off bootstrapping a product. Now, if we hit the Go to Console button up here, what we're going to see is that it's going to ask us to sign in. Now, in order to use Firebase, which is completely free to begin with, and in their particular Spark plan, you need a Google account. So for those of you who do not have a Google account, I recommend you create a Google account. This is in the form of a Gmail email address, for instance. So you need to go through that process of creating an account. And over here, you can see that you can fill in your first name, last name, and pick a username for your Google account, as well as a password. And so once you go through that process, what you're going to see here is that when you go to the Firebase docs outside of the console, if you go to firebase.google.com, then what you'll see here is that the Go to Console button will actually take you to your console for your particular Google account. Once we're here, we can start exploring, because the exploration is part of the fun. You can see here all of our Firebase projects, and right now what we want to do is we want to create a new Firebase project. So we need to give it a name, and we'll call it MealsToGo. Once we do that, we'll hit continue, and we're going to turn off analytics for our project right now because we do not need it. And we'll create the project. And now Firebase is going to go through the motions of setting up everything that is necessary for us and provisioning all of the resources that we require for all of its services. So it offers like authentication and databases and all of this good stuff. And so it just needs to make sure that it has everything hooked up properly for us for our project. And now that our project is ready, we're good to go. Amazing. So as you can see here, we start off on the Spark plan, which means it's a $0 plan. We don't pay anything. We don't have to supply payment information, and everything that we can use is absolutely free. And as we can see here, authentication is one of the main pillars. Authenticate and manage your users, as well as something called the Cloud Firestore. And there are many other build features. And so they've bucketed all of the features inside of build, release, monitor, analytics, and engage. And by doing that, they give us the ability to know, hey, here's what you use for this particular pillar. So inside of build, we're going to be focusing on authentication because that's what we need for our application. So if we hit authentication, what we're going to see here is that we haven't set up authentication yet. And authenticate and manage your users from providers without any type of code, server-side code particularly. So we're going to set it up as if Firebase is our server and it's going to be our intermediary for authentication. So we'll hit get started. Once we start with getting started, we can see here that it's going to take us to the authentication settings, specifically to the sign in method, because currently all of the optional sign in methods are disabled, which is not what we want. So we want to enable email and password. And once we hit enable, what we're going to see here, once we save, is that it will be set to enabled. And that means that we're good to go. Now, currently, we don't have any users for this project. And we can see here that there's all types of different analytics that we can see. Hey, how many people signed in this month? And the current billing period, last 7 days, yesterday, today. So we can see some type of in-depth analytics, as well as we can see all of the users that have registered, which we do not have as of yet. Okay, but it's set up, right? It's set up. Yes, it is. And so now we have to look at what the end-to-end integration is going to look like for Firebase. So make sure you have an account. You've registered a Google account if you didn't have one. You've created a project for MealsToGo. And once you've created that project, that you've set up the authentication the same way we have. And then we'll go into the next video where we look at how we're going to feed this back into our actual application. Now that we're looking at the end-to-end integration of Firebase into our code base, I can hear you screaming from the rooftops, Mo, we need a service. And yes, we do. But first we need to do a little bit more research about how we're going to integrate it into the app. And so if we go over here to the Expo documentation, they even have a guide on using Firebase. And they say things like Firebase gives you the functionality like analytics, databases, messaging, crash reporting, and authentication. And Google's infrastructure scales automatically, even for the largest apps. So if we look at the Firebase integration with the Expo client, they recommend using the Firebase JS SDK, which supports authentication, the Firestore, the database's storage functions, etc., on React Native. Other modules like analytics aren't supported, but we can easily extend that by using something like Expo Firebase Analytics. Okay, so Expo has gone through the motions of trying to cover every possible service that Firebase can give us. And so with that, we can go and say, hey, well, if we need to do this, how do we go about installing it then? Because, we know throughout the past of the course that usually there's an Expo command coupled to this. And try and true, they have an Expo install Firebase. So let's go through the motion of running that, and then we'll continue reading. If we go over to our terminal here, and we open our second terminal, and we run Expo install Firebase, while this is installing, we'll continue reading. So the Firebase console provides us with API keys and identifiers we need for project initialization. Oh, interesting. Okay, so we're going to need a specific configuration here. Oh, we're seeing a use case here. So we're going to import star as Firebase from Firebase, and then we're going to put together a configuration here with all of these different. What are these? Oh, an API key, an auth domain, a database URL. Great stuff. So Firebase is going to supply us with all of this information ahead of time, and then we're going to use that to initialize our app so that it can be linked back to our MealsToGo application that we set up here. So Firebase, somewhere in Firebase, we're going to be able to find this information here. Okay, well that's good. That's good. Now let's look at how that would work. Is Firebase installed yet? Not quite yet, but we'll go ahead and trek ahead a little bit. So we know here that we're going to have to import star as Firebase from Firebase. And so we want to inject Firebase at the right position in our application. And so that would be the entry point, which is app.js. There, we're going to import Firebase from Firebase, and we're going to also take into account the Firebase config that we need here. We're going to declare that just before the render function, just before the app declaration rather. And we're also going to copy this last line, the initialize app based on the Firebase config. And by doing this, we now have an initialize app, or do we? Mo, this isn't the right information. You forgot that we need to get it from our actual app, and that's true. So let's go over here to MealsToGo. Now, where would we find all of this information? I don't see it anywhere. And so what we need to do is we need to go back to project overview. And if we hit this little icon and we go to project settings, we're going to end up on the settings panel. And so once we're on the settings panel, we can see that we have all of these different settings that we can touch. But the one we need to focus on the most is if we scroll down right here, we have all of this information, project ID, project number, all of this good stuff, but we haven't configured any apps yet. And so the app we want to configure is the third one in this row. You can see iOS, Android, but because we're running React Native, we want to use what is called the Firebase Web SDK. And the Firebase Web SDK is nothing more than just a JavaScript software development kit that will work on React Native, like we read on the Expo documentation. So we're going to call it MealsToGo React Native, and we're going to register the app. And once we register the app, it's going to give us all of this beautiful information in order to set up the SDK. So we're going to copy this bread and butter right here, and we're going to paste it right in our Firebase config. And by doing this, we now have all the information we require for the Firebase package to link itself to our Firebase app. So initialize app is going to take this config, and now Firebase is going to be able to talk to the app that we set up here originally if we go back to the console. And now whenever we authenticate, it's going to say, hey, do you have a user? Now we don't have any users yet for this project, and we haven't set anything up other than the linking of our React Native app to our Firebase app, but they're not really talking just yet. They just know of each other now. So now we want to make our app talk to Firebase and be able to get a response from Firebase. Let's look at how we're going to achieve that. A quick note here. Please do not copy my configuration, as I will be deleting my app post the course so that there is no possibility of integrating against the infrastructure that I put in place. So it would be a bad idea for you to go ahead and copy my configuration, as it will not work. Now you may be wondering, Mo, now that we have Firebase talking to our app and vice versa, how do we get this up and running? Well, that's a good question. We're going to do a small scale integration here in app.js, and then we're going to scale it out. So we're going to do useState and useEffect from React. And what we're going to do down here is we're going to say const is authenticated and set is authenticated is equal to useState of false. And so we're going to basically set if you're authenticated or not. Then we're going to implement the useEffect that's going to take in the function that we're going to utilize. And we're going to run it on mount of the component, so an empty array. Okay, now that we know that, what we're going to use is something called Firebase auth.signin with email and password. And this is returning a promise. So if we fill in email and password as a string, we know this isn't going to work, but we do .then. Well, in the .then, we should be retrieving back the user object. And if we have an error, it will happen in the .catch, and that will return us an error. So let's console.log error, and let's console.log user, and let's also set is authenticated to true if you do hit the truthy case. And so with this, basically our integration is good. But let's do one more thing. Let's go ahead and test it out. Let's open our console here and open our terminal. And then let's go over to our app and let's open it up. And by opening it up, what we're going to see happen here is we're going to see the logs pop up once it has loaded. And so over here, you can see error. Email address is poorly formatted. Okay, so this is not a valid email address, email@beanie.io. And if we do that, well, Firebase app name with default already exists. So this is an error we're getting because of hot refresh. So hot reload. We can't hot reload inside of React Native with the JavaScript SDK like this. So we need to do something additional because we don't want this error to come back. And you can see that it's just because we're hot reloading. Anytime I change a line of code, it's just, as you can see, there's no user record, etc., etc. But if I update, oh, it's going to break again. The Firebase app name with default already exists. So this line is breaking because we're running it too many times. So what we want to do is we want to check if not firebase.apps.length. Okay, so we want to check if you have a Firebase length. If you don't have a Firebase length, so we don't have Firebase apps running in here, run the initialize app. Otherwise, don't run the initialize app so that we make sure that we only ever run it once. And now if we update our code, we can see that it is continuing to refresh and everything is working as intended and there's no more crashes. But now we're seeing the error. There is no user record corresponding with this identifier. All right. So let's go ahead and create a user. Let's go inside of Firebase directly and let's go inside of authentication and let's add a user. And let's say that the user is mo@beanie.io and let's give him the password test. Let's add the user. Oh, test, it must be 6 characters. Test123 then. And then once we do that, we'll see here that we have this user in our user base. So if we do mo@beanie.io and password, well, now we can see the password is invalid. So if you fill in test123, well, now we're getting back the user object. And as you can see here, the user object has a lot of information. We can see here that it's coming from the app MealsToGo, what the email is, if the email is verified or not, when they last logged in. We can see the display name and all that good stuff. We don't have very much information for our user, but we do have their email and we know that they're authenticated because they authenticated against Firebase. So if we remove this log, we now know that you are authenticated. So what we can do here is we can do a shorthand. We can say, hey, if you are not authenticated, and let's do it below the usage of these hooks. If you are not authenticated, then we're going to return null. And then once you are authenticated, we'll return true. And so what we can see here is if we wrap this with a set timeout, and we set that to 2 seconds, what we're going to see here is that when we reload the app, we're going to have to wait for 2 seconds before the authentication kicks in. And then once you're authenticated, the app will render. So we could put a loading indicator here, or we could put whatever else while you're authenticating. Now you can already feel like this isn't really scalable. This isn't really where you want to put your authentication code, nor do you want to hard code the inputs. And I can already hear you saying and shouting from the rooftops, Mo, this has to be a service. And you're right. So let's look at how we're going to take this basic implementation where we're just trying to play around with the authentication and then push it outward towards a more robust implementation that actually has a login screen and all of that good stuff. Now we're getting to the bread and butter of authentication. We've proven that once we give a sign-in with email and password of a correct email and a correct password, we're able to set our isAuthenticated flag to true because we're reaching the .then statement that has the user object. Now that we've proven that, well, this doesn't scale very well. This won't actually get us anywhere. So what we want to do is we want to remove this and we want to build an infrastructure that's going to last the test of time and be able to scale and potentially be able to change. So you guessed it, we're going to need a service. So let's create a new folder, authentication. And in that authentication folder, we're going to create a new file, authentication.service.js. This file is going to be the entry point for all of the logic that goes into the service. And it's going to be very simple. It's going to be a light wrapper around the Firebase method that we just called, which was the login request. And that login request is going to look a little something like this. We're going to create a function const login request where we have an email and a password. And then we're going to do firebase.auth, sign in with email and password. So it's a light wrapper around what we just did. But the bread and butter of this is going to be the context. So when we create the context, authentication.context.js, what we want to do is we want to do the same thing that we've always done. We want to import the useState and the create context with React. And we're also going to import Firebase because we may need a function from it at some point. So let's just set the scene here. Now, if we do export const auth context, authentication context, and then we do an export const of the authentication context provider, what we know is that what we need to return in order for our context to share its state is the authentication context dot provider. And if we close that off, what we can see here is that we're going to need to return the children. So let's just quickly grab those off the props. Once we do that, we can save. And now we have everything in our authentication context provider in order for it to wrap, but it doesn't have any state yet. So what do we need to return as the value to every function? Well, what we need to return is the user. Well, we're obviously going to have a user object at some point. We're going to have to return whether it's loading or not. We're going to have to return an error, and we're going to have to return on login, which is going to be our login request. Okay, knowing that, what does this look like? Well, we're going to have to set up our state in order for us to properly be able to return these values because they currently don't exist. And what we need to do here is we need to make sure that every single value from the state is being filled somewhere. Now, we're going to declare a function that's going to be called const on login. Now, you may be wondering, what is this function going to do and how is it going to work? Well, first of all, it's going to take in the email and the password. And it's going to allow us to be able to trigger our login function. And by being able to trigger our login function, we're going to be able to properly log a user in, but also track all of the state. Now we're going to need to import our login request from our login service. So /authentication.service. Now that we have our login request, we can say login request.then. Well, first of all, we need to give it the email and the password. Once we give it the email and the password, we can say .then. And when we trigger the method, what we can do is we can say, well, if we're in our .then, we have our user. So let's go ahead and let's set our user to user. Let's also set is loading to true when we trigger the method. And let's set it to false when we succeed. But what about the error case? Well, then we're going to add a .catch, and we're going to say when the error comes in, we're going to set is loading to false, and we're going to set the error to the error. And that's going to allow us the full, let's just quickly call this U, not to conflict with the outer scope of user here. Now this is going to allow us the full feature-fledged functionality of login. And with that, we can now go and actually build out our login screen because we're passing through all the values. But first, what we need to do is we need to make sure that the authentication context provider is available at the top level. So with that, we can then utilize all of the functionality subsequently in the navigation. Okay. Authentication context provider from authentication / authentication.context. Let's just remove the end here. And there we go. Authentication.context is locked and loaded and clearly available because our app is loading. And so with that being all set up, let's go ahead and look at how we're going to build out our navigation for authentication. Our context and our service are built out. Now remains the question, Mo, how are we going to get authentication to run when our app immediately loads on the screen? Well, let me show you. because this is an interesting concept that we need to work through. Now, if you remember, when we went through our setup, we set up this infrastructure folder, and the infrastructure folder had a navigation folder. And in that navigation folder, we set up the index file. And we set this up with a purpose back then. And that purpose was eventually to extend out the app navigator to also render out the authentication navigation at some point. This is that point, which we now need to make smart decisions. And so what we're going to do is we're going to import use context from React, and we're going to get the is authenticated from the authentication context. So if we go and we say import the authentication context, and we do that from ../services/authentication/authentication context, we now have the ability to know whether or not you are authenticated. And based solely off that, we can make so many smart decisions. So let's go ahead and import view and text from React Native. And what we can see here is that if we said something like is authenticated, ? Then we'll render app navigator. Otherwise, we'll render out a view with some text that's going to show us you're not authenticated. And this is going to allow us to build out our long-term goal, which is the infrastructure for authentication. And we can see right here, we're not authenticated. So what we would actually want to build inside of here is not necessarily the view and text. No. What we want to do is we want to build out something way better, which is the account navigator, which is going to be the account level consideration or feature with which we're going to interact with authentication. Because when we're talking about authentication, we're talking about authenticating an account. So let's build out an account navigator. That account navigator is going to come from account.navigator, and then we're going to go in here. We're going to say new file, account.navigator. That's going to allow us to basically build out everything we need in order to be able to log a user in. Okay, so if we know that, well, what does the account navigator look like? Well, we'll import React from React. We'll take in a navigation container. Mo, you told us we don't need a navigation container. We don't need a navigation container because it's already being used at the app level. Oh yeah, is it? Huh, I thought it was being used at the app navigator level. Oh, it's over here. Over here, we're using a navigation container. Okay. So because the navigation container is wrapping app navigator, we actually do need it in account navigator. Now, could we move it up to the index? Potentially. I like to put the navigation containers closer to the actual navigator that is using them. But in any case, it's perfectly fine to say, let's take the navigation container here and let's move it up a level, because we don't really want to duplicate some code just because. So let's take this, let's go over here, let's take that. And what we can do now is we can put this in braces and we can say, hey, return us a navigation container. And let's slash that navigation container. And then let's just put this code right inside of there. And that's going to allow us to render out the correct navigation container when we need to. And that way we don't need a navigation container here. So we moved it up from the app navigator. Both ways are completely acceptable, but this is slightly better because now we don't need to duplicate the usage of navigation container. Let's just structure our imports here. I don't like these imports mixing with these imports. Okay, so knowing that now, we can go back to our account navigator, and what we need to import is a stack navigator. So we're going to create a stack navigator, and we're going to just call it stack. And now what we need to do is we need to define what our screens are going to be. Now, for that, we're going to export const account navigator. That's going to return a function that's going to have the stack navigator set up for us. And we're going to do /stack.navigator. Okay, header mode none. We don't want a header in our stack. And now we can start setting up the stack screens. So first off, we're going to have our main screen, which is going to be just our screen where we kind of decide if we're going to log in or register. We're going to call that our account screen, but for now, let's just render out null. Well, actually, you know what? Let's render out import text and view from React Native just to temporarily put something there from React Native. And what we're going to do is put up a view with some text. And that text is going to be filled with /text, the account screen. Then we're going to have our login screen just as well. So we're going to have something called login. And we're going to call that login screen. I mistyped here. And now that we have both these screens, what we can do is we can go look and we can see that we are on the account screen. So that's the screen that's rendering when we're not authenticated. And what we're going to do on the account screen in the next video, first of all, we're going to build out what the account screen looks like. And then we're going to build out the login screen. And eventually we'll look at, well, how do I register? How do I log out? And all of that good stuff. We're in real good shape now. What we need to do is, as always, we need to decide, well, how are we going to build out the feature for this navigator? And with everything we've built so far, if we go look at our infrastructure navigators, the account navigator, the app navigator, the restaurant navigator, usually they're linked to a feature in some cases. In this case, account is linked to a feature. And so the feature is going to be called account. And in the account folder is where we are going to build out the majority of the code for the account feature. Now, inside of the account feature, we're going to define the screens folder, as we've done with so many other folders, right? And also, we're going to have a components folder, which is going to carry our components that may be shared across screens for this feature. And if we go and look at what screens we need to actually build, well, the screen we need to build is the login screen.js. This is the screen that is going to basically be the screen that will interact with the user to log in. But we're also going to need the account screen. The account screen is the entry screen at which the user decides whether they want to register or they want to actually log in. Okay, so knowing that, let's also preemptively create our register screen.js. And we're going to fill these with temporary information for now, but in any case, what we need to do inside of here is we need a couple of imports. So we need our, good question. What does this screen look like? Let's go look at what the screen looks like so we can determine what we need. And if I go home and I open the ZTM app of MealsToGo and I quickly log out, what we're going to see here is, okay, we need a backdrop. So we're going to have a background image. And then we're going to have a small section where we have a login button and a create account button. And we're going to have a title over here, MealsToGo. And then at the end, we're going to add in this amazing animation of a watermelon. Where do we start? Well, let's start with the image backdrop. Okay. Knowing that we need the image backdrop, well, we're going to need to import a couple of things. First, let's start with const account screen. And let's set the scene for us to be able to actually build out what we need. And let's return. So the question now becomes, well, how do we do an image background, Mo? And if we go to React Native, what we're going to see is we're going to have a image background component. And this is a common feature request from developers that they want to use a background image like they would on the web. And so the image background component provides the same props as a normal image component, but it works in a different way. It works in allowing us to set up an image background for our app. Now, what we're going to do here is we're going to set this up so that we can render out the background image that is required for our account screen, login screen, and our register screen. So all three screens are going to use the same image background. Now, what I want you to do as an exercise is I want you to go here and I want you to take all of this into account. And what I want is I want scalable code to be created. So I want us to go inside components and create something that is called maybe account.styles.js, and we're going to create a styled component that is an image background, and we're going to use it across all three screens. And then we're going to utilize that in order to create consistency among all three screens. Now that is the exercise, and in the next video, we'll look at what the solution looks like. So in the end, this is what we should be able to see when we put in place our image background. Now on the previous video, you will have found a resource in the resources on the video in order to get this particular image, but you can load any image you want. Honestly, take whatever you want and use that as long as you find that your app looks amazing. Now, if we took a look at the code, what happened in our account navigator is that we set up an extra screen. So we set up an extra screen that basically was the register screen, because initially we didn't have this. So we had a stack.screen for main, which is the main account screen. We had a stack.screen for login, which showed us the login, and we had one for register, which showed us the register screen. And we imported these all from the feature authentication screens. Okay. So like I said, in authentication screens, we set up an authentication.styles.js. Now, in that styles.js, we can set up something called an account background. Now, you may have done this in a different way. This is what I personally find the most optimal way to set it up, but as long as you got it working, that's what's most important. And great job on that, by the way. This is not easy to achieve in the particular way that I did it over here. Now, with that said, what we want to achieve here is, and if we look at the code, we import styled from styled components native, and then we set up a component called account background. Styled.imageBackground is the React Native element that we wanted to target. And so we wanted to give its particular attributes, and we've done this in the past. And when we target attributes, we can basically set props on the image background hard-coded. So the prop that I wanted to set on the image background hard-coded is something called source. And the source points to the image that it's going to load as the background. And I set it to require ... and so forth to the assets folder, the home background component.jpg. And then I set it to flex1. I gave it a background color, which is not really necessary. You could honestly leave this out and it would still work perfectly. I was testing some things out when I did that. When we do align items, however, we're trying to make sure that anything that comes inside of it is particularly flex aligned, because we want to center the information. Okay. So this is the initial way that we can do it. And then if we look at account screen, basically account screen just became an import of account background where we just render it out. And then the login screen became the exact same thing where we did the exact same thing. And the register screen does the exact same thing as well. So all of these will render this as a background. And it's that simple. And now look at how beautiful this looks. This honestly looks like a real application, like a real MealsToGo app. We could compete with Uber Eats easily. Easily, I tell you. Okay, so now that we have this in place, what I want to do next is I want to fortify our account screen and start building it out a bit more. So let's go ahead and do that. Wouldn't you agree that this image is a bit stark? We want to lighten it up a bit. It's kind of overpowering. There's too many colors going on. So to lighten it up a bit, what we're going to do is we're going to create an authentication cover, kind of like something to cover the background image, and we'll call it export const account cover. And we're going to say that it's a style.view, and we're going to give it a good style here. We're going to spruce it up a bit. Now, what do we want it to look like? Well, if it's going to cover the entirety of the screen, well, we don't want it to conflict with anything else. So we're going to give it a position absolute, because we just want it to fill up the whole screen. We're going to give it a width of 100% and a height of 100%. And we just want it to overlay, basically. We want where we put it to overlay everything. So it's kind of like a stack. We want it to be all the way at the back of the stack, and we just want it to look nice. Now we're going to say that this is going to have a background color, which is going to look a little something like this. It's going to be RGBA 255, 255, 255, and we're going to give it a opacity. This is the opacity parameter of 0.3. So we're going to say, hey, it's only this much visible. Now let's look at what that looks like actually, because I can say that all I want, but the visual speaks more than words, doesn't it? Account background, let's close that off. And then let's go inside of here and let's get our account cover going on. And let's self-close that tag. Let's import it. And once we have that, what's going, oh, this is the register screen. Well, first of all, I need to be on the account screen, which is the one being rendered right now. And so once we're in this screen, we'll do account cover. And then we'll open up the tag here of account background. And we'll put the account cover in here. And once we do that, automatically a bit lighter. And you can see here, if we play around with the opacity, we put it at 0.5, 0.6, 0.9, it's going to get lighter and lighter up until we don't see anything. 0.3 for me felt like the best middle ground. You can put 0.4, 0.2 would be a little more color interfering coming in. 0.3 honestly for me was perfect. And so I kept it at that level. And let's look at what's going on Android. And if we open up that app in the Expo, we'll see the account cover pop up as well. Now, playing with the aesthetics of these things obviously can be a bit like tinkering. You want it to look nice for your visual. It doesn't necessarily need to be the exact same thing we're doing. You could even do a light blue background. Let's do 25. You could do something like this and give it a blue opacity. You know, it really depends on the eye that you have and what you find to look nice. Personalize this app as much as you need to. And as we can see here in Android, looks exactly the same. Beautiful, absolutely stunning. Uber Eats, we're in right straight competition with you with our meals to go. Just joking. We can't compete with Uber Eats. That being said, visually very pleasing app. Now that we've lightened up our account background, now comes the most important part, building out the content for the screen. And in order for us to do that, what we need to do is set up some styles in order for us to create that centricity or that feeling of content on the screen. So originally we set our account cover to have a background color of 0.3. Now what I want us to do is I want us to build a container that's going to basically emulate that same feeling. And what we're going to call it is export const account container. And that's going to equal a styled component, or styled view rather, that's going to have a background color of a higher opacity, or a higher opacity of white. So it's going to look a little bit more white. We're going to set the padding to the proper spacing. And then once we have that, we're going to go to our account screen. And what we're going to do is we're going to bring in that account container. And that account container is basically going to contain the interactable items that are available for that screen. And it's going to create this effect that basically counteracts what we're typically seeing on the lightened background. So you see here we have a slightly more white, but still high opacity block. And so in that block, we can then go and put elements in order for us to log in or register. I hear you thinking, Mo, how is it we've built almost an entire app, yet we haven't used a button yet? Well, we have used a couple of different types of buttons, but they've more been interactable elements rather than specific button presses. Now, you may be wondering, well, how do we use a button? And over here in React Native, there is a button component, a basic button component that should render nicely to each platform with minimal customization. Now it also says if this button doesn't look right for your app, you can build your own using the touchable opacity or touchable without feedback. And this allows you to basically build circular buttons or kind of customized buttons that need that little bit of extra pizzazz. For our use cases, the regular button should work just fine. So if we go back into our account screen, what we can do here is we can go into account.styles and we can specifically style a button by doing export const auth button equals styled.button. And then what we're going to do here is we're going to adjust the attributes specifically. So if we do .attributes and we go in and say that we want to specifically change the color, well, the way that we would do that is we would change the attribute color. So if we set color and then we set it to, if we go look at our colors.js, we can import the colors from over here, and then we'll probably use brand.primary. So if we do import colors, and we do that from infrastructure/theme/colors. And once we import colors, we can use colors.brand.primary. So we'll set colors.brand.primary. And the reason we have to import colors here is because the theme is not available when you set the attributes here. So if we go look at that now, and we went into our account screen first to set up the button, meaning going here and then saying auth button. If we set our auth button with a title of login, then we can see here in the UI that the login is being set. But it's getting a very specific UI over here. It's not really looking like the Press Me button that is over here. So if we go look at Press Me, and we see over here, in iOS, it's specifically getting a UI that we don't particularly want. If we go look on iOS now and we say tap to play, we can see that it's going to do a UI specific representation, which looks a little like this. These are the iOS standard buttons. Okay, well that's not really what we want, is it? That's not how we want our auth button to look. Even though it works, it's just a piece of text and it doesn't really feel buttony. And given it's an iOS standard, we can see here on our Android device, for instance, that if we reopen, it looks like a real button. So we want that look and feel. Now, where can we get that? Well, maybe React Native Paper has something. So let's go look at React Native Paper. And if we look at React Native Paper, or React Native Paper, and then we go to the getting started, we can see over here that it has a button component. And that button component feels a bit more like an actual button. So let's go ahead and import that button rather than creating our own button based on the React Native button, because that isn't feeling quite right. Okay, so over here at the top, we'll import button from React Native Paper. And then once we do that, well, what do we need to do here? Okay, well, it kind of looks like this. It can have an icon. What do we need it to look like? Well, let's try this one out. Let's see what it looks like. So if we do this and then we say button, and instead of having it look like a camera, maybe we could try a different type of icon. So we'll say over here, login. Then over here, if we go to icons, what we can see is that it can use React Native vector icons or material icons. So let's open up the list and let's look for like a lock. And what we can see is that there's all different types of locks. There's a lock open outline. So let's use that one. We can put the icon in here and then let's see what it looks like on the screen. Oh, much better. Much better. That looks like a real button, doesn't it? But it's a bit purple. So how would we adjust the color of this one? Well, let's look for color. So dark, whether the color is a dark color. So this says whether the color is a dark color, a dark button will render with light text and vice versa. We can also give a custom color. Well, I prefer that much more. So if we said, for instance, color, and we said black here, what would it look like? Oh, well, that's going to render black. Okay. Well, that works. Maybe we could take this button and kind of customize it over here where we had our colors. So if we said export const auth button again, and instead of making auth button a styled button, we'll import the button from React Native Paper, and instead of using styled.button, we'll do styled button, and then we'll do .attrs, and we'll set the color to colors.brand.primary, and then we'll have a primary branded button. And over here, instead of using this, what we can do is we can import auth button, And we can use that over here and over here with a custom color. And if we go look at our, oh, that looks much better. That, oh, with the padlock, absolutely amazing. Nice touch focus. Looks beautiful. And now we can also create an auth button for registration. So if we go over here and we say auth button, and we remove the color over here because we don't need to set the color. It's already being set externally. And then we say, for instance, what should we set over here? Oh, register. That's the button we need. Well, they're pretty close to each other. So, you know, maybe we need a spacer. Let's import spacer from components/spacer/spacer component. And then we can say that the spacer has a spot right over here, right around this component. And let's space it from the top. And once we do that, okay, the space is good. We could maybe work on the sizing. And so let's go look at our spacer component once more. And if we look at our spacer component right here, we can see that it takes in the position and the size. So let's adjust the size specifically, and let's set that to large. And then, yeah, that feels like better spacing. But there's one more thing, and we need to like make this button look a bit more professional. So maybe we should add some padding to the button. If we add a padding where we do a props and we say props.theme.space 2. Would that look good? Yeah, much more breathable buttons, and they interact way better this way. Although you can see that the clickable area is centered, so you can see exactly where you're clicking. That's pretty nice. It's pretty neat. And so now that we have this set up, let's make them interactable. Let's make them go somewhere. And as we said before, whenever we have a screen that is directly linked to a route right here, which is main is account screen. If we go to our account screen, we should have navigation available. So we'll grab navigation here, and then we can say navigation.navigate, and we can tell it to go to login right over here, navigation.navigate, and we'll go to login. And then down here, we'll say navigation.navigate, and we'll go to register. So login and register. And that should do it. If we press login, there we go. We're on the login screen. If we press register, oh well, register with the navigate payload. So apparently we do not have a register route. Let's go look at our account navigator. Looks like I made a small typo. Very important to fix those. And so now if we hit register, we'll go over to our register screen. Awesome. So we have that full interactivity working, and it's looking pretty sweet. Next, we'll work on kind of getting the login screen and the register screen in a good state. And then we'll add on some nifty little things like the animation and the title and all that good stuff. Now that we've reached this point, the next exercise I want us to do is I want us to build out the full login screen so that we can actually already log in. So over here, there will be 2 text inputs, an email and a password. And in the email, we'll be able to fill in the email address and then the password. And if we fill in the wrong password, obviously it won't log in. We won't create any visual feedback just yet. But when we fill in the correct password, we are greeted with our application. That is the end outcome that we're aiming towards. And when we reload the app, obviously we'll be logged out because we're force reloading. Okay, so now that we have that portion, there's a couple of things we need to set up. First off, we need to add this is authenticated over here to line 29. That's something that needs to be in place. And then also we need to make sure that we have export const on the login request. On top of which, we need to make sure that we use the context that we've created in the login screen in order to create the actual intended output. I want us to use state. So we want to use the text input field from React Native Paper, and this will help us actually build out that input field. You can create a styled component or you can put it directly in place, whatever you see fit. Just try to build out the screen and do the end-to-end integration on your own. And in the next video, we'll look at the solution that I made so that you can have a path forward. Hopefully, having gone through that and trying it out, you would have come up with something that is relatively similar to what we see over here, which is if I do at moadb.io and I do test 1, 2, 3, and I try to log in. If I fill in the wrong password, it won't apply, but if I fill in the right password, then boom, we're in. And if I reload, then we're back to square one. Okay, so how did I achieve this? Well, over here in our account screen, what I basically did was, well, we saw that I changed the icon for register to email. There was a small typo over there. And then if we went over to the login screen, what we can see in here is there's a couple of things going on. First off, we can see over here we have an auth input, which is a new component. We also imported auth button, auth container, auth cover, account cover, and account background, which we all had, got a spacer, and got the authentication context. Now at the beginning, what we needed to do is declare two properties, email and password, which are a use state of an empty string, which will pass into our text input as the basic input. And then we grabbed the on login from the authentication context, which is what we'll use to log in the user. And if we scroll down here a bit, what we're going to see is that for these auth inputs, there are many different things we can use. So first off, I gave it a label email, and I gave it a value email. And then I said the text content type is email address. So, and to ensure that we pull up the correct keyboard, this is how we determine, first of all, what kind of text is going to be in the field so that it expects it. And then here we determine what keyboard type we're going to bring up. So both of these fields together ensure that we get the correct output for the user in terms of the experience that they want to fill in an email address. We do not auto capitalize, and on change text, we set the email to the value that is being entered. Then a bit lower over here, we have the password field. And in the password field, we can say we gave it label password. It's linking to the value of the password state, and the text content is password, so that we know that it has to be password, a password type entry. Now we're securing the text entry, which gives us this lovely little feel of the bubbles when we're filling in a password, which makes it feel secure. That's awesome. Couple of small fields and we're good to go. No auto capitalization, we turn that off. We turned on secure, and then we said on change text, set password. Now with all of these fields, we're able to basically get the exact field that we want for email and password. And then on the auth button, at the end, we put back the login auth button. And on press, we trigger the on login from auth context, which is email and password. And don't worry, we'll be linking the code in the resources as always so that you can go view this code. And by hitting that, we'll trigger login. Now, all of this code is basically what we need to integrate an end-to-end login flow with an optimistic feel. Optimistic meaning we're not handling edge scenarios just yet, like error cases or anything like that. In order to handle an error case, we would need to pull in the error from on login. And once we have the error, we can basically create an error scenario below the button or in between the button, wherever we want to place it. And we can put kind of a spacer around it. And what we can say is /spacer. And then we can do a version of error handling where we import our text component. Right over here, we'll import text from text.component, and we'll get it from /typography. And if we go over to our text component in typography, what we'll be able to see over here is that we have a text component that can take multiple different shapes and sizes. So we'll take on the variant error, and that's the one that will load into the text container. So right over here in our spacer, what we're going to say is text variant is equal to error, and then we'll put the error in between here. And once we do that, we'll be able to see any error that pops up from the login flow, which is a little addition here that we'll quickly introduce. And if we reload, what we'll be able to see when we log in and we fill in a wrong email address is we'll see an error pop up, or we'll see a issue pop up. Now what's happening here? It's meant to render a collection of children, use an array instead. So what exactly is coming in on error? Well, let's check that out. Let's console.log error right here, and let's see what exactly is going on. So if we see error, what we're going to see probably that it is multiple messages inside of an array. So if we go to terminal here and we scroll to the bottom, what we can see when we go to login is the following. We fill in a wrong email address, we fill in the password, and we hit login, and we're getting an error. And why is that error popping up? Well, if we scroll up, what we're going to be able to see here, right at the top, once we scroll past all of the errors all the way back up, is that the error is inside of an array. So what we want to do here is actually we want to call error 0, which will get the 0th element on the array. And if we hit login here, oh, well that's not going to work. Well, what do we do in this case? We can't call 0 on undefined. There's two options here. We can go inside our authentication context and we can say that by default, the error is an empty array, since we expect an array. Or the next thing we can do, and on top of that, maybe we'll do it in combination with something. We'll add an empty array here, but then next to that on the login screen, we'll also only conditionally render the error. So we'll wrap this with error and we'll make sure that we only ever render these the error part right up here rather when there is an error. And that way we can target error 0. And if we log in now and we fill in a malformed email address, a malformed password, what we're going to see here, no error. Well, first of all, we need to make sure that error.length, that we check that. And then when we hit this, we should see the error pop up. Still nothing. What exactly is going on? Well, let's take a look. Let's take a look in our terminal, because it's things like this that can pop up at any given point when you work with this type of code. So if we go over here and we say console.log error, what we'll see is here error is badly formatted, but error 0 isn't actually going to give us anything. It's going to give us undefined. Why is that? Why are we retrieving a piece of text but we can't render it? Well, it's not actually an array. It's putting brackets around it because over here we're returning it as if it's text. But if we did something like json.parse around the error, then we'll see over here in the login screen that it will interact as an array. So if we do error 0 now and we went over here to kind of like this and we press login, what we're going to see is, whoops, unexpected identifier error. Why is that? Well, it's not actually JSON. So what we want to do here is we want to do toString. And if we do toString, what we can ensure ourselves here is that if we render out error right down here, we don't target 0, and we save. If we go over here and we fill in a malformed thing, oh, okay. Well, that works. The toString helped. It's things like this. Small intricate details, like having to do e.toString rather than think that it is an array and then JSON parse it and then send you for a loop on that loophole of thinking that you need to work with the data one way or another way. And at the end of the day, this is all we needed to do. And that could cause a bunch of different errors that you don't want to run into. You don't want to walk into those types of errors. There's a couple of loose ends I'd like to tie up. First off, we initially didn't have a title. So I went ahead and I created a title component, on top of which we also didn't have really a way to go back here. Now you can swipe from the side, But on Android, that doesn't really feel natural either. So we also introduced this non-native back button just in case, with which you can go back. Now you may ask yourself, how do we do this? Well, over here in account styles, we first of all created this title component with a font size of 30 pixels. On top of which, in the account screen, we took that title component and just put it right behind the authentication cover, right underneath the account cover. And the same is true for the login screen. And then at the bottom of the login screen, we introduced a spacer with an auth button that also had a contained mode, which took an on press of navigation.go back, which comes from the navigation prop that we get because it's in a login space. But the other thing we did is to tighten up some loose ends is we introduced this nice feature where if we get an error, it's actually being displayed in the center rather than outward. And so if we do this and we, for instance, at moadbini.io and we filled in the wrong password, obviously we're going to get the error, but it's going to fill the space and not push out. And the way that we achieve that is in the account styles, we introduced this error container. And the error container has a max width of 300, just like the auth input, just like everything else. It has align item center, align self center, margin top of space 2, margin bottom of space 2. And that will constrain everything for the error. And so now that we've cleaned that up for the majority, one other thing we want to now achieve is, well, now that we can log in, what's basically going on, and here you can see an error, I pressed login way too many times. Now that we're able to log in, what about registration? And so let's take a look at that. Now that we have login, register should be a breeze, shouldn't it? And for the most part, it will be. What we're going to do now is we're going to go look at our authentication service and we're going to set some things up that need to be set up in order for onRegister to work. So we're going to say const onRegister. And in onRegister, we're going to say email, password, repeated password. And what we're going to do is we're going to call a Firebase method, which is basically firebase.auth create user with email and password. That's the function we're going to call. Now, there's one small issue with this. It doesn't do any password repetition verification. So what we need to figure out here is, well, how are we going to create an error? Okay, well, let's say if password is not equal to repeated password, then we'll do set error passwords do not match, and we'll return and exit the function. And that will allow us to check on what exactly is occurring. Now over here in the create user with password, what we want to do is we want to use that same .then.catch structure that we had here, because when we register successfully, we'll also be logged in. Now with that, what we want to do over here is we want to pass this onRegister into the value context, and then we can start using it. And so with this, we basically have everything set up roughly in order for our register screen to work. Now what I want to do is, first of all, I want to go remove the secure here. I had this because I copy pasted secure entry twice. Secure keyword does not exist. Do not use that. But the secure text entry does exist. Now let's copy paste everything that's in here. And let's just go ahead and rename this register screen because they look fairly alike. Now the main difference here is that register screen is going to have the repeated password. So set repeated password. And we're going to call this repeated password. And then we're going to, instead of taking on login, we're going to take on register. And on register is going to be passed to the button below. Now this is going to take email, password, and repeated password. And that's going to allow us to get the error back in case we do not have the password done twice properly. Now we're going to need a second auth input of the type password, which is going to be repeat password as a label. And we're going to give it repeated password as the value. Now the last thing we need to do is we need to use set repeated password, and we need to put that in place over here. Once we do all of that, what we can actually achieve over here is a fairly easy registration process by doing this. Well, of course, we need to use the right icon here, which is mail, and then we'll do a contained. Actually, what did we call it over here in account screen? Let's use the same one. It's account email. So let's do that. And then we're going to call it register. That needs to be correct. And so once we set all of these properties, what we can do now is we can do mo+1 at beanie.io, which is a syntax just to reuse the same email to register. And we can do test, and we can do test again. And when we hit register, oh, password should be at least 6 characters. So we already got our errors back. It was that easy. So if we do test 1, 2, 3, and we do test 1, 2, 3, well, now when we register, we should log in, right? It was that easy. We just built an entire registration function in that many lines of code. And it wasn't hard at all. We basically set up our service. We knew where to set that up. We knew where to hook it up. We knew how to do our repeated password logic. So if we do mo+2 at beanie.io, and we do test 1, 2, 3, and we do test 2, 3, 4, what we're going to see here is an error. Passwords do not match. So we set up all of the logic. We set up a register button. We basically copy pasted the entire login screen and tweaked it a little bit. And we already have everything working as intended. And if we hit the back button, it's going to go back. Absolutely amazing. Just like that. Built 2 full features. Okay, it took some setup on the login screen and you know, we had to go through some motions over there and make sure that everything was tight. But once we did that, we were in a good state to just build a registration function. No huss, no fuss. And if we go look at Android here and we quickly go inside and we say reload, what we're going to see is that it's going to work exactly the same way. When we load up the app, we can see over here our login screen looks exactly the same. Register screen looks exactly the same. If we do mo+2 at beanie.io and we then go to password test 1, 2, 3, test 1, 2, 3, we can see when we register, it's actually going to log in. Now, we don't have the instant feedback yet. Like, it was registering for a minute, but the button was still there. Now, that's something we need to solve for, of course, but you can see how instantly amazing this is and how simple it was for us to achieve all of this. Okay, so now that we have our registration set up, let's go tighten up some more loose ends. There's one more thing we need to do on login and register, and that's ensure that the user is being told when something is happening. And for that to happen, we need to grab the isLoading indicator. And when we grab the isLoading indicator from the auth context, what we also need to grab is some type of activity indicator. And so what I want us to do is I want us to grab activity indicator and colors from React Native paper. And so in order to do that, we'll grab this. We'll grab our activity indicator and the colors. And over here at the bottom, what we're going to do is we're going to say, if it is loading, question mark. We're going to show, if it is not loading, we're going to show the auth button. Otherwise, we're going to show the activity indicator. And this is going to allow us to switch between the authentication button, which is going to allow you to register, and the activity indicator, which is going to show you that something's happening. And of course, we need to do the same on the login screen, which means we're going to need to do the same import we did over here in the login screen over up here. And then once we do that, let's grab the activity indicator from the bottom right down here. And so now we'll grab isLoading from the authentication state. And with that property, what we can do over here is say, if it is not loading, show the auth button. Otherwise, show the activity indicator. And that will allow us to, again, tell the user that something is going on. And if we look at what that looks like, if we refresh here, we reload the app, what we're going to see on login is when we do mo at beanie.io, test 1, 2, 3, on login, we're going to see the activity indicator interoperate. And if we look on register, what we're going to see is if we do mo+3 at beanie.io, test 1, 2, 3, test 1, 2, 3, and we register. Something isn't happening on register. Why is that? Well, let's take a look at that, because that's strange. As we can see, we have a major problem right now. When we log in to mo@beanie.io with test 1, 2, 3, we're loading the exact same favorites for each individual user. So right over here, we can see we're loading these favorites. And if we reload and we log into mo+2@beanie.io, we're going to see the exact same thing pop up, mo+2@beanie.io, test 1, 2, 3, and we log in. We're going to see the exact same favorites load. Now, first of all, why are the exact same favorites loading? Well, we have an issue where we're not uniquely identifying each and every favorite. We're not uniquely identifying the favorites. And that's a problem. But the second problem is, why do we have to re-authenticate every time we reload? Why isn't the session persisting? So there's a twofold error going on here. Our authentication infrastructure is 98% set up, but we have a problem with the persistence of the session, right? Our user, when we reload, is technically still logged in, but for some reason we can log in again. And then on top of that, our favorites aren't being stored against the right user. Okay, so we have to solve this one issue at a time. And so the first issue we need to solve is we need to solve the issue of the session persistence. And in order to do that, what we need to go look at is the way that Firebase is set up in the authentication context. And over here, we can see that, well, if we log in, we're doing our login, our register, all that stuff is good. But we're not checking on app load if there is actually already a session. And so Firebase has a hook for that. Firebase has a hook that's going to go look for auth state changes. And it's called Firebase auth on state change. And that's going to take the user object and is going to say, well, if user, then set the user to user. And that's going to ensure us that, well, Firebase is going to go look, hey, did I previously authorize someone to log in? And if I previously authorized someone to log in, well, let's go ahead and use that user and log them in rather than still have an authentication session going on, but allow a different user to log in, because that creates conflicting state. We don't want to work with conflicting state. We don't want to have issues between different users going on. So when the app boots and we set up our authentication context, let's quickly go check if there's already a session going on. If not, completely fine. We still go to our account screen and we can log in. Okay, so now how do we log out then, Mo? You kind of basically broke the entire thing and now we can't log out. Well, good point. The way that we need to log out is kind of through Firebase as well. And so in order to get that going, well, we need to add right here an onLogout function. Oh, and I just noticed something. We're missing a set is loading to true for the register function right over here. And so that may cause issues. So let's just make sure that we always start loading when we register. But we need an onLogout function where basically we'll set the user to null and we'll call Firebase auth.signout, because that should always work. It's just going to clear state, so we don't need to use the .then.catch syntax. It will always successfully log you out. And so because of that, now we can take this onLogout function and we can pass it over here to the value. And we can quickly build a very simple logout function before we have our settings ready. Over here in settings, we can quickly go get a button from React Native. And once we have this button, what we can do is we can say button title is equal to logout. And we'll say onPress is equal to a function call of onLogout. Now we don't have onLogout right here currently, but if we import the authentication context from services slash navigate slash authentication context. Now we'll have it. We also need to import use context from React so that we can use the context. And if we quickly build it inside of our settings placeholder here, we can quickly put a button in place just to make sure that we have a full circle authentication. So const on logout is equal to use context of, and then we grab our authentication context from here and we'll plug it into this part. And once we do that, well, now we can go full circle with our logout function. By doing this, we now kind of have gone full circle. If we go to settings, we can press the on logout function, and that's going to log us out. Firebase no longer has a session now, and we can securely log in to another account without having any issues of potentially having conflicting state or anything like that. And so what we want to do is say test 1, 2, 3. And if we log in, now we're logged in as a different user. But we still have the issue of the favorites being persisted even though we have different users. So how do we solve that? Well, we've solved one fold of the problem, which is our authentication session issue. And the second fold of the problem is the favorites issue. Now that we've solved one part of the equation, which is the full authentication flow, finishing the full authentication flow end to end and making sure that Firebase has full control over our session and can properly manage our session, because you never want to fix a feature when your infrastructure is half built. Now that we've done that, how exactly do we fix the issue in here? And so one would argue that, well, the favorites context is broken because the favorites aren't uniquely identified, and that would be completely correct. So the first thing we're going to do is we're going to import authentication context, and we're going to import that from ../../services slash authentication context. And once we have that, we're going to import use context. And when we have our context here available, what we're going to do is we're going to say const, and we're going to destructure the user is equal to use context of authentication context. And by doing that, what we now have is the user object. Okay. Now, what we need to do here is we need to uniquely identify this in some way. Well, how do we do that? Well, we'll retype @favorites because that part was okay. And now we need some type of unique identifier between here in order to identify the user. Well, we have the user object right here. So how about we use user.uid? That could work. Well, let's just put UID then. We don't need to do user.uid. And let's make that a parameter of the function. The function takes in the user identity in order to save and load the favorites. And that way we uniquely identify the favorites at any given stage. Now we have to go to our use effects. And when we look at our use effects, well, we have one main problem. Load favorites only loads when the app loads. Doesn't reload when the user changes. And the same with the favorites. It doesn't resave the favorites when the user changes. So we have no idea here what the UID is. So we need to add user as a dependency and user as a dependency here. And we need to add a check to both. If the user has a value, then we'll load the favorites. If the user does not have a value, let's not try because we'll run into gnarly situations in that case. And then in that case, we'll add user.uid as the parameter here and user.uid as the parameter here. Would this solve it? Would it be that simple? Well, let's go take a look. So if we go into our login function now and we log in as mo@beanie.io and we do test 1, 2, 3, we log in and we see all of our favorites. What's going to happen here is basically when we log in, we're going to have the favorites for Mobini, which are these two. But when we log out and we, for instance, register mo +12 at beanie.io, and we do test 1, 2, 3, test 1, 2, 3, and hit register. Well, something's going to go wrong here because we're still loading the favorites of Mo. Why is that? Why isn't it unmounting? Well, let me show you. If we look at where the favorites context is loaded, it's loaded all the way at the top around the authentication context provider. Now this is a problem, right? Because all of these context providers are basically at the app level and they never, ever, ever get unmounted. Now, are they all our favorites, location, and restaurant absolutely necessary at the app level? They aren't anymore because now we have two navigators. So what we want to do is anytime our app navigator mounts, that's when we want these contexts to mount. Anytime the app navigator is mounted, right over here. So that around the tab navigation, that's where we want to add these. So we'll go ahead, we'll copy these, and I'll just take these, and then we'll save here, and we'll go over here, and at the bottom, we'll paste these. We'll make sure that all the navigators are there. And what we'll do now is we'll grab all three of these, which need to be at a lower level now. They can't be at the app level anymore. And we're going to put them at the app navigator level, right over here. And what we're going to do is we're going to make sure that they're imported from the right spot. So ... And we'll make sure that that's true for all of these. And this one as well. And once we do that, now all of these should be imported correctly. And if we go over here to our load function, okay, now we see that we're loading the correct ones for the user. But now when we log out, we should see when we register a new account, so for instance, mo plus 120, 123 at beanie.io, test123, test123. If we register that account, what we should see now is that it shouldn't be rendering the favorites of mo1. And that's because the context is getting unmounted. It's cleaning itself up. Previously, when the context was at the app level, we were unable to clear the app context. We were unable to clear the favorites context because it was an app level consideration. So navigation was rendering after all of the context. So the context never got unmounted. The favorite context never got cleared between sessions. So every session, the favorite context would stay the same and the favorite context would stay the same. And so what we learned here is that navigation plays a vital role in where we should load specific contexts. So at the app navigator level, once we're logged in, that's when we should start mounting the favorites, the locations, and the restaurants, because that's where we need that information. When we render our tab navigation, when we render our main app, when we log out, they should be cleared. And when they're cleared and we go back to the account screen, so we load up a different navigator, all of these are unmounted and thus their memory is cleaned. When they were at the app level, they stayed in memory. So now what we can see is if I do mo plus 2 at beanie.io and I do test123 and I log in, what I'm going to see over here is that when I load up mobeanie2, I'm going to load up mobeanie2's favorites. So I'm not going to load up mobeanie1's favorites. And when I log out here and I log into mo at beanie.io, that's going to enable me to load up specifically mo at beanie.io's favorites. So we solved that problem, but the bug was so niche. It had to do with code structure. It had nothing to do with the actual implementation. It had everything to do with the way and the place that we were structuring our contexts. So putting all of the contexts, right? All of the context at the entry level is not always a good idea. It isn't always the best plan. We need to put the context in the place where they're needed. Because we were loading the favorite context all the time and it never got unmounted, even though we were logging out, even though we went back to the account screen, and even though we were loading a completely different navigator in the account navigator, right? Because we swapped them out here, we weren't clearing the state properly, and that was causing issues. Now, the best way to solve this is, of course, to put the context inside the app navigator. There are other ways to clean this up in order to make sure that you can potentially inject it at the app.js level, but in my opinion, that would just be hacking around context, because context should only be used in the spots where it's necessary. And when it's not necessary anymore, you don't need to keep it in memory anymore. Because why would we keep favorites, locations, and restaurants in memory? Those are a consideration of the user being logged in. And if they're a consideration of the user being logged in, that means that when we go look at index.js, they should only ever be loaded if we're authenticated. So they should only ever be loaded if we're loading the app navigator. And that solves our bug. Amazing. Time to button up some more things, but on top of that, we're going to build one more thing. So if we go home and we load the original MealsToGo app, what we can see here on the authentication screen is what looks like a watermelon from Lottie animation. So we're going to import a custom animation here. And before we do that, we're going to do a little bit of cleanup, and then we're going to go look at how we do this. Well, so one thing we noticed in our app that is kind of breaking the user experience, so to speak, is we don't have a background color set. So what we want to do here is we want to set quickly a background color to our safe area view. So let's take in props and let's say props.theme.colors.primary. And let's go see. This may not be the correct one. The color white is UI.bg.primary. Colors.bg.primary. And this will set the background color of the safe area view to white so that everything looks uniform. A little edit goes a long way. Okay, so now if we log out, what we can see here is that once our background screen loads, and don't worry, once we build a production build, it will go faster, it will load faster. This is because it's a development build currently. Now, what we can see here is no watermelon. Well, that's because we need something called Lottie. And so if we look up Lottie React Native, what we're going to see here, and we look that up for Expo, if we look up Lottie in Expo documentation, what we can see is Expo includes support for Lottie, the animation library from Airbnb. And so what we need to do here is Expo install Lottie React Native. But before we do that, let's look at what Lottie is. Lottie is a easily add high quality animation to any native app. So it's an animation library that basically Airbnb built for iOS, Android, React Native to render After Effects animations and allow the app to use the animations easily. So anytime you create anything in After Effects, you can basically utilize that and utilize that effect in your React Native, Android, and iOS app. And so we want to quickly show you how you can integrate that in your app fairly easily. So first off, we're going to Expo install Lottie React Native. And let's go over here to our command line. And once we do that, what we can do is open up a new one, and we can render out, or we can run the Expo install Lottie React Native command. And so that's going to start installing Lottie React Native, which is what we need in order to build our Lottie view. Okay, now that we're doing that, well, Mo, what is Lottie React Native going to look like? Well, if we go look at Lottie React Native, what we can see is that there is a GitHub page for Lottie React Native that is basically going to allow us to understand how to integrate this properly. Lottie is a component for React Native, iOS, and Android. It's a mobile library that parses Adobe After Effects animations exported to JSON and renders them natively on the mobile. Now, we've already gone through the Expo installation, but basically what we want to look at here is they have some examples down here. Some examples of things you can render. And over here you can see, here is our little kind of animation of a watermelon that we want to take and utilize and see how we integrate it. So if we go to example and we go to example and we go to JS, and then we kind of look at the animations, we can see here that there's a watermelon.json. And this watermelon.json is the thing that we want to copy from Lottie React Native. If we go over to our assets folder and we say watermelon.json and we quickly add that in, what we'll be able to do here is once we reload, we'll have our watermelon JSON. And once it's done installing Lottie React Native and we run our app again, what we can do is we can start integrating that particular Lottie feature. Now let me show you how to do that. What we need to do is we need to go over here to our login screen. And once we're on our login screen, what we need to basically pull in is the Lottie view from Lottie React Native. Actually, we need to be on our account screen, not our login screen. We could add the watermelon to the login screen, but we want it to be the first animation you see when you come in. So, and we don't want to subsequently show it everywhere. So what we want to import is Lottie view from Lottie React Native view. And then what we're going to do is we're going to put in a Lottie view right above MealsToGo. And that Lottie view is going to have the key animation. We're going to put it on autoplay. We're going to put it on loop. We're going to put the resize mode to cover, and we're going to give it watermelon.json. And once we do that, what we're going to see here is that, it threw an exception trying to identify a read-only property. So let's just see and make sure that our assets are being imported correctly. And so they are. And so if we reload here, let's just make sure, there it is. There is our watermelon. It's a bit big, isn't it? It's a bit big, but it looks great. And so what we want to do here is we basically want to wrap it in something called an animation wrapper. And this is something we're going to create in our account styles, or we can create it locally. I feel like we should create it locally since it's something that's only going to live in this file. And we basically need it for this particular file only. So let's go ahead and take this animation wrapper, and we need to close the tag like this, obviously. Once we grab that, what we can do is we can define const animation wrapper is equal to styled.view, and then we'll go ahead and, well, maybe we should put it inside of the styled components because we already have styles defined there. So it's best to bundle everything together. Let's do export const animation wrapper view equals styled.view, and then let's go ahead and determine what styles this needs. So if we look at this from the perspective of how it's going to render on the screen, well, obviously we want it to have a width of 100% because we want it to fill the screen, but we don't necessarily want the height to be all that crazy. So let's give that a 40 percentile. And then let's say that the position should be absolute because we don't want it to take into account flex positioning. We just want to render it on a specific portion of the screen. And then we'll say top 30 pixels. And we'll say padding. And we'll say prop spacing 2. We'll take this over here. We'll put that there. And then let's see what happens. Oh, that looks perfect. That is so ideal. Look at where it's positioned. Absolutely amazing. And it was that simple to integrate a whole effect into our login screen. No effort at all. We just had to install a library. Okay, granted, creating the After Effects effect is something that may require some effort, but there are places on the internet where you can pull After Effects effects in JSON file. And as long as you have those After Effects, you can just take those, you can dump those inside of a Lottie view as a JSON file, and they will render on the screen. They will render out. And doesn't this look amazing? Doesn't this just add a certain wow factor to our app? It's absolutely amazing. And it was that simple. Now we've reached the final part, and one of the final features that we'll be building for the main flow of MealsToGo. That is the settings flow. Now when we log in, whenever we log into our account, what we want to do is, once we're logged in, well, we're able to search for specific cities, we're able to view our favorites, and we're even able to view our map view with our specific highlighted dialogues. But now our settings panel is kind of bleak. It's kind of bleak. And so we need to make it look a bit nicer. And in order to do that, what we're going to do is we're going to build out an entire settings panel where we will be able to view our favorites and also log out. All right, so let's get to it. Now that we're taking a deeper look at our settings screen, the very first thing we need to look at is our app navigator. Because in our app navigator, we initially made the decision that our settings screen was going to be a function that lives inside of the app navigator. Now that's not the place where we want this feature to live, of course. When we move over to the features folder, what we want to do is we want to create a settings folder. And this settings folder is going to contain, again, screens and components. And with that, it will be able to create the perfect integration for our settings feature into the navigator. Now, the very first file we need to create is settings.screen.js. And in that settings.screen.js, we need to move from the app navigator our component. So we'll take settings from over here and we'll move it into here. We'll add an export and we'll call it settings screen. And we'll need to move a couple of imports as well. So we'll move this, the text and the button, and we'll move it all in here. And what we'll do as well is move the React in the use context, which we'll need at the top of the file to begin with. And with that, now we have our settings screen up and running, ready to go. But what we need to do now is we also need to create the proper integration point over here, which is settings screen. And for that, what we need to do is we need to import settings screen from features, settings, screens, settings screen.js. And so now what we'll see is that, oh, our component isn't rendering. So if we dismiss all the errors and we quickly reload, what we'll see over here is that it should technically load. If we go over here to our node, what we'll see is that unable to resolve ... components utility safe area. So one of our imports in here is failing because the imports haven't been addressed to point to the proper path. So what we need to do here is say ... components, add one more, add here a ... and by doing that, we should now be able to render out the proper path. So if we go over here and we go to settings, what we can see is we're rendering the same exact setting screen that we had before. But now we need to make it look nice, don't we? So how are we going to do that? Well, first of all, let's remove button and text because that's not what we want to do in here. And we'll remove button and text from here as well. We'll leave our onLogout function in our use context. And what we want to do is we want to import list from React Native Paper because that is what we're going to be using in order to build up our screen. So we'll import list from React Native Paper. And basically we're going to compose our screen from both sections and items. And so what we're going to do is we're going to put together a section here where we do list.section and we'll close the tag list.section. And inside of there, we're going to put two list items. We're going to put our logout item that is going to look something like this. So on logout, we're going to put some padding temporarily over here. And then we're also going to put our favorites icon over in here, right there. And so with that, we should be able to render out the favorites. Now, do we actually have a favorites route? Huh, that's peculiar. Well, first off, let's take in navigation over here because setting screen should be getting navigation. And navigation.navigate favorites. Well, if we go look at our app navigator, we're loading in settings screen. Oh, maybe we need a settings navigator. That's what we need, a settings navigator. That's what we need because, as we can see, settings is going to contain multiple views. So what we'll set up in here is a specific settings.navigator.js. And in that settings navigator is where we're going to put the code for our settings screens. Now, if we look at how we've built navigators in the past, first of all, we need React. We're also going to import useEffect. And then we're going to import both the create stack navigator and the card interpolator styles for us to determine how we're going to render out these cards. Then what we'll do is we'll render out the settings navigator, and that will return the actual settings navigator, which we need to create a settings stack for in order for that to work. Then we'll create our settings stack.navigator, and we'll close off that opening point. And as we can see here, we're going to put header mode to screen. So we're going to have headers for these specific screens. This is because we want to see the title of the screen. And then we're going to have a settings stack where we put in both our settings, which is going to be linked to settings screen, and then eventually our favorites screen where we're going to show our favorites, because we can currently see our favorites in the favorites bar, but we also want to see them in a list view. And we're going to be able to access that from settings. So first off, we're going to go and import the settings screen inside of here. And then for now, we're going to render out null here. And what we're going to do is we're going to use, well, we don't currently need the useEffect because we don't need to integrate that just yet. So what we'll have over here is our settings stack with our current settings screen, and then we'll look at building out the rest of the screen later on. Okay, so now that we know that we have favorites, the thing we need to do in the app navigator is we need to import the settings navigator from /settings.navigator. And let's take this import. And so now we got it all set up. And if we go over to our app, we go over to the settings screen. Oh, what did I do? Whoops, did I not export the component? Nope, that's exported. What about here? Oh, that's exported. So settings navigator is exported. And oh, probably this null. So we want that to be a function value. And then we have an inline component. So over here, now we can see that we have favorites and log out. And by adding both of those features, now we can log out of the app. We can also log back into the app. And what we should do now is we should look at how we're supposed to build out this features function. What is it going to look like? But we should also look at prettying up this screen a bit because it's a bit bland with just these two options. So let's look at both of those integrations and feature improvements. So first and foremost, we want to polish this screen a bit more. And in order to do that, let's go ahead and let's import styled from styled components /native. And what we're going to do here is we're going to say export const settings item. We don't need to export. Let's just say const settings item is equal to styled. And let's take list.item, which we're going to style specifically with the padding that we require over here, which is a padding of 16 all around, which means we're going to take the props and we're going to say props.theme.space, and we'll say maybe 3. 3 sounds about right. And by doing that, now we can replace list.item with setting.item. Now, we only want to replace the ones in the list, so that means these two. And that means we can also replace these two lines, no longer needed because they're done over here. Now with that, we've cleaned up our implementation. And the next thing we need to do is, it'd be nice to have an avatar to kind of show that this is the user page. So let's import avatar from React Native Paper. And what we can do here is right above the list section, I want to put an avatar icon of 180 of a human. And let's give it a background color blue. And what we can see over here is, oh, that looks great. It's just not really centered, is it? Doesn't really look like it's in the right spot. So what we're going to do is we're going to say const avatar container is equal to styled.view. And what we're going to say here is that the align items of this view is going to be set to center. And we're going to take that avatar container, we're going to wrap that around the avatar icon. And by doing that, we should now have centered our avatar icon. Beautiful. Now, the one more thing we want to do is we want to grab user from here, because I would like for us to render some text. So let's go ahead and import text from settings, components, typography, and then we'll say text.component, and we'll do a, underneath the avatar, potentially, we'll do a spacer. Let's also import a spacer. Spacers are great. So let's import spacer from spacer component. And let's do a spacer of the position equaling top and the size equaling large. And let's do that for a typography text where we're going to be rendering out the email of the user. So let's say text here. Let's say variant is equal to caption. And by doing this, what we're going to be allowing us to do is render out the user.email. So on the user, there should be an email profile. And now if we open up our app, oh, the email's right there. So why isn't that rendering in the right spot? Well, we should put that inside of the avatar container so that it's also rendered inside of the center. Amazing. Caption is a bit small, so how about we use label? And we can test out, we can try things out. That looks much, much better. And now favorites is over here, which is rendering nothing currently, and the logout feature works. Great. So now we've gone through and cleaned up our settings interface, and it looks much, much more professional by doing this. Now it says you've passed an inline function for the favorites, which is our render null over here in our settings navigator. And in the next video, what we're going to do is we're going to build out our favorites screen. Now that we're pretty much set up to build out the rest of the settings interface, the last thing that we need to do is build out a nice interface for the favorites screen that is going to render inside settings. And in order to do that, what we're going to do is we're going to build out the favorites screen. And this is going to come from the same place that settings screen comes from, which is the screens of settings, but we're going to call it favorites. And so there's going to be a favorites.screen that we're going to create here. favorites.screen.js. And we're going to import React from React. So let's go ahead and do that. Import React from React. And we're going to export const favorites screen. And that's going to equal the render out right now of null. So let's do that. So it's going to be the exact same. And let's go back to settings navigator, and it has to be favorites.screen. Now, if we go over here and we go to favorites, again, rendering null. What we want it to render though, and this is a short exercise just on reusability, we want it to render something equivalent to this list view. The exact same type of list view that we're rendering for restaurants. Exact same layout, exact same format, exact same item. We want it to do that with the favorites array. Not with all of the restaurants, strictly with your favorites. Now, for this exercise, I want you to go look at the implementation over here, see which parts are reusable, potentially reach the flat list and all of these other things that we've learned, and try to build out the list in a way that you can view it over here. Now, in the next video, we'll look at the model solution. Now, this doesn't mean that the way that you solve it is incorrect, or that you cannot do it in different ways. It is completely valid to gain an interface and build it out in the way that you see it. However, the model solution reaches to my knowledge and my expertise in the way that I view it in terms of how I would solve it. That doesn't mean that your implementation is wrong in any way, shape, or form. All right, so here I'm going to show you how I would have built a favorite screen. I hope you all got a version working that works for you. However, this is the model solution. This is how I would have done it. That doesn't mean that there aren't different ways, but I would have said const favorites is equal to the use context of the favorites context. So we would have pulled in the favorites context, and we would have done that from import favorites context from ... services favorites, and then the favorites context. and that would have given us access to our favorites. At that point, I would have said, if favorites.length, we're going to return something. Otherwise, we're going to return something else. And the something else we're going to return is, first of all, let's import the safe area. And let's import text as well. And then we're going to render out in the safe area is a text where we say, if you do not have favorites yet, we're going to render out no favorites found yet. But if you do have a length, let's just put that to null real quick, right? Over here, we're saying, well, align item center, justify content center. So we're going to need a styled component here in order to make this a bit nicer. Styled from styled components / native. And we're going to call this favorites area. Const favorites area is equal to styled, and let's call that area. Let's take in the safe area view. Let's add onto it, and let's say align items center, and let's say justify content center. And by doing this, we can now put in favorites area. Let's remove the style over here. And by doing this, we can put favorites area here. Great, no inline styles. What do we render though if it has a length? Well, that's a good question. Let's take our safe area then at that point, because we want to render out a safe area. We don't need to align anything. And let's say safe area. You know what? Let's call favorites area no favorites area. Let's say no favorites area. Let's call that, because it's only when you have no favorites. So when you have favorites, we're going to render out a safe area. And what we're going to do is we're actually going to import our restaurant list component. What is that component actually? Well, let's go look at restaurants and let's go look at the components. And so what we had inside of our restaurant screen was a restaurant list that came from the restaurant list component that was a flat list, correct? So we used a flat list with a content container inset. All right, so now we need to reuse this. How are we going to reuse it? Well, we can export it, but we kind of want to put it somewhere nice, right? So let's go over here. So we have restaurant info cart styles. So let's create a new file called restaurant list.component.js. And although it's a styled component, we're still going to call it a component because it's going to be reused in that way. We could also call it .styles. Maybe we should call it .styles to be consistent. So let's do .styles. And let's say export const restaurant list, and then let's import styled from styled components / native. And then let's import flat list from React Native. You could also do style.flatlist. And by doing this, now we can go and say restaurant list is the import restaurant list from ... components / restaurant list styles. And now inside of our favorite screen, what we can say is import restaurant list from ... and then again ... We'll go to restaurants, we'll go to components, we'll go to restaurant list styles. And with this component, now we will build our view here. So we'll say the same thing that we did over in the restaurant screen. So where the restaurant list is, we're going to do the exact same thing. We're going to copy this entire implementation from line 49. So we'll copy that and we'll go back to our favorite screen. And this is basically what we need right here. So what else do we need? Well, we need touchable opacity. So we're going to import touchable opacity from React Native. And then once we have that, now we need our restaurants. So what else do we need here? Well, we need to use the context for the restaurants from the restaurants context. So let's do that, restaurants context. And we're going to import the restaurants context from the services restaurant. So restaurants context from services restaurants / restaurants.context.js. And once we have that one in there, now we can grab all of our restaurants And what else are we missing? Well, we need navigation, so our favorite screen is going to pull in navigation. And then what we need is our spacer, so we're going to pull in our spacer from /spacer, spacer.component, kind of building it up correctly. And then we can pull in our restaurant info card. So we're going to do restaurant info card, and we're going to go here to the end. We're going to delete this part. We're going to say restaurant info card.component.js. Now we've built up our favorite screen based on features that we built for the restaurant screen. So we're reutilizing code in a proper way to build out a feature quickly and safely. Now it says favorites has already been declared. What exactly is going on here? Oh, this hasn't been refreshed properly. So let's just restart this. And once we restart it, what we should be able to see is, first of all, if we have any imports that are incorrect. So import safe area component. So let's go look at that. Is our safe area coming from the right spot? So let's just /components/safe area. And this is in the favorites screen. So let's just reload this real quick. Unable to resolve ... components. So let's just make sure that this is the correct path. And let's do this. ... components /utility /safe area.component. And once we do that, let's reload here. And we should be good to go. Once we go to our settings screen and we load our favorites, now we can see all of our favorites over here. Or can we? Oh, I copied a bit too much code. Like I said, we didn't need to load the restaurants, so we actually didn't need the restaurants context. And this can happen when you copy code. You have to be very aware of what your data source is. And so now when we swap it out and we go to settings, now we're rendering out our favorites. And if we go back here and we quickly add one, what we can see over here is it's been added to the list. So always make sure that your data source is correct and that you're pulling the correct information into your list. Because as you can see, when I'm copy pasting code between features, it's very easy to have a slight oversight. Line 24 caught me. In my overview here, in my feature overview of favorites, I was loading the entire list of restaurants, not just the favorites. But with a quick swap, we now have the correct implementation. And it goes back to the restaurant view and it shows you the detail page. Amazing. So looking at this now, we have a fully featured application. We can view our favorites, we can log out, we can log in, we can register, we can view a map view of our restaurants, we can go into the detail view, we have the menus, we can see what they sell. All of that is a great feature. We can show our favorites bar here at the top that has a nice effect. We have the clearing of search and the syncing of search between the two places. We can search for Antwerp. And if we search for Antwerp over here, we're going to view Antwerp. If we log out, we have this cool watermelon that's going to pop out. When we register, we have the entire registration flow set up. We have manual back buttons we have all the features, every single thing you could think of. Absolutely amazing. Now, with that, you have built the majority of focus time. And now we can go and look at ways to extend functionality. Great job. Now that we've completed roughly the holistic setup of our application and have all of the main features ready to roll, what we need to do is look at our app and say, hey, could we polish this a bit more? And one of the things that I think about when I think about polish, well, I think about animations. And animations are very important because they are the cornerstone of what creates what is considered a great user experience. You see, stationary objects are kind of like, pops into view. It's not really a great feeling. Now, React Native provides two components. The animated component, which is granular and can allow you to kind of create very, very custom animations. And then there's the layout animations for global layout transactions. Now, if we look at the animated API versus the layout API, what I want us to do is kind of see, well, what can we do here? And if we see right over here, if we look at the fading in component, we can see that if we tap the play here, it will fade into view, and we can kind of look at what the code looks like. We have a fade animation that's a reference. This is a React reference. So they utilize that to reference an object and keep that reference memoized, so in memory. And we'll use something called the animated.timing to take the fade animation, which is currently at value 0, and transition it to value 1 over 10,000 milliseconds. And we'll call that the fade animation. And then we give that fade animation that value that's going to go from 0 to 1 over 10,000 milliseconds. We'll give it to the opacity. And by giving it to the opacity, what's going to happen is it's going to fade into view. Now, iOS is having a difficulty loading, but over here we can see it fading into view over 10,000 milliseconds, which is equivalent to 10 seconds. And so that slow fade that we're getting, that's what we want to achieve. We want to fade some views in to kind of create this non-stationary feel, this jankiness almost that, some apps can tend to have. So what we're going to do is in our animations folder, we're going to create a new folder called animations. And that folder is going to contain all of our animation type of components. And so you can expand on this and test out different animations. And so the animation we want to create is the fade animation.animation.js. And so you may have been thinking throughout the course, Mo, why do you use the dot animation, dot component, dot style? Well, that's basically for search purposes. If I were to go in my search here and I were to say dot component, now I can find all of my components that I'm looking for. Similarly, for my animation, I can quickly reveal all of the animations. And if I wanted to find all the screens, well, now I can see all the screens. And the same is true for if I wanted to find m.screen. Oh, okay, now I can fuzzy search map.screen, and I can kind of navigate my code base in a smarter way. With that, now let's look at kind of how we're going to build out this animation. So there's two things we need to do. Well, we need to import the animated API from React Native, and we're going to have a ref and also import React as we always do. Then we're going to export the const fade in view, which is going to be the name of our animation here. And we're going to give it a duration standard of 1.5 seconds or a second and a half. Then what we'll do is we'll return the animated.view, similar to what they were doing on the documentation. And we're going to do the same type of fade in where we're going to give it to the opacity. So we're going to bind the opacity to the animated value. And this is the special animated view. And with this, we can basically now say, well, we can animate something into the view. Now we have to use animated.view because it's a special type of view that is animatable. So animated, just like styled components, is exporting a view that has extra properties on it to allow it to be animated. And we'll wrap things with this fade in view in order for them to start fading in. Now you can see here, we still need to declare our fade animation, which we're going to do like this. We're going to say const fade animation is equal to useRef of a new animated value 0.current. And then we're going to also put in place a use effect that is going to allow us to transition that value from 0 to 1. And by doing this, we can then allow the animated hook to animate itself, but we also need to add in duration just in case if duration were to change as a prop, that we re-trigger the effect to properly interact. Okay, so now that we have our fade animation, well, where are we going to put it, Mo? Well, we could put it in a bunch of places. We could put it around a ton of different things. I was thinking, for instance, if we go into, well, let's say we go to our actual features and we said on the screens, well, we have restaurants.screen here. We could easily import a fade animation over here. First of all, let's get rid of our flat list here. Get rid of some of the errors. And what we can do is, next to importing safe area, we can import fade in view. And we can import that from the animations. So what we have to do is remove this component / animation / fade. And by importing the fade in view, now we can wrap it inside of our safe area to fade in the entire view. And if we go look at that, if we go to restaurants, well, what's happening? Well, let's reload quickly. And what we'll see here is, oh, you can see that fade into view, but it's kind of breaking the rest of the animations. So maybe we shouldn't put it right there, but maybe we should rather put it specifically around our restaurant list so that our restaurant list will fade into view. Because we don't want our animation to break the rest of our application. And by doing this, we now allow ourselves the room to create that animation effect without breaking the rest of the UI. So as we can see here, now our animation list, oh, it didn't fade into view, did it? Well, why is that? Well, it's because the fade into view has actually already rendered at this point. So how do we go about this? Well, maybe we should put it a level deeper. Maybe we should put it around the restaurant info card. So let's try that. If we put it around the restaurant info card, will that affect the restaurant info card? Let's see. So let's put it around here. And by doing this, oh, okay. Now the fade animation is coming in and every single card itself is fading itself into view, which creates this pleasing effect of it coming in. And where you put the animation, this is why I wanted to showcase this, where you put the animation may affect whether or not it occurs, whether or not it breaks other things in the layout. So picking the right spot is fairly important. And if we go over here to settings, we can put it in a bunch of different spots. But basically what we want to achieve here is the ability for you to be able to use this fade into view and put it in certain places to create that aesthetic. Now with that, we've created a lot of polish to our application because the main feature that you are greeted with as a user now has this aesthetically pleasing thing where it comes into view and you have this nice effect guiding you into the restaurant list. And that feeling, that user experience is extremely important for keeping users engaged. Okay, so now that we have that in place, what else do we need to do? Well, do we have any errors? Do we have any linting errors? Doesn't seem like it. So with that, we've now added a very good level of polish to our application. One of the final steps of polish is kind of looking at our app holistically and looking at the configuration that is currently in the app. And if we do that, we can quickly see that our app is lacking a proper splash screen, as well as when we go over to the home, what we can see here is that no icon is loading. This is the icon, the app icon, that the app will load both on Android and iOS if you were to release it on the App Store. So currently we don't have any of that. Now, we did put together some icons for you, some ZTM icons, but you could create whatever icon you like, as well as a splash screen. And if we go over here to assets, well, what we want to do is we want to get rid of our adaptive icon because that's not something that we want. And we also want to get rid of the favicon. And once we do that, then we'll get rid of, what does the home background look like? That's correct. The icon, we don't need that. All of these things kind of give us a bad user experience. So we want to make sure that we clear it out. And then what we'll do is we'll pull in icon at 2x and icon at 3x and the splash PNG, pull that into our assets. And if we go to our app.json, what we'll see here is adaptive icon will now be icon.png. And we'll make sure that that's correct, icon.png. We'll remove our web clause because we don't really need that. We're not focusing on the web. The support tablet set to true. Splash.png, icon.png, the orientation's portrait. And so if we save that, what we'll see is that when we go home and we load the app now, it's loading our splash screen. As well as if we go to home and we were to refresh this list, well, clearly it still doesn't have the icon. So something is still caching. And if we refresh our Expo app, now we can see that MealsToGo has the Zero to Mastery logo, as well as the splash screen. You can create whatever splash and logo you prefer, but it's a little bit of polish that you have to be aware of that can be configured for you. And it adds that extra bit of finish to your application. Now you may be asking yourself, Mo, now that I've developed this app, well, I basically need to be in development mode in order to show it to anyone. I can't really run it outside of my house. I need to be on my computer at all times. It's really quite bothersome. How do I go about this? And so that's a great question, because one of the things that happens here is that you may be in the process of making an app, but you don't want to publish it to the store yet so it's publicly available, but you do want to show your friends and family potentially what's going on your phone. In order to do that, let's go over to the terminal here. And one of the commands that we need to know is something called expo publish. And if we go to the expo help section and we scroll up here, it kind of becomes unreadable, but over here we can see publish, deploy a project to expo hosting. So this will allow us to deploy a project directly to expo. And if we run expo publish, if we're not logged in, obviously it'll ask us to log in, but you should do expo login to your account. And what expo publish is going to do is it's going to publish a built version of your application, all the assets, to your account. And so if we go in here and we sign into our account, which for me is Mobini, and if I grab my expo password and paste it in here and we sign in, what I'll be able to see is I'll be able to see a MealsToGo app over here with SDK 30. I have two because I've been testing out, but this is the one that we've recently published. And if we go over to the Expo website, what we'll see over here is a project. And this project is the MealsToGo project. It's the project that we've been working on. And over here, it clearly states that I am the owner. Currently, there are no builds because we have run no builds. We've just published our project for our own consumption. And over here, we can see the Expo URL. And what that will show us is going to be our project page. And currently it's not publicly visible, but you could make the project publicly visible to everyone. Now, one thing to note here is that these published projects, they will not open on iOS unless you are logged into the account that is the owner of this project. So if you want to share this project with multiple iOS users, it will not work. Android users, I believe, should be able to open this QR code just fine, but just note that there's a limitation here for the published project to only be accessible to your account. And if we open that up, what we're going to see is our application loading perfectly fine with all of the things that we put in place, and we can log out. We can see our animation pop up here, and it's absolutely amazing.